Section 26 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 2, Chapter 7. Examination of some opinions opposed to the preceding doctrines. Parts 1 through 3. Part 1. Polemical discussion is foreign to the plan of this work, but an opinion which stands in need of much illustration can often receive it most effectually and least tediously in the form of a defense against objections, and on subjects concerning which speculative minds are still divided. A writer does but half his duty by stating his own doctrine, if he does not also examine and, to the best of his ability, judge those of other thinkers. In the dissertation which Mr. Herbert Spencer has prefixed to his, in many respects, highly philosophical treatise on the mind, he criticizes some of the doctrines of the two preceding chapters, and propounds a theory of his own on the subject of the first principles. Footnote: Principles of Psychology. End footnote. Mr. Spencer agrees with me in considering axioms to be simply our earliest inductions from experience, but he differs from me widely as to the worth of the test of inconceivableness. He thinks that it is the ultimate test of all beliefs. He arrives at this conclusion by two steps. First, we never can have any stronger ground for believing anything than the belief of it invariably exists. Whenever any fact or proposition is invariably believed, that is, if I understand Mr. Spencer rightly, believed by all persons and by oneself at all times, it is entitled to be received as one of the primitive truths, or original premises of our knowledge. Secondly, the criterion by which we decide whether anything is invariably believed to be true is our inability to conceive it as false. Quote, the inconceivability of its negation is the test by which we ascertain whether a given belief invariably exists or not. End quote. Quote, for our primary beliefs, the fact of invariable existence, tested by an abortive effort to cause their non-existence, is the only reason assignable. End quote. He thinks this the sole ground of our belief in our own sensations. If I believe that I feel cold, I only receive this as true because I cannot conceive that I am not feeling cold. Quote, while the proposition remains true, the negation of it remains inconceivable. End quote. There are numerous other beliefs which Mr. Spencer considers to rest on the same basis, being chiefly those, or a part of those, which the metaphysicians of the Reid and Stuart school consider as truths of immediate intuition. That there exists a material world, that this is the very world which we directly and immediately perceive, and not merely the hidden cause of our perceptions, that space, time, force, extension, figure are not modes of our consciousness, but objective realities, are regarded by Mr. Spencer as truths known by the inconceivableness of their negatives. We cannot, he says, by any effort conceive these objects of thought as mere states of our mind, as not having an existence external to us. Their real existence is, therefore, as certain as our sensations themselves, the truths which are the subject of direct knowledge being, according to this doctrine, known to be truths only by the inconceivability of their negation, and the truths which are not the object of direct knowledge being known as inferences from those which are, and those inferences being believed to follow from the premises only because we cannot conceive them not to follow. Inconceivability is thus the ultimate ground of all assured beliefs. Thus far, there is no very wide difference between Mr. Spencer's doctrine and the ordinary one of philosophers on the intuitive school, from Descartes to Dr. Whewell. But at this point Mr. Spencer diverges from them, for he does not, like them, set up the test of inconceivability as infallible. On the contrary, he holds that it may be fallacious, not from any fault in the test itself, but because, quote, men have mistaken for inconceivable things some things which were not inconceivable, end quote. And he himself in this very book denies not a few propositions usually regarded as among the most marked examples of truths whose negations are inconceivable. But occasional failure, he says, is incident to all tests. If such failure vitiates, quote, the test of inconceivableness, end quote, it, quote, must similarly vitiate all tests whatever. We consider an inference logically drawn from established premises to be true. Yet in millions of cases men have been wrong in the inferences they have thought thus drawn. Do we therefore argue that it is absurd to consider an inference true on no other ground than that it is logically drawn from established premises? No, we say that though men may have taken for logical inferences that were not logical, there nevertheless are logical inferences, and that we are justified in assuming the truth of what seems to us such until better instructed. Similarly, though men may have thought some things inconceivable which were not so, there may still be inconceivable things, and the inability to conceive the negation of a thing may still be our best warrant for believing it. Though occasionally it may prove an imperfect test, yet, as our most certain beliefs are capable of no better, to doubt any one belief because we have no higher guarantee for it is really to doubt all beliefs. End quote. Mr. Spencer's doctrine, therefore, does not erect the curable, but only the incurable limitations of the human conceptive faculty into laws of the outward universe. Part 2. The doctrine that, quote, a belief which is proved by the inconceivableness of its negation to invariably exist is true, end quote, Mr. Spencer enforces by two arguments, one of which may be distinguished as positive and the other as negative. The positive argument is that every such belief represents the aggregate of all past experience, quote, conceding the entire truth of, quote, the quote, position that during any phase of human progress the ability or inability to form a specific conception wholly depends on the experiences men have had, and that by a widening of their experiences they may, by and by, be enabled to conceive things before inconceivable to them. It may still be argued that as, at any time, the best warrant men can have for a belief is the perfect agreement of all pre-existing experience in support of it. It follows that, at any time, the inconceivableness of its negation is the deepest test any belief admits of. Objective facts are ever impressing themselves upon us. Our experience is a register of these objective facts, and the inconceivableness of a thing implies that it is wholly at variance with the register. Even were this all, it is not clear how, if every truth is primarily inductive, any better test of truth could exist. But it must be remembered that while many of these facts, impressing themselves upon us, are occasional, while others again are very general, some are universal and unchanging. These universal and unchanging facts are, by the hypothesis, certain to establish beliefs of which the negations are inconceivable, while the others are not certain to do this, and if they do, subsequent facts will reverse their action. Hence, if, after an immense accumulation of experiences, there remain beliefs of which the negations are still inconceivable, most, if not all of them, must correspond to universal objective facts. If there be certain absolute uniformities in nature, if these uniformities produce, as they must, absolute uniformities in our experience, and if these absolute uniformities in our experience disable us from conceiving the negations of them, Then, answering to each absolute uniformity in nature which we can cognize, there must exist in us a belief of which the negation is inconceivable, and which is absolutely true. In this wide range of cases, subjective inconceivableness must correspond to objective impossibility. Further, experience will produce correspondence where it may not yet exist, and we may expect the correspondence to become ultimately complete. In nearly all cases, this test of inconceivableness must be valid now." End quote. I wish I could think we were so nearly arrived at omniscience. Quote, "And where it is not, it still expresses the net result of our experience up to the present time, which is the most that any test can do." End quote. To this I answer, first, that it is by no means true that the inconceivability by us of the negative of a proposition proves all, or even any "pre-existing experience" to be in favour of the affirmative. There may have been no such pre-existing experiences, but only a mistaken supposition of experience. How did the inconceivability of antipodes prove that experience had given any testimony against their possibility? How did the incapacity men felt of conceiving sunset otherwise than as a motion of the sun represent any net result of experience in support of its being the sun and not the earth that moves? It is not experience that is represented, it is only a superficial semblance of experience. The only thing proved with regard to real experience is the negative fact that men have not had it of the kind which would have made the inconceivable proposition conceivable. Next, even if it were true that inconceivableness represents the net result of all past experience, why should we stop at the representative when we can get at the thing represented? If our incapacity to conceive the negation of a given supposition is proof of its truth, because proving that our experience has hitherto been uniform in its favour, the real evidence for the supposition is not the inconceivableness, but the uniformity of experience. Now this, which is the substantial and only proof, is directly accessible. We are not obliged to presume it from an incidental consequence. If all past experience is in favour of a belief, let this be stated, and the belief openly rested on that ground, after which the question arises what that fact may be worth as evidence of its truth. For uniformity of experience is evidence in very different degrees. In some cases it is strongly evidence, in others weak. In others it scarcely amounts to evidence at all. That all metals sink in water was a uniform experience from the origin of the human race to the discovery of potassium in the present century by Sir Humphry Davy. That all swans are white was a uniform experience down to the discovery of Australia. In the few cases in which uniformity of experience does amount to the strongest possible proof, as with such propositions as these, two straight lines cannot enclose a space, every event has a cause, it is not because their negations are inconceivable, which is not always the fact, but because the experience which has been thus uniform pervades all nature. It will be shown in the following book that none of the conclusions either of induction or of deduction can be considered certain, except as far as their truth is shown to be inseparably bound up with truths of this class. I maintain then, first, that uniformity of past experience is very far from being universally a criterion of truth. But secondly, inconceivableness is still further from being a test even of that test. Uniformity of contrary experience is only one of many causes of inconceivability. Tradition handed down from a period of more limited knowledge is one of the commonest. The mere familiarity of one mode of production of a phenomenon often suffices to make every other mode appear inconceivable. Whatever connects two ideas by a strong association may, and continually does, render their separation in thought impossible, as Mr. Spencer in other parts of his speculations frequently recognizes. It was not for want of experience that the Cartesians were unable to conceive that one body could produce motion in another without contact. They had as much experience of other modes of producing motion as they had of that mode. The planets had revolved and heavy bodies had fallen every hour of their lives, but they fancied these phenomena to be produced by a hidden machinery which they did not see, because without it they were unable to conceive what they did see. The inconceivableness, instead of representing their experience, dominated and overrode their experience. Without dwelling further on what I have termed the positive argument of Mr. Spencer in support of his criterion of truth, I pass to his negative argument, on which he lays more stress. Part 3. The negative argument is that, whether inconceivability be good evidence or bad, no stronger evidence is to be obtained. That what is inconceivable cannot be true is postulated in every act of thought. It is the foundation of all our original premises, still more it is assumed in all conclusions from those premises. The invariability of belief, tested by the inconceivableness of its negation, is our sole warrant for every demonstration. Logic is simply a systemization of the process by which we indirectly obtain this warrant for beliefs that do not directly possess it. To gain the strongest conviction possible respecting any complex fact, we either analytically descend from it by successive steps, each of which we unconsciously test by the inconceivableness of its negation, until we reach some axiom or truth which we have similarly tested, or we synthetically ascend from such axiom or truth by such steps. In either case, we connect some isolated belief with a belief which invariably exists by a series of intermediate beliefs which invariably exist." End quote. The following passage sums up the theory. Quote, "When we perceive that the negation of the belief is inconceivable, we have all possible warrant for asserting the invariability of its existence, and in asserting this we express alike our logical justification of it and the inexorable necessity we are under of holding it. We have seen that this is the assumption on which every conclusion, whatever ultimately rests. We have no other guarantee for the reality of consciousness, of sensations, of personal existence. We have no other guarantee for any axiom. We have no other guarantee for any step in a demonstration. Hence, as being taken for granted in every act of the understanding, it must be regarded as the universal postulate." End quote. But as this postulate, which we are under an "inexorable necessity" of holding true, is sometimes false, as "beliefs that were once shown by the inconceivableness of their negations to invariably exist have since been found untrue," and as "beliefs that now possess this character may someday share the same fate." The canon of belief laid down by Mr. Spencer is that "the most certain conclusion" is that "which involves the postulate the fewest times." Reasoning, therefore, never ought to prevail against one of the immediate beliefs, the belief in matter, in the outward reality of extension, space, and the like, because each of these involves the postulate only once, while an argument, besides involving it in the premises, involves it again in every step of the ratiocination, no one of the successive acts of inference being recognized as valid except because we cannot conceive the conclusion not to follow from the premises. It will be convenient to take the last part of this argument first. In every reasoning, according to Mr. Spencer, the assumption of the postulate is renewed at every step. At each inference we judge that the conclusion follows from the premises, our sole warrant for that judgment being that we cannot conceive it not to follow. Consequently, if the postulate is fallible, the conclusions of reasoning are more vitiated by that uncertainty than direct intuitions, and the disproportion is greater the more numerous the steps of the argument. To test this doctrine, let us first suppose an argument consisting only of a single step, which would be represented by one syllogism. This argument does rest on an assumption, and we have seen in the preceding chapters what the assumption is. It is that whatever has a mark has what it is a mark of. The evidence of this axiom I shall not consider at present. Let us suppose it, with Mr. Spencer, to be the inconceivableness of its reverse. Footnote. Mr. Spencer is mistaken in supposing me to claim any peculiar necessity for this axiom as compared with others. I have corrected the expressions which led him into that misapprehension of my meaning. End footnote. Let us now add a second step to the argument. We require what? Another assumption? No, the same assumption a second time, and so on to a third and a fourth. I confess I do not see how, on Mr. Spencer's own principles, the repetition of the assumption at all weakens the force of the argument. If it were necessary the second time to assume some other axiom, the argument would no doubt be weakened, since it would be necessary to its validity that both axioms should be true, and it might happen that one was true and not the other, making two chances of error instead of one. But since it is the same axiom, if it is true once, it is true every time, and if the argument, being of 100 links, assumed the axiom 100 times, these 100 assumptions would make but one chance of error among them all. It is satisfactory that we are not obliged to suppose the deductions of pure mathematics to be among the most uncertain of argumentative processes, which, on Mr. Spencer's theory, they could hardly fail to be, since they are the longest. But the number of steps in an argument does not subtract from its reliableness if no new premises of an uncertain character are taken up by the way. Footnote. Mr. Spencer, in recently returning to the subject, Principles of Psychology, New Edition, Chapter 12, The Test of Relative Validity, makes two answers to the preceding remarks. One is, quote, were an argument formed by repeating the same proposition over and over again, it would be true that any intrinsic fallibility of the postulate would not make the conclusion more untrustworthy than the first step. But an argument consists of unlike propositions. Now, since Mr. Mill's criticism on the universal postulate is that in some cases, which he names, it has proved to be an untrustworthy test, it follows that in any argument consisting of heterogeneous propositions, there is a risk, increasing as the number of propositions increases, that some one of them belongs to this class of cases and is wrongly accepted because of the inconceivableness of its negation. Unquote. No doubt, but this supposes new premises to be taken in. The point we are discussing is the fallibility not of the premises but of the reasoning, as distinguished from the premises. Now the validity of the reasoning depends always upon the same axiom, repeated, in thought, over and over again, that is, that whatever has a mark has what it is a mark of, even, therefore, on the assumption that this axiom rests ultimately on the universal postulate, and that, the postulate not being wholly trustworthy, the axiom may be one of the cases of its failure. all the risk there is of this is incurred at the very first step of the reasoning, and is not added to, however long may be the series of subsequent steps. I am here arguing, of course, from Mr. Spencer's point of view. From my own, the case is still clearer, for in my view the truth that whatever has a mark has what it is a mark of is wholly trustworthy, and derives none of its evidence from so very untrustworthy a test as the inconceivability of the negative. Mr. Spencer's second answer is valid up to a certain point. It is that every prolongation of the process involves additional chances of casual error from carelessness in the reasoning operation. This is an important consideration in the private speculations of an individual reasoner, and even with respect to mankind at large. It must be admitted that, though mere oversights in the syllogistic process, like errors of addition in an account, are special to the individual, and seldom escape detection, confusion of thought produced, for example, by ambiguous terms, has led whole nations or ages to accept fallacious reasoning as valid. But this very fact points to causes of error so much more dangerous than the mere length of the process, as quite to vitiate the doctrine that the test of the relative validities of conflicting conclusions is the number of times the fundamental postulate is involved. On the contrary, the subjects on which the trains of reasoning are longest, and the assumption, therefore, oftenest repeated, are in general those which are best fortified against the really formidable causes of fallacy, as in the example already given of mathematics. End footnote. To speak next of the premises. Our assurance of their truth, whether they be generalities or individual facts, is grounded, in Mr. Spencer's opinion, on the inconceivableness of their being false. It is necessary to advert to a double meaning of the word inconceivable, which Mr. Spencer is aware of, and would sincerely disclaim founding an argument upon, but from which his case derives no little advantage notwithstanding. By inconceivableness is sometimes meant inability to form or get rid of an idea, sometimes inability to form or get rid of a belief. The former meaning is the most conformable to the analogy of language, for a conception always means an idea and never a belief. The wrong meaning of inconceivable is, however, fully as frequent in philosophical discussion as the right meaning, and the intuitive school of metaphysicians could not well do without either. To illustrate the difference, we will take two contrasted examples. The early physical speculators considered antipodes incredible because inconceivable. But antipodes were not inconceivable in the primitive sense of the word. An idea of them could be formed without difficulty. They could be completely pictured to the mental eye. What was difficult, and, as it then seemed, impossible, was to apprehend them as believable. The idea could be put together of men sticking on by their feet to the underside of the earth, but the belief would follow that they must fall off. Antipodes were not unimaginable, but they were unbelievable. On the other hand, when I endeavour to conceive an end to extension, the two ideas refuse to come together. When I attempt to form a conception of the last point of space, I cannot help figuring to myself a vast space beyond that last point. The combination is, under the conditions of our experience, unimaginable. This double meaning of inconceivable it is very important to bear in mind, for the argument from inconceivableness almost always turns on the alternate substitution of each of those meanings for the other. In which of these two senses does Mr. Spencer employ the term when he makes it a test of the truth of a proposition that its negation is inconceivable? Until Mr. Spencer expressly stated the contrary, I inferred from the course of his argument that he meant unbelievable. He has, however, in a paper published in the 5th number of the Fortnightly Review, disclaimed this meaning and declared that by an inconceivable proposition he means, now and always, quote, one of which the terms cannot by any effort be brought before consciousness in that relation which the proposition asserts between them, a proposition of which the subject and predicate offer an insurmountable resistance to union in thought. End quote. We now therefore know positively that Mr. Spencer always endeavours to use the word inconceivable in this, its proper sense, but it may yet be questioned whether his endeavour is always successful, whether the other and popular use of the word does not sometimes creep in with its associations and prevent him from maintaining a clear separation between the two. When, for example, he says that when I feel cold, I cannot conceive that I am not feeling cold, this expression cannot be translated into, quote, I cannot conceive myself not feeling cold, quote, for it is evident that I can. The word conceive, therefore, is here used to express the recognition of a matter of fact, the perception of truth or falsehood, which I apprehend to be exactly the meaning of an act of belief, as distinguished from simple conception. Again, Mr. Spencer calls the attempt to conceive something which is inconceivable, quote, an abortive attempt to cause the non-existence, end quote, not of a conception or mental representation, but of a belief. There is need, therefore, to revise a considerable part of Mr. Spencer's language if it is to be kept always consistent with his definition of inconceivability. But in truth, the point is of little importance, since inconceivability, in Mr. Spencer's theory, is only a test of truth, inasmuch as it is a test of believability. The inconceivableness of a supposition is the extreme case of its unbelievability. This is the very foundation of Mr. Spencer's doctrine. The invariability of the belief is with him the real guarantee. The attempt to conceive the negative is made in order to test the inevitableness of the belief. It should be called an attempt to believe the negative. When Mr. Spencer says that while looking at the sun, a man cannot conceive that he is looking into darkness, he should have said that a man cannot believe that he is doing so, for it is surely possible in broad daylight to imagine oneself looking into darkness. Footnote. Mr. Spencer makes a distinction between conceiving myself looking into darkness and conceiving that I am then and there looking into darkness. To me, it seems that this change of the expression to the form I am just marks the transition from conception to belief, and that the phrase to conceive that I am, or that anything is not consistent with using the word conceive in its rigorous sense. End footnote. As Mr. Spencer himself says, speaking of the belief of our own existence, quote, that he might not exist he can conceive well enough, but that he does not exist he finds it impossible to conceive, end quote. That is, to believe. So that the statement resolves itself into this: that I exist and that I have sensations I believe, because I cannot believe otherwise. And in this case everyone will admit that the impossibility is real. Anyone's present sensations or other states of subjective consciousness, that one person inevitably believes. They are facts known per se. It is impossible to ascend beyond them. Their negative is really unbelievable, and therefore there is never any question about believing it. Mr. Spencer's theory is not needed for these truths. But according to Mr. Spencer, there are other beliefs relating to other things than our own subjective feelings, for which we have the same guarantees, which are, in a similar manner, invariable and necessary. With regard to these other beliefs, they cannot be necessary, since they do not always exist. There have been, and are, many persons who do not believe the reality of an external world, still less the reality of extension and figure as the forms of that external world, who do not believe that space and time have an existence independent of the mind, nor any other of Mr. Spencer's objective intuitions. The negations of these alleged invariable beliefs are not unbelievable, for they are believed. It may be maintained without obvious error that we cannot imagine tangible objects as mere states of our own and other people's consciousness, that the perception of them irresistibly suggests to us the idea of something external to ourselves, and I am not in a condition to say that this is not the fact, though I do not think anyone is entitled to affirm it of any person besides himself. But many thinkers have believed, whether they could conceive it or not, that what we represent to ourselves as material objects are mere modifications of consciousness, complex feelings of touch and of muscular action. Mr. Spencer may think the inference correct from the unimaginable to the unbelievable, because he holds that belief itself is but the persistence of an idea, and that what we can succeed in imagining we cannot at the moment help apprehending as believable. But of what consequence is it what we apprehend at the moment, if the moment is in contradiction to the permanent state of our mind? A person who has been frightened when an infant by stories of ghosts, though he disbelieves them in after years, and perhaps never believed them, may be unable all his life to be in a dark place, in circumstances stimulating to the imagination, without mental discomposure. The idea of ghosts, with all its attendant terrors, is irresistibly called up in his mind by the outward circumstances. Mr. Spencer may say that while he is under the influence of this terror, he does not disbelieve in ghosts, but has a temporary and uncontrollable belief in them. Be it so, but allowing it to be so, which would it be truest to say of this man on the whole, that he believes in ghosts, or that he does not believe in them? Assuredly that he does not believe in them. The case is similar with those who disbelieve a material world, though they cannot get rid of the idea, though while looking at a solid object they cannot help having the conception, and therefore, according to Mr. Spencer's metaphysics, the momentary belief of its externality. Even at that moment they would sincerely deny holding that belief, and it would be incorrect to call them other than disbelievers of the doctrine. The belief, therefore, is not invariable, and the test of inconceivableness fails in the only cases to which there could ever be any occasion to apply it. That a thing may be perfectly believable and yet may not have become conceivable, and that we may habitually believe one side of an alternative and conceive only in the other, is familiarly exemplified in the state of mind of educated persons respecting sunrise and sunset. All educated persons either know by investigation or believe on the authority of science that it is the earth and not the sun which moves. But there are probably few who habitually conceive the phenomenon otherwise than as the ascent or descent of the sun. Assuredly, no one can do without a prolonged trial, and it is probably not easier now than in the first generation after Copernicus. Mr. Spencer does not say, quote, "In looking at sunrise, it is impossible not to conceive that it is the sun which moves. Therefore, this is what everybody believes, and we have all the evidence for it that we can have for any truth." End quote. Yet this would be an exact parallel to his doctrine about the belief in matter. The existence of matter and other noumena, as distinguished from the phenomenal world, remains a question of argument, as it was before, and the very general, but neither necessary nor universal, belief in them stands as a psychological phenomenon to be explained either on the hypothesis of its truth or on some other. The belief is not a conclusive proof of its own truth, unless there are no such things as idolatribus. But being a fact, it calls on antagonists to show from what except the real existence of the thing believed, so general and apparently spontaneous a belief, can have originated, and its opponents have never hesitated to accept this challenge. Footnote: I have myself accepted the contest and fought it out on this battleground in the 11th chapter of An Examination of Sir William Hamilton's Philosophy. End footnote. The amount of their success in meeting it will probably determine the ultimate verdict of philosophers on the question. End of section 26. Section 27 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 2, Chapter 7. Examination of some opinions opposed to the preceding doctrines, Parts 4 through 5. Part 4. In the revision, or rather reconstruction, of his Principles of Psychology, as one of the stages or platforms in the imposing structure of his system of philosophy, Mr. Spencer has resumed what he justly terms the amicable controversy that has been long pending between us, expressing at the same time a regret, which I cordially share, that this lengthened exposition of a single point of difference, unaccompanied by an exposition of the numerous points of concurrence, unavoidably produces an appearance of dissent very far greater than that which exists. I believe with Mr. Spencer that the difference between us, if measured by our conclusions, is superficial rather than substantial, and the value I attach to so great an amount of agreement in the field of analytic psychology with a thinker of his force and depth is such as I can hardly overstate. But I also agree with him that the difference which exists in our premises is one of profound importance philosophically considered, and not to be dismissed while any part of the case of either of us has not been fully examined and discussed. In his present statement of the universal postulate, Mr. Spencer has exchanged his former expression, beliefs which invariably exist, for the following, cognitions of which the predicates invariably exist along with their subjects. And he says that, an abortive effort to conceive the negation of a proposition shows that the cognition expressed is one of which the predicate invariably exists along with its subject, and the discovery that the predicate invariably exists along with its subject is the discovery that this cognition is one we are compelled to accept. Both these premises of Mr. Spencer's syllogism I am able to assent to, but in different senses of the middle term. If the invariable existence of the predicate along with its subject is to be understood in the most obvious meaning as an existence in actual nature, or in other words, in our objective or sensational experience, I, of course, admit that this, once ascertained, compels us to accept the proposition. But then I do not admit that the failure of an attempt to conceive the negative proves the predicate to be always coexistent with the subject in actual nature. If, on the other hand, which I believe to be Mr. Spencer's meaning, the invariable existence of the predicate along with the subject is to be understood only of our conceptive faculty, that is, that the one is inseparable from the other in our thoughts, then, indeed, the inability to separate the two ideas proves their inseparable conjunction, here and now, in the mind which has failed in the attempt. But this inseparability in thought does not prove a corresponding inseparability in fact, nor even in the thoughts of other people or of the same person in a possible future. Quote, that some propositions have been wrongly accepted as true because their negations were supposed inconceivable when they were not, unquote, does not, in Mr. Spencer's opinion, quote, disprove the validity of the test, unquote, not only because any test whatever, quote, is liable to yield untrue results, either from incapacity or from carelessness in those who use it, unquote, but because the propositions in question, quote, were complex propositions not to be established by a test applicable to propositions no further decomposable, unquote. Quote, a test legitimately applicable to a simple proposition, the subject and predicate of which are in direct relation, cannot be legitimately applied to a complex proposition, the subject and predicate of which are indirectly related through the many simple propositions implied. That things which are equal to the same thing are equal to one another is a fact which can be known by direct comparison of actual or ideal relations. But that the square of the hypotenuse of a right-angled triangle equals the sum of the squares on the other two sides cannot be known immediately by comparison of two states of consciousness. Here the truth can be reached only mediately through a series of simple judgments respecting the likeness or unlikeness of certain relations. End quote. Moreover, even when the proposition admits of being tested by immediate consciousness, people often neglect to do it. A schoolboy, in adding up a column of figures, will say, 35 and 9 are 46, though this is contrary to the verdict which consciousness gives when 35 and 9 are really called up before it. But this is not done, and not only schoolboys, but men and thinkers do not always, quote, distinctly translate into their equivalent states of consciousness the words they use. End quote. It is but just to give Mr. Spencer's doctrine the benefit of the limitation he claims, that is, that it is only applicable to propositions which are assented to on simple inspection, without any intervening media of proof. But this limitation does not exclude some of the most marked instances of propositions now known to be false or groundless, but whose negative was once found inconceivable, such as that in sunrise and sunset it is the sun which moves, that gravitation may exist without an intervening medium, and even the case of the antipodes. The distinction drawn by Mr. Spencer is real, but in the case of the propositions classed by him as complex, consciousness, until the media of proof are supplied, gives no verdict at all. It neither declares the equality of the square of the hypotenuse with the sum of the squares of the sides to be inconceivable, nor their inequality to be inconceivable. But in all the three cases which I have just cited, the inconceivability seems to be apprehended directly. No train of argument was needed, as in the case of the square of the hypotenuse, to obtain the verdict of consciousness on the point. Neither is any of the three a case like that of the schoolboy's mistake, in which the mind was never really brought into contact with the proposition. They are cases in which one of two opposite predicates, mero adspectu, seem to be incompatible with the subject, and the other, therefore, to be proved always to exist with it. Footnote. In one of the three cases, Mr. Spencer, to my no small surprise, thinks that the belief of mankind cannot be rightly said to have undergone the change I allege. Mr. Spencer himself still thinks we are unable to conceive gravitation acting through empty space. Quote, if an astronomer avowed that he could conceive gravitative force as exercised through space absolutely void, my private opinion would be that he mistook the nature of conception. Conception implies representation. Here, the elements of the representation are the two bodies and an agency by which either affects the other. To conceive this agency is to represent it in some terms derived from our experiences, that is, from our sensations. As this agency gives us no sensations, we are obliged, if we try to conceive it, to use symbols idealized from our sensations, imponderable units forming a medium." End quote. If Mr. Spencer means that the action of gravitation gives us no sensations, the assertion is one than which I have not seen, in the writings of philosophers, many more startling. What other sensation do we need than the sensation of one body moving toward another? The elements of the representation are not two bodies and an agency, but two bodies and an effect, that is, the fact of their approaching one another. If we are able to conceive a vacuum, is there any difficulty in conceiving a body falling to the earth through it? End footnote. As now limited by Mr. Spencer, the ultimate cognitions fit to be submitted to his test are only those of so universal and elementary a character as to be represented in the earliest and most unvarying experience, or apparent experience, of all mankind. In such cases, the inconceivability of the negative, if real, is accounted for by the experience. And why, I have asked, should the truth be tested by the inconceivability, when we can go further back for proof, namely, to the experience itself? To this Mr. Spencer answers that the experiences cannot be all recalled to mind, and, if recalled, would be of unmanageable multitude. To test a proposition by experience seems to him to mean that, quote, "before accepting as certain the proposition that any rectilineal figure must have as many angles as it has sides," unquote, "I have," quote, "to think of every triangle, square, pentagon, hexagon, and so on, which I have ever seen, and to verify the asserted relation in each case." End quote. I can only say with surprise that I do not understand this to be the meaning of an appeal to experience. It is enough to know that one has been seeing the fact all one's life, and has never remarked any instance to the contrary, and that other people with every opportunity of observation unanimously declare the same thing. It is true, even this experience may be insufficient, and so it might be even if I could recall to mind every instance of it, but its insufficiency, instead of being brought to light, is disguised. If instead of sifting the experience itself, I appeal to a test which bears no relation to the sufficiency of the experience, but, at the most, only to its familiarity. These remarks do not lose their force, even if we believe with Mr. Spencer that mental tendencies originally derived from experience impress themselves permanently on the cerebral structure and are transmitted by inheritance, so that modes of thinking which are acquired by the race become innate and a priori in the individual, thus representing, in Mr. Spencer's opinion, the experience of his progenitors in addition to his own. All that would follow from this is, that a conviction might be really innate, that is, prior to individual experience, and yet not be true, since the inherited tendency to accept it may have been originally the result of other causes than its truth. Mr. Spencer would have a much stronger case if he could really show that the evidence of reasoning rests on the postulate, or, in other words, that we believe that a conclusion follows from premises only because we cannot conceive it not to follow. But this statement seems to me to be of the same kind as one I have previously commented on, that is, that I believe I see light, because I can not, while the sensation remains, conceive that I am looking into darkness. Both these statements seem to me incompatible with the meaning, as very rightly limited by Mr. Spencer, of the verb to conceive. To say that when I apprehend that A is B and that B is C, I cannot conceive that A is not C, is to my mind merely to say that I am compelled to believe that A is C. If to conceive be taken in its proper meaning, that is, to form a mental representation, I may be able to conceive A as not being C. After assenting with full understanding to the Copernican proof that it is the earth and not the sun that moves, I not only can conceive or represent to myself sunset as a motion of the sun, but almost everyone finds this conception of sunset easier to form than that which they nevertheless know to be the true one. Part 5. Sir William Hamilton holds as I do that inconceivability is no criterion of impossibility. Quote, "There is no ground for inferring a certain fact to be impossible merely from our inability to conceive its possibility. Things there are which may, nay, must be true, of which the understanding is wholly unable to construe to itself the possibility." End quote. Footnote. Discussions and so on, 2nd edition, page 624. End footnote. Sir William Hamilton is, however, a firm believer in the a priori character of so many axioms, and of the sciences deduced from them, and is so far from considering those axioms to rest on the evidence of experience, that he declares certain of them to be true even of noumena, of the unconditioned, of which it is one of the principal aims of his philosophy to prove that the nature of our faculties debars us from having any knowledge. The axioms to which he attributes this exceptional emancipation from the limits which confine all our other possibilities of knowledge, the chinks through which, as he represents, one ray of light finds its way to us from behind the curtain which veils us from the mysterious world of things in themselves, are the two principles which he terms, after the schoolmen, the principle of contradiction and the principle of excluded middle. The first, that two contradictory propositions cannot both be true. The second, that they cannot both be false. Armed with these logical weapons, we may boldly face things in themselves and tender to them the double alternative, sure that they must absolutely elect one or the other side, though we may be forever precluded from discovering which. To take his favourite example, we cannot conceive the infinite divisibility of matter, and we cannot conceive a minimum or end to divisibility, yet one or the other must be true. As I have hitherto said nothing of the two axioms in question, those of contradiction and of excluded middle, it is not unseasonable to consider them here. The former asserts that an affirmative proposition and the corresponding negative proposition cannot both be true, which has generally been held to be intuitively evident. Sir William Hamilton and the Germans consider it to be the statement in words of a form or law of our thinking faculty. Other philosophers, not less deserving of consideration, deem it to be an identical proposition, an assertion involved in the meaning of terms, a mode of defining negation, and the word not. I am able to go one step with these last. An affirmative assertion and its negative are not two independent assertions connected with each other only as mutually incompatible. That if the negative be true, the affirmative must be false, really is a mere identical proposition, for the negative proposition asserts nothing but the falsity of the affirmative, and has no other sense or meaning whatever. The principium contradictionis should therefore put off the ambitious phraseology which gives it the air of a fundamental antithesis pervading nature, and should be enunciated in the simpler form, that the same proposition cannot at the same time be false and true. But I can go no further with the nominalists, For I cannot look upon this last as a merely verbal proposition. I consider it to be, like other axioms, one of our first and most familiar generalizations from experience. The original foundation of it I take to be that belief and disbelief are two different mental states excluding one another. This we know by the simplest observation of our own minds, and if we carry our observation outward, we also find that light and darkness, sound and silence, motion and quiescence, equality and inequality, preceding and following, succession and simultaneousness, any positive phenomenon whatever, and its negative, are distinct phenomena, pointedly contrasted, and the one always absent where the other is present. I consider the maxim in question to be a generalization from all these facts. In like manner as the principle of contradiction, that one of two contradictories must be false, means that an assertion cannot be both true and false, so the principle of excluded middle, or that one of two contradictories must be true, means that an assertion must be either true or false. Either the affirmative is true, or otherwise the negative is true, which means that the affirmative is false. I cannot help thinking this principle a surprising specimen of a so-called necessity of thought, since it is not even true unless with a large qualification. A proposition must be either true or false, provided that the predicate be one which can in any intelligible sense be attributed to the subject, and as this is always assumed to be the case in treatises on logic, the axiom is always laid down there as of absolute truth. Abracadabra is a second intention, is neither true nor false. Between the true and the false there is a third possibility, the unmeaning, and this alternative is fatal to Sir William Hamilton's extension of the maxim to noumena, that matter must either have a minimum of divisibility or be infinitely divisible, is more than we can ever know. For in the first place, matter, in any other than the phenomenal sense of the term, may not exist, and it will scarcely be said that a nonentity must be either infinitely or finitely divisible. In the second place, though matter, considered as the occult cause of our sensations, do really exist, yet what we call divisibility may be an attribute only of our sensations of sight and touch, and not of their uncognizable cause. Divisibility may not be predicable at all, in any intelligent sense, of things in themselves, nor therefore of matter in itself, and the assumed necessity of being either infinitely or finitely divisible may be an inapplicable alternative. On this question I am happy to have the full concurrence of Mr. Herbert Spencer, from whose paper in the Fortnightly Review I extract the following passage. The germ of an idea identical with that of Mr. Spencer may be found in the present chapter on a preceding page, but in Mr. Spencer it is not an undeveloped thought, but a philosophical theory. Quote, when remembering a certain thing as in a certain place, the place and the thing are mentally represented together, while to think of the non-existence of the thing in that place implies a consciousness in which the place is represented, but not the thing. Similarly, if instead of thinking of an object as colourless, we think of it having colour, the change consists in the addition to the concept of an element that was before absent from it. The object cannot be thought of first as red and then as not red, without one component of the thought being totally expelled from the mind by another. The law of the excluded middle, then, is simply a generalization of the universal experience that some mental states are directly destructive of other states. It formulates a certain absolutely constant law, that the appearance of any positive mode of consciousness cannot occur without excluding a correlative negative mode, and that the negative mode cannot occur without excluding the correlative positive mode. The antithesis of positive and negative being, indeed, merely an expression of this experience. Hence it follows that if consciousness is not in one of the two modes, it must be in the other." End quote. Footnote. Professor Bain, Logic 1:16, identifies the principle of contradiction with his law of relativity, that is, that, quote, "everything that can be thought of, every affirmation that can be made, has an opposite or counter-notion or affirmation," end quote. A proposition which is one of the general results of the whole body of human experience. For further considerations respecting the axioms of contradiction and excluded middle, see the 21st chapter of an examination of Sir William Hamilton's philosophy. End footnote. I must here close this supplementary chapter, and with it the second book. The theory of induction, in the most comprehensive sense of the term, will form the subject of the third. End of section 27. Section 28 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 3 of Induction, Chapter 1, Preliminary Observations on Induction in General. Quote, "According to the doctrine now stated, the highest, or rather the only proper object of physics, is to ascertain those established conjunctions of successive events which constitute the order of the universe, to record the phenomena which it exhibits to our observations, or which it discloses to our experiments, and to refer these phenomena to their general laws." End quote. D. Stuart, Elements of the Philosophy of the Human Mind, Volume 2, Chapter 4, Section 1. Quote, "In such cases the inductive and deductive methods of inquiry may be said to go hand in hand, the one verifying the conclusions deduced by the other, and the combination of experiment and theory which may thus be brought to bear in such cases forms an engine of discovery infinitely more powerful than either taken separately. This state of any department of science is perhaps of all others the most interesting, and that which promises the most to research." End quote. Sir J. Herschel, Discourse on the Study of Natural Philosophy. Part 1. The portion of the present inquiry upon which we are now about to enter may be considered as the principal, both from its surpassing in intricacy all the other branches, and because it relates to a process which has been shown in the preceding book to be that in which the investigation of nature essentially consists. We have found that all inference, consequently all proof, and all discovery of truths not self-evident, consists of inductions and the interpretation of inductions, that all our knowledge, not intuitive, comes to us exclusively from that source. What induction is, therefore, and what conditions render it legitimate, cannot be but deemed the main question of the science of logic, the question which includes all others. It is, however, one which professed writers on logic have almost entirely passed over. The generalities of the subject have not been altogether neglected by metaphysicians, but, for want of sufficient acquaintance with the processes by which science has actually succeeded in establishing general truths, their analysis of the inductive operation, even when unexceptionable as to correctness, has not been specific enough to be made the foundation of practical rules, which might be for induction itself what the rules of the syllogism are for the interpretation of induction, while those by whom physical science has been carried to its present state of improvement, and who, to arrive at a complete theory of the process, needed only to generalize and adapt to all varieties of problems the methods which they themselves employed in their habitual pursuits, never until very lately made any serious attempt to philosophize on the subject, nor regarded the mode in which they arrived at their conclusions as deserving of study independently of the conclusions themselves. Part 2. For the purposes of the present inquiry, induction may be defined the operation of discovering and proving general propositions. It is true that, as already shown, the process of indirectly ascertaining individual facts is as truly inductive as that by which we establish general truths, but it is not a different kind of induction. It is a form of the very same process, since, on the one hand, generals are but collections of particulars, definite in kind but indefinite in number, and on the other hand, whenever the evidence which we derive from observation of known cases justifies us in drawing an inference respecting even one unknown case, we should, on the same evidence, be justified in drawing a similar inference with respect to a whole class of cases. The inference either does not hold at all, or it holds in all cases of a certain description, in all cases which, in certain definable respects, resemble those we have observed. If these remarks are just, if the principles and rules of inference are the same whether we infer general propositions or individual facts, it follows that a complete logic of the sciences would be also a complete logic of practical business and common life. Since there is no case of legitimate inference from experience in which the conclusion may not legitimately be a general proposition, an analysis of the process by which general truths are arrived at is virtually an analysis of all induction whatever. Whether we are inquiring into a scientific principle or into an individual fact, and whether we proceed by experiment or by ratiocination, every step in the train of inferences is essentially inductive, and the legitimacy of the induction depends in both cases on the same conditions. True it is that in the case of the practical inquirer, who is endeavouring to ascertain facts not for the purposes of science but for those of business, such, for instance, as the advocate or the judge, the chief difficulty is one in which the principles of induction will afford him no assistance. It lies not in making his inductions, but in the selection of them, in choosing from among all general propositions ascertained to be true, those which furnish marks by which he may trace whether the given subject possesses or not the predicate in question. In arguing a doubtful question of fact before a jury, the general propositions or principles to which the advocate appeals are mostly, in themselves, sufficiently trite and assented to as soon as stated. His skill lies in bringing his case under those propositions or principles, in calling to mind such of the known or received maxims of probability as admit of application to the case in hand, and selecting from among them the best adapted to his object. Success is here dependent on natural or acquired sagacity, aided by knowledge of the particular subject, and of subjects allied with it. Invention, though it can be cultivated, cannot be reduced to rule. There is no science which will enable a man to bethink himself of that which will suit his purpose. But when he has thought of something, science can tell him whether that which he has thought of will suit his purpose or not. The inquirer or arguer must be guided by his own knowledge and sagacity in the choice of the inductions out of which he will construct his argument. But the validity of the argument, when constructed, depends on principles, and must be tried by tests, which are the same for all descriptions of inquiries, whether the result be to give A an estate, or to enrich science with a new general truth. In the one case and in the other, the senses, or testimony, must decide on the individual facts. The rules of the syllogism will determine whether, those facts being supposed correct, the case really falls within the formulae of the different inductions under which it has been successively brought. And finally, the legitimacy of the inductions themselves must be decided by other rules, and these it is now our purpose to investigate. If this third part of the operation be, in many of the question of practical life, not the most but the least arduous portion of it, we have seen that this is also the case in some great departments of the field of science, in all those which are principally deductive, and most of all in mathematics, where the inductions themselves are few in number and so obvious and elementary that they seem to stand in no need of the evidence of experience, while to combine them so as to prove a given theorem or solve a problem may call for the utmost powers of invention and contrivance with which our species is gifted. If the identity of the logical processes which prove particular facts and those which establish general scientific truths required any additional confirmation, it would be sufficient to consider that in many branches of science single facts have to be proved, as well as principles, facts as completely individual as any that are debated in a court of justice, but which are proved in the same manner as the other truths of the science, and without disturbing in any degree the homogeneity of its method. A remarkable example of this is afforded by astronomy. The individual facts on which that science grounds its most important deductions, such facts as the magnitudes of the bodies of the solar system, their distances from one another, the figure of the earth and its rotation, are scarcely any of them accessible to our means of direct observation. They are proved indirectly by the aid of inductions founded on other facts which we can more easily reach. For example, the distance of the moon from the earth was determined by a very circuitous process. The share which direct observation had in the work consisted in ascertaining at one and the same instant the zenith distances of the moon as seen from 2 points very remote from one another on the earth's surface. The ascertainment of these angular distances ascertained their supplements, and since the angle at the earth's centre subtended by the distance between the 2 places of observation was deducible by spherical trigonometry from the latitude and longitude of those places, the angle at the moon subtended by the same line became the 4th angle of a quadrilateral of which the other 3 angles were known. The 4 angles being thus ascertained, and 2 sides of the quadrilateral being radii of the earth, the 2 remaining sides and the diagonal, or, in other words, the moon's distance from the 2 places of observation and from the centre of the earth, could be ascertained at least in terms of the earth's radius from elementary theorems of geometry. At each step in this demonstration, a new induction is taken in, represented in the aggregate of its results by a general proposition. Not only is the process by which an individual astronomical fact was thus ascertained exactly similar to those by which the same science establishes its general truths, but also, as we have shown to be the case in all legitimate reasoning, a general proposition might have been concluded instead of a single fact. In strictness, indeed, the result of the reasoning is a general proposition, a theorem respecting the distance not of the moon in particular, but of any inaccessible object, showing in what relation that distance stands to certain other quantities. And although the moon is almost the only heavenly body the distance of which from the earth can really be thus ascertained, this is merely owing to the accidental circumstances of the other heavenly bodies, which render them incapable of affording such data as the application of the theorem requires, for the theorem itself is as true of them as it is of the moon. Footnote: Dr. Whewell thinks it improper to apply the term induction to any operation not terminating in the establishment of a general truth. Induction, he says, Philosophy of Discovery, page 245, quote, is not the same thing as experience and observation. Induction is experience or observation consciously looked at in a general form. This consciousness and generality are necessary parts of that knowledge which is science. End quote. And he objects, page 241, to the mode in which the word induction is employed in this work as an undue extension of that term, quote, not only to the cases in which the general induction is consciously applied to a particular instance, but to the cases in which the particular instance is dealt with by means of experience in that rude sense in which experience can be asserted of brutes, and in which, of course, we can in no way imagine that the law is possessed or understood as a general proposition." End quote. This use of the term he deems a quote, "confusion of knowledge with practical tendencies." End quote. I disclaim, as strongly as Dr. Whewell can do, the application of such terms as induction, inference, or reasoning to operations performed by mere instinct, that is, from an animal impulse, without the exertion of any intelligence. But I perceive no ground for confining the use of those terms to cases in which the inference is drawn in the forms and with the precautions required by scientific propriety. To the idea of science, an express recognition and distinct apprehension of general laws as such is essential, but 9/10 of the conclusions drawn from experience in the course of practical life are drawn without any such recognition. They are direct inferences from known cases to a case supposed to be similar. I have endeavoured to show that this is not only as legitimate an operation, but substantially the same operation as that of ascending from known cases to a general proposition, except that the latter process has one great security for correctness which the former does not possess. In science, the inference must necessarily pass through the intermediate stage of a general proposition, because science wants its conclusions for record and not for instantaneous use. But the inferences drawn for the guidance of practical affairs by persons who would often be quite incapable of expressing in unexceptionable terms the corresponding generalizations may and frequently do exhibit intellectual powers quite equal to any which have ever been displayed in science. And if these inferences are not inductive, what are they? The limitation imposed on the term by Dr. Whewell seems perfectly arbitrary, neither justified by any fundamental distinction between what he includes and what he desires to exclude, nor sanctioned by usage, at least from the time of Reid and Stuart, the principal legislators, as far as the English language is concerned, of modern metaphysical terminology. End footnote. We shall fall into no error, then, if in treating of induction we limit our attention to the establishment of general propositions. The principles and rules of induction, as directed to this end, are the principles and rules of all induction, and the logic of science is the universal logic applicable to all inquiries in which man can engage. End of section 28. Section 29 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 3, Chapter 2 of Inductions Improperly So Called, Parts 1 through 3. Part 1. Induction, then, is that operation of the mind by which we infer that what we know to be true in a particular case or cases will be true in all cases which resemble the former in certain assignable respects. In other words, induction is the process by which we conclude that what is true of certain individuals of a class is true of the whole class, or that what is true at certain times will be true in similar circumstances at all times. This definition excludes from the meaning of the term induction various logical operations to which it is not unusual to apply that name. Induction, as above defined, is a process of inference. It proceeds from the known to the unknown, and any operation involving no inference, any process in which what seems the conclusion is no wider than the premises from which it is drawn, does not fall within the meaning of the term. Yet, in the common books of logic, we find this laid down as the most perfect, indeed the only quite perfect, form of induction. In those books, every process which sets out from a less general and terminates in a more general expression, which admits of being stated in the form this and that A are B, therefore every A is B, is called an induction, whether anything be really concluded or not, and the induction is asserted not to be perfect unless every single individual of the class A is included in the antecedent or premise, that is, unless what we affirm of the class has already been ascertained to be true of every individual in it, so that the nominal conclusion is not really a conclusion, but a mere reassertion of the premises. If we were to say, all the planets shine by the sun's light from observation of each separate planet, or all the apostles were Jews because this is true of Peter, Paul, John, and every other apostle, these and such as these would, in the phraseology in question, be called perfect, and the only perfect inductions. This, however, is a totally different kind of induction from ours. It is not an inference from facts known to facts unknown, but a mere shorthand registration of facts known. The two simulated arguments which we have quoted are not generalizations. The propositions purporting to be conclusions from them are not really general propositions. A general proposition is one in which the predicate is affirmed or denied of an unlimited number of individuals, namely, all, whether few or many, existing or capable of existing, which possess the properties connoted by the subject of the proposition. All men are mortal does not mean all now living, but all men past, present, and to come. When the signification of the term is limited so as to render it a name not for any and every individual falling under a certain general description, but only for each of a number of individuals designated as such, and as it were counted off individually, the proposition, though it may be general in its language, is no general proposition, but merely that number of singular propositions written in an abridged character. The operation may be very useful, as most forms of abridged notation are, but it is no part of the investigation of truth, though often bearing an important part in the preparation of the materials for that investigation. As we may sum up a definite number of singular propositions in one proposition, which will be apparently, but not really, general, so we may sum up a definite number of general propositions in one proposition, which will be apparently, but not really, more general. If by a separate induction applied to every distinct species of animals, it has been established that each possesses a nervous system, and we affirm thereupon that all animals have a nervous system, this looks like a generalization, though, as the conclusion merely affirms of all what has already been affirmed of each, it seems to tell us nothing but what we knew before. A distinction, however, must be made. If, in concluding that all animals have a nervous system, we mean the same thing and no more as if we had said all known animals, the proposition is not general, and the process by which it is arrived at is not induction. But if our meaning is that the observations made of the various species of animals have discovered to us a law of animal nature, and that we are in a condition to say that a nervous system will be found even in animals yet undiscovered, this indeed is an induction. But in this case, the general proposition contains more than the sum of the special propositions from which it is inferred. The distinction is still more forcibly brought out when we consider that if this real generalization be legitimate at all, its legitimacy probably does not require that we should have examined without exception every known species. It is the number and nature of the instances, and not their being the whole of those which happen to be known, that makes them sufficient evidence to prove a general law, while the more limited assertion, which stops at all known animals, cannot be made unless we have rigorously verified it in every species. In like manner, to return to a former example, we might have inferred not that all the planets, but that all planets shine by reflected light. The former is no induction, the latter is an induction, and a bad one, being disproved by the case of double stars, self-luminous bodies which are properly planets, since they revolve round a centre. Part 2. There are several processes used in mathematics which require to be distinguished from induction, being not unfrequently called by that name, and being so far similar to induction properly so called that the propositions they lead to are really general propositions. For example, when we have proved with respect to the circle that a straight line cannot meet it in more than 2 points, and when the same thing has been successively proved of the ellipse, the parabola, and the hyperbola, it may be laid down as a universal property of the sections of the cone. The distinction drawn in the 2 previous examples can have no place here, there being no difference between all known sections of the cone and all sections, since a cone demonstrably cannot be intersected by a plane except in one of these 4 lines. It would be difficult, therefore, to refuse to the proposition arrived at the name of a generalization, since there is no room for any generalization beyond it. But there is no induction, because there is no inference. The conclusion is a mere summing up of what was asserted in the various propositions from which it is drawn. A case somewhat, though not altogether similar, is the proof of a geometrical theorem by means of a diagram. Whether the diagram be on paper or only in the imagination, the demonstration, as formerly observed, does not prove directly the general theorem. It proves only that the conclusion which the theorem asserts generally is true of the particular triangle or circle exhibited in the diagram. But since we perceive that in the same way in which we have proved it of the circle, it might also be proved of any other circle, we gather up into one general expression all the singular propositions susceptible of being thus proved, and embody them in a universal proposition. Having shown that the 3 angles of the triangle ABC are together equal to 2 right angles, we conclude that this is true of every other triangle, not because it is true of ABC, but for the same reason which proved it to be true of ABC. If this were to be called induction, an appropriate name for it would be induction by parity of reasoning. But the term cannot properly belong to it. The characteristic quality of induction is wanting, since the truth obtained, though really general, is not believed on the evidence of particular instances. We do not conclude that all triangles have the property because some triangles have, but from the ulterior demonstrative evidence which was the ground of our conviction in the particular instances. There are nevertheless in mathematics some examples of so-called induction, in which the conclusion does bear the appearance of a generalization grounded on some of the particular cases included in it. A mathematician, when he has calculated a sufficient number of the terms of an algebraical or arithmetical series to have ascertained what is called the law of the series, does not hesitate to fill up any number of the succeeding terms without repeating the calculations. But I apprehend he only does so when it is apparent from an a priori considerations, which might be exhibited in the form of demonstration, that the mode of formation of the subsequent terms, each from that which preceded it, must be similar to the formation of the terms which have been already calculated, and when the attempt has been hazarded without the sanction of such general considerations, there are instances on record in which it has led to false results. It is said that Newton discovered the binomial theorem by induction, by raising a binomial successively to a certain number of powers and comparing those powers with one another until he detected the relation in which the algebraic formula of each power stands to the exponent of that power and to the two terms of the binomial. The fact is not improbable, but a mathematician like Newton, who seemed to arrive per saltum at principles and conclusions that ordinary mathematicians only reached by a succession of steps, certainly could not have performed the comparison in question without being led by it to the a priori ground of the law, since anyone who understands sufficiently the nature of multiplication to venture upon multiplying several lines of symbol at one operation cannot but perceive that in raising a binomial to a power, the coefficients must depend on the laws of permutation and combination. And as soon as this is recognized, the theorem is demonstrated. Indeed, when once it was seen that the law prevailed in a few of the lower powers, its identity with the law of permutation would at once suggest the considerations which prove it to obtain universally. Even, therefore, such cases as these are but examples of what I have called induction by parity of reasoning, that is, not really induction, because not involving inference of a general proposition from particular instances. Part 3. There remains a third improper use of the term induction, which it is of real importance to clear up, because the theory of induction has been, in no ordinary degree, confused by it, and because the confusion is exemplified in the most recent and elaborate treatise on the inductive philosophy which exists in our language. The error in question is that of confounding a mere description, by general terms, of a set of observed phenomena with an induction from them. Suppose that a phenomenon consists of parts, and that these parts are only capable of being observed separately, and, as it were, piecemeal. When the observations have been made, there is a convenience, amounting for many purposes to a necessity, in obtaining a representation of the phenomenon as a whole by combining, or, as we may say, piecing these detached fragments together. A navigator sailing in the midst of the ocean discovers land. He cannot at first, or by any one observation, determine whether it is a continent or an island, but he coasts along it, and after a few days finds himself to have sailed completely round it. He then pronounces it an island. Now, there was no particular time or place of observation at which he could perceive that this land was entirely surrounded by water. He ascertained the fact by a succession of partial observations, and then selected a general expression which summed up in 2 or 3 words the whole of what he so observed. But is there anything of the nature of an induction in this process? Did he infer anything that had not been observed from something else which had? Certainly not. He had observed the whole of what the proposition asserts. That the land in question is an island is not an inference from the partial facts which the navigator saw in the course of his circumnavigation. It is the facts themselves. It is a summary of those facts, the description of a complex fact to which those simpler ones are as the parts of a whole. Now there is, I conceive, no difference in kind between this simple operation and that by which Kepler ascertained the nature of the planetary orbits, and Kepler's operation, all at least that was characteristic in it, was not more an inductive act than that of our supposed navigator. The object of Kepler was to determine the real path described by each of the planets, or let us say by the planet Mars, since it was of that body that he first established the two of his three laws which did not require a comparison of planets. To do this there was no other mode than that of direct observation, and all which observation could do was to ascertain a great number of the successive places of the planet, or rather of its apparent places. That the planet occupied successively all these positions, or at all events positions which produced the same impressions on the eye, and that it passed from one of these to another insensibly and without any apparent breach of continuity, thus much the senses, with the aid of the proper instruments, could ascertain. What Kepler did more than this was to find what sort of a curve these different points would make, supposing them to be all joined together. He expressed the whole series of the observed places of Mars by what Dr. Whewell calls the general conception of an ellipse. This operation was far from being as easy as that of the navigator who expressed the series of his observations on successive points of the coast by the general conception of an island, but it is the very same sort of operation, and if the one is not an induction but a description, this must also be true of the other. The only real induction concerned in the case consisted in inferring that because the observed places of Mars were correctly represented by points in an imaginary ellipse, therefore Mars would continue to revolve in that same ellipse, and in concluding, before the gap had been filled up by further observations, that the positions of the planet during the time which intervened between two observations must have coincided with the intermediate points of the curve, for these were facts which had not been directly observed. They were inferences from the observations, facts inferred as distinguished from facts seen. But these inferences were so far from being a part of Kepler's philosophical operation that they had been drawn long before he was born. Astronomers had long known that the planets periodically returned to the same places. When this had been ascertained, there was no induction left for Kepler to make, nor did he make any further induction. He merely applied his new conception to the facts inferred as he did to the facts observed, knowing already that the planets continued to move in the same paths. When he found that an ellipse correctly represented the past path, he knew that it would represent the future path. In finding a compendious expression for the one set of facts, he found one for the other. But he found the expression only, not the inference. Nor did he, which is the true test of a general truth, add anything to the power of prediction already possessed. End of section 29. Section 30 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 3, Chapter 2 of Inductions Improperly So Called, Parts 4 through 5. Part 4. The descriptive operation which enables a number of details to be summed up in a single proposition, Dr. Whewell, by an aptly chosen expression, has termed the colligation of facts. In most of his observations concerning that mental process I fully agree, and would gladly transfer all that portion of his book into my own pages. I only think him mistaken in setting up this kind of operation, which, according to the old and received meaning of the term, is not induction at all, as the type of induction generally, and laying down throughout his work as principles of induction the principles of mere colligation. Dr. Whewell maintains that the general proposition which binds together the particular facts and makes them, as it were, one fact, is not the mere sum of those facts, but something more, since there is introduced a conception of the mind which did not exist in the facts themselves. Quote, The particular facts, says he, are not merely brought together, but there is a new element added to the combination by the very act of thought by which they are combined. Footnote: Novum Organum Renovatum, pages 72 and 73. End footnote. When the Greeks, after long observing the motions of the planets, saw that these motions might be rightly considered as produced by the motion of one wheel revolving in the inside of another wheel, these wheels were creations of their minds, added to the facts which they perceived by sense. And even if the wheels were no longer supposed to be material, but were reduced to mere geometrical spheres or circles, they were not the less products of the mind alone, something additional to the facts observed. The same is the case in all other discoveries. The facts are known, but they are insulated and unconnected, till the discoverer supplies from his own store a principle of connection. The pearls are there, but they will not hang together till someone provides the string. End quote. Let me first remark that Dr. Whewell in this passage blends together indiscriminately examples of both the processes which I am endeavouring to distinguish from one another. When the Greeks abandoned the supposition that the planetary motions were produced by the revolution of material wheels and fell back upon the idea of mere geometrical spheres or circles, there was more in this change of opinion than the mere substitution of an ideal curve for a physical one. There was the abandonment of a theory, and the replacement of it by a mere description. No one would think of calling the doctrine of material wheels a mere description. That doctrine was an attempt to point out the force by which planets were acted upon and compelled to move in their orbits. But when, by a great step in philosophy, the materiality of the wheels was discarded and the geometrical forms alone retained, the attempt to account for the motions was given up, and what was left of the theory was a mere description of the orbits. The assertion that the planets were carried round by wheels revolving in the inside of other wheels gave place to the proposition that they moved in the same lines which would be traced by bodies so carried, which was a mere mode of representing the sum of the observed facts, as Kepler's was another and a better mode of representing the same observations. It is true that for these simply descriptive operations, as well as for the erroneous inductive one, a conception of the mind was required. The conception of an ellipse must have presented itself to Kepler's mind before he could identify the planetary orbits with it. According to Dr. Whewell, the conception was something added to the facts. He expresses himself as if Kepler had put something into the facts by his mode of conceiving them. But Kepler did no such thing. The ellipse was in the facts before Kepler recognized it, just as the island was an island before it had been sailed round. Kepler did not put what he had conceived into the facts, but saw it in them. A conception implies and corresponds to something conceived, and though the conception itself is not in the facts, but in our mind, yet if it is to convey any knowledge relating to them, it must be a conception of something which really is in the facts, some property which they actually possess, and which they would manifest to our senses, if our senses were able to take cognizance of it. If, for instance, the planet left behind it in space a visible track, and if the observer were in a fixed position at such a distance from the plane of the orbit as would enable him to see the whole of it at once, he would see it to be an ellipse, and if gifted with appropriate instruments and powers of locomotion, he could prove it to be such by measuring its different dimensions. Nay, further, if the track were visible, and he was so placed that he could see all parts of it in succession, but not all of them at once, he might be able, by piecing together his successive observations, to discover both that it was an ellipse and that the planet moved in it. The case would then exactly resemble that of the navigator who discovers the land to be an island by sailing around it. If the path was visible, no one, I think, would dispute that to identify it with an ellipse is to describe it, and I cannot see why any difference should be made by its not being directly an object of sense, when every point in it is as exactly ascertained as if it were so. Subject to the indispensable condition which has just been stated, I do not conceive that the part which conceptions have in the operation of studying facts has ever been overlooked or undervalued. No one ever disputed that in order to reason about anything we must have a conception of it, or that when we include a multitude of things under a general expression, there is implied in the expression a conception of something common to those things. But it by no means follows that the conception is necessarily pre-existent, or constructed by the mind out of its own materials. If the facts are rightly classed under the conception, it is because there is in the facts themselves something of which the conception is itself a copy, and which, if we cannot directly perceive, it is because of the limited power of our organs, and not because the thing itself is not there. The conception itself is often obtained by abstraction from the very facts which, in Dr. Whewell's language, it is afterward called in to connect. This he himself admits, when he observes, which he does on several occasions, how great a service would be rendered to the science of physiology by the philosopher who should establish a price tenable and consistent conception of life. Footnote: Novum Organum Renovatum, page 32. End footnote. Such a conception can only be abstracted from the phenomenon of life itself, from the very facts which it is put in requisition to connect. In other cases, no doubt, instead of collecting the conception from the very phenomena which we are attempting to colligate, we select it from among those which have been previously collected by abstraction from other facts. In the instance of Kepler's laws, the latter was the case, the facts being out of the reach of being observed in any such manner as would have enabled the senses to identify directly the path of the planet. The conception requisite for framing a general description of that path could not be collected by abstraction from the observations themselves. The mind had to supply, hypothetically, from among the conceptions it had obtained from other portions of its experience, some one which would correctly represent the series of the observed facts. It had to frame a supposition respecting the general course of the phenomenon and ask itself, if this be the general description, what will the details be? And then compare these with the details actually observed. If they agreed, the hypothesis would serve for a description of the phenomenon. If not, it was necessarily abandoned, and another tried. It is such a case as this which gives rise to the doctrine that the mind, in framing the descriptions, adds something of its own, which it does not find in the facts. Yet it is a fact, surely, that the planet does describe an ellipse, and a fact which we could see if we had adequate visual organs and a suitable position. Not having these advantages, but possessing the conception of an ellipse, or, to express the meaning in less technical language, knowing what an ellipse was, Kepler tried whether the observed places of the planet were consistent with such a path. He found they were so, and he consequently asserted as a fact that the planet moved in an ellipse. But this fact, which Kepler did not add to, but found in, the motions of the planet, namely, that it occupied in succession the various points in the circumference of a given ellipse, was the very fact, the separate parts of which had been separately observed. It was the sum of the different observations. Having stated this fundamental difference between my opinion and that of Dr. Whewell, I must add that his account of the manner in which a conception is selected, suitable to express the facts, appears to me perfectly just. The experience of all thinkers will, I believe, testify that the process is tentative, that it consists of a succession of guesses, many being rejected, until one at last occurs fit to be chosen. We know from Kepler himself that before hitting upon the conception of an ellipse, he tried 19 other imaginary paths, which, finding them inconsistent with the observations, he was obliged to reject. But as Dr. Webber truly says, the successful hypothesis, though a guess, ought generally to be called not a lucky but a skillful guess. The guesses which serve to give mental unity and wholeness to a chaos of scattered particulars are accidents which rarely occur to any minds but those abounding in knowledge and disciplined in intellectual combinations. How far this tentative method, so indispensable as a means to the colligation of facts for purposes of description, admits of application to induction itself, and what functions belong to it in that department, will be considered in the chapter of the present book which relates to hypotheses. On the present occasion we have chiefly to distinguish this process of colligation from induction, properly so called, and that the distinction may be made clearer, it is well to advert to a curious and interesting remark, which is as strikingly true of the former operation as it appears to me unequivocally false of the latter. In different stages of the progress of knowledge, philosophers have employed for the colligation of the same order of facts different conceptions. The early rude observations of the heavenly bodies, in which minute precision was neither attained nor sought, presented nothing inconsistent with the representation of the path of a planet as an exact circle, having the earth for its centre. As observations increased in accuracy, facts were disclosed which were not reconcilable with this simple supposition. For the colligation of those additional facts, the supposition was varied, and varied again and again as facts became more numerous and precise. The earth was removed from the centre to some other point within the circle. The planet was supposed to revolve in a smaller circle called an epicycle, round an imaginary point which revolved in a circle round the earth. In proportion as observation elicited fresh facts contradictory to these representations, other epicycles and other eccentrics were added, producing additional complication, until at last Kepler swept all these circles away and substituted the conception of an exact ellipse. Even this is found not to represent with complete correctness the accurate observations of the present day, which disclose many slight deviations from an orbit exactly elliptical. Now, Dr. Webber has remarked that these successive general expressions, though apparently so conflicting, were all correct. They all answered the purpose of colligation. They all enabled the mind to represent to itself with facility and by a simultaneous glance the whole body of facts at the time ascertained. Each in its turn served as a correct description of the phenomena, so far as the senses had up to that time taken cognizance of them. If a necessity afterward arose for discarding one of these general descriptions of the planet's orbit, and framing a different imaginary line by which to express the series of observed positions, it was because a new number of facts had now been added, which it was necessary to combine with the old facts into one general description. But this did not affect the correctness of the former expression, considered as a general statement of the only facts which it was intended to represent. And so true is this, that, as is well remarked by M. Comte, these ancient generalizations, even the rudest and most imperfect of them, that of uniform movement in a circle, are so far from being entirely false that they are even now habitually employed by astronomers when only a rough approximation to correctness is required. Quote, l'astronomie moderne, en détruisant sans retour les hypothèses primitives, envisageait comme loi réelle du monde, à soigneusement maintenant leur valeur positive et permanente, la propriété de représenter commodément les phénomènes quand il s'agit d'une première ébauche. Nos ressources à cet égard sont même bien plus entendues, précisément à cause que nous ne nous faisons aucune illusion sur la réalité des hypothèses, ce qui nous permet d'employer sans scrupule en chaque cas celle que nous jugions la plus avantageuse. End quote. Footnote. Cours de philosophie positive, Volume 2, page 202. End footnote. Dr. Webber's remark, therefore, is philosophically correct. Successive expressions for the colligation of observed facts, or, in other words, successive descriptions of a phenomenon as a whole which has been observed only in parts, may, though conflicting, be all correct as far as they go. But it would surely be absurd to assert this of conflicting inductions. The scientific study of facts may be undertaken for three different purposes: the simple description of the facts, their explanation, or their prediction, meaning by prediction the determination of the conditions under which similar facts may be expected again to occur. To the first of these three operations the name of induction does not properly belong. To the other two it does. Now, Dr. Webber's observation is true of the first alone. Considered as a mere description, the circular theory of the heavenly motions represents perfectly well their general features, and by adding epicycles without limit, those motions, even as now known to us, might be expressed with any degree of accuracy that might be required. The elliptical theory, as a mere description, would have a great advantage in point of simplicity and in the consequent facility of conceiving it and reasoning about it, but it would not really be more true than the other. Different descriptions, therefore, may be all true, but not, surely, different explanations. The doctrine that the heavenly bodies moved by a virtue inherent in their celestial nature, the doctrine that they were moved by impact, which led to the hypothesis of vortices as the only impelling force capable of whirling bodies in circles, and the Newtonian doctrine that they are moved by the composition of a centripetal with an original projectile force. All these are explanations collected by real induction from supposed parallel cases, and they were all successively received by philosophers as scientific truths on the subject of the heavenly bodies. Can it be said of these, as was said of the different descriptions, that they are all true as far as they go? Is it not clear that only one can be true in any degree, and the other two must be altogether false? So much for explanations. Let us now compare different predictions. The first, that eclipses will occur when one planet or satellite is so situated as to cast its shadow upon another. The second, that they will occur when some great calamity is impending over mankind. Do these two doctrines only differ in the degree of their truth, as expressing real facts with unequal degrees of accuracy? Assuredly the one is true, and the other absolutely false. Footnote. Dr. Webber in his reply contests the distinction here drawn and maintains that not only different descriptions but different explanations of a phenomenon may all be true. Of these three theories representing the motions of the heavenly bodies, he says, Philosophy of Discovery, page 231, quote, undoubtedly all these explanations may be true and consistent with each other, and would be so if each had been followed out so as to show in what manner it could be made consistent with the facts, and this was in reality in a great measure done. The doctrine that the heavenly bodies were moved by vortices was successfully modified, so that it came to coincide in its result with the doctrine of an inverse quadratic centripetal force. When this point was reached, the vortex was merely a machinery, well or ill devised, for producing such a centripetal force, and therefore did not contradict the doctrine of a centripetal force. Newton himself does not appear to have been averse to explaining gravity by impulse. So little it is true that if one theory be true, the other must be false. The attempt to explain gravity by the impulse of streams of particles flowing through the universe in all directions, which I have mentioned in the philosophy, is so far from being inconsistent with the Newtonian theory that it is founded entirely upon it, and even with regard to the doctrine that the heavenly bodies move by an inherent virtue. If this doctrine had been maintained in any such way that it was brought to agree with the facts, the inherent virtue must have had its laws determined, and then it would have been found that the virtue had a reference to the central body, and so the inherent virtue must have coincided in its effect with the Newtonian force, and then the two explanations would agree, except so far as the word inherent was concerned. And if such a part of an earlier theory as this word inherent indicates is found to be untenable, it is of course rejected in the transition to later and more exact theories, in inductions of this kind, as well as in what Mr. Mill calls descriptions. There is therefore still no validity discoverable in the distinction which Mr. Mill attempts to draw between descriptions like Kepler's law of elliptical orbits and other examples of induction. End quote. If the doctrine of vortices had meant not that vortices existed, but only that the planets moved in the same manner as if they had been whirled by vortices, if the hypothesis had been merely a mode of representing the facts, not an attempt to account for them, if in short it had been only a description, it would no doubt have been reconcilable with the Newtonian theory. The vortices, however, were not a mere aid to conceiving the motions of the planets, but a supposed physical agent actively impelling them, a material fact which might be true or not true, but could not be both true and not true. According to Descartes' theory, it was true. According to Newton's, it was not true. Dr. Whewell probably means that since the phrases centripetal and projectile force do not declare the nature but only the direction of the forces, the Newtonian theory does not absolutely contradict any hypothesis which may be framed respecting the mode of their production. The Newtonian theory, regarded as a mere description of the planetary motions, does not. But the Newtonian theory as an explanation of them does. For in what does the explanation consist? In ascribing those motions to a general law which obtains between all particles of matter, and in identifying this with the law by which bodies fall to the ground. If the planets are kept in their orbits by a force which draws the particles composing them toward every other particle of matter in the solar system, they are not kept in those orbits by the impulsive force of certain streams of matter which whirl them round. The one explanation absolutely excludes the other. Either the planets are not moved by vortices, or they do not move by a law common to all matter. It is impossible that both opinions can be true. As well might it be said that there is no contradiction between the assertions that a man died because somebody killed him, and that he died a natural death. So, again, the theory that the planets move by a virtue inherent in their celestial nature is incompatible with either of the two others, either that of their being moved by vortices, or that which regards them as moving by a property which they have in common with the earth and all terrestrial bodies. Dr. Whewell says that the theory of an inherent virtue agrees with Newton's when the word inherent is left out, which, of course, it would be, he says, if found to be untenable. But leave that out, and where is the theory? The word inherent is the theory. When that is omitted, there remains nothing except that the heavenly bodies move, quote, by a virtue, end quote. That is, by a power of some sort, or by virtue of their celestial nature, which directly contradicts the doctrine that terrestrial bodies fall by the same law. If Dr. Whewell is not yet satisfied, any other subject will serve equally well to test his doctrine. He will hardly say that there is no contradiction between the emission theory and the undulatory theory of light, or that they can be both one and two electricities, or that the hypothesis of the production of the higher organic forms by development from the lower, and the supposition of separate and successive acts of creation are quite reconcilable, or that the theory that volcanoes are fed from a central fire and the doctrines which ascribe them to chemical action at a comparatively small depth below the Earth's surface are consistent with one another, and all true as far as they go. If different explanations of the same fact cannot both be true, still less, surely, can different predictions. Dr. Whewell quarrels, on what ground it is not necessary here to consider, with the example I had chosen on this point, and thinks an objection to an illustration a sufficient answer to a theory. Examples not liable to his objection are easily found if the proposition that conflicting predictions cannot both be true can be made clearer by many examples. Suppose the phenomenon to be a newly discovered comet, and that one astronomer predicts its return once in every 300 years, another once in every 400. Can they both be right? When Columbus predicted that by sailing constantly westward he should in time return to the point from which he set out, while others asserted that he could never do so except by turning back, were both he and his opponents true prophets? Were the predictions which foretold the wonders of railways and steamships, and those which averred that the Atlantic could never be crossed by steam navigation, nor a railway train propelled 10 miles an hour, both, in Dr. Whewell's words, true and consistent with one another? Dr. Whewell sees no distinction between holding contradictory opinions on a question of fact and merely employing different analogies to facilitate the conception of the same fact. The case of different inductions belongs to the former class, that of different descriptions to the latter. End footnote. In every way, therefore, it is evident that to explain induction as the colligation of facts by means of appropriate conceptions, that is, conceptions which will really express them, is to confound mere description of the observed facts with inference from those facts, and ascribe to the latter what is a characteristic property of the former. There is, however, between colligation and induction a real correlation which it is important to conceive correctly. Colligation is not always induction, but induction is always colligation. The assertion that the planets move in ellipses was but a mode of representing observed facts. It was but a colligation, while the assertion that they are drawn, or tend, toward the sun was the statement of a new fact, inferred by induction. But the induction, once made, accomplishes the purposes of colligation likewise. It brings the same facts which Kepler had connected by his conception of an ellipse under the additional conception of bodies acted upon by a central force, and serves, therefore, as a new bond of connection for those facts, a new principle for their classification. Further, the descriptions which are improperly confounded with induction are, nevertheless, a necessary preparation for induction. no less necessary than correct observation of the facts themselves. Without the previous colligation of detached observations by means of one general conception, we could never have obtained any basis for an induction, except in the case of phenomena of very limited compass. We should not be able to affirm any predicates at all of a subject incapable of being observed otherwise than piecemeal. Much less could we extend those predicates by induction to other similar subjects. Induction, therefore, always presupposes not only that the necessary observations are made with the necessary accuracy, but also that the results of these observations are, so far as practicable, connected together by general descriptions, enabling the mind to represent to itself as wholes whatever phenomena are capable of being so represented. Part 5. Dr. Whewell has replied at some length to the preceding observations, restating his opinions, but without, as far as I can perceive, adding anything material to his former arguments. Since, however, mine have not had the good fortune to make any impression upon him, I will subjoin a few remarks tending to show more clearly in what our difference of opinion consists, as well as, in some measure, to account for it. Nearly all the definitions of induction by writers of authority make it consist in drawing inferences from known cases to unknown, affirming of a class a predicate which has been found true of some cases belonging to the class, concluding because some things have a certain property that other things which resemble them have the same property, or because a thing has manifested a property at a certain time that it has and will have that property at other times. It will scarcely be contended that Kepler's operation was an induction in this sense of the term. The statement that Mars moves in an elliptical orbit was no generalization from individual cases to a class of cases. Neither was it an extension to all time of what had been found true at some particular time. The whole amount of generalization which the case admitted of was already completed, or might have been so. Long before the elliptical theory was thought of, it had been ascertained that the planets returned periodically to the same apparent places. The series of these places was, or might have been, completely determined, and the apparent course of each planet marked out on the celestial globe in an uninterrupted line. Kepler did not extend an observed truth to other cases than those in which it had been observed. He did not widen the subject of the proposition which expressed the observed facts. The alteration he made was in the predicate. Instead of saying, "The successive places of Mars are so and so," he summed them up in the statement that the successive places of Mars are points in an ellipse. It is true, this statement, as Dr. Whewell says, was not the sum of the observations merely. It was the sum of the observations seen under a new point of view. Footnote: Philosophy of Discovery, page 256. End footnote. But it was not the sum of more than the observations, as a real induction is. It took in no cases but those which had been actually observed, or which could have been inferred from the observations before the new point of view presented itself. There was not that transition from known cases to unknown, which constitutes induction in the original and acknowledged meaning of the term. Old definitions, it is true, cannot prevail against new knowledge, and if the Keplerian operation as a logical process be really identical with what takes place in acknowledged induction, the definition of induction ought to be so widened as to take it in, since scientific language ought to adapt itself to the true relations which subsist between the things it is employed to designate. Here then it is that I am at issue with Dr. Whewell. He does think the operations identical. he allows of no logical process in any case of induction other than what there was in Kepler's case, namely, guessing until a guess is found which tallies with the facts, and accordingly, as we shall see hereafter, he rejects all canons of induction, because it is not by means of them that we guess. Dr. Whewell's theory of the logic of science would be very perfect if it did not pass over altogether the question of proof. But in my apprehension there is such a thing as proof, and inductions differ altogether from descriptions in their relation to that element. Induction is proof. It is inferring something unobserved from something observed. It requires, therefore, an appropriate test of proof, and to provide that test is the special purpose of inductive logic. When, on the contrary, we merely collate known observations and, in Dr. Whewell's phraseology, connect them by means of a new conception, if the conception does serve to connect the observations, we have all we want. As the proposition in which it is embodied pretends to no other truth than what it may share with many other modes of representing the same facts, to be consistent with the facts is all that it requires. It neither needs nor admits of proof, though it may serve to prove other things, inasmuch as, by placing the facts in mental connection with other facts, not previously seen to resemble them, it assimilates the case to another class of phenomena, concerning which real inductions have already been made. Thus, Kepler's so-called law brought the orbit of Mars into the class ellipse, and by doing so proved all the properties of an ellipse to be true of the orbit. But in this proof, Kepler's law supplied the minor premise, and not, as is the case with real induction, the major. Dr. Whewell calls nothing induction where there is not a new mental conception introduced, and everything induction where there is. But this is to confound two very different things, invention and proof. The introduction of a new conception belongs to invention, and invention may be required in any operation, but is the essence of none. A new conception may be introduced for descriptive purposes, and so it may for inductive purposes, but it is so far from constituting induction that induction does not necessarily stand in need of it. Most inductions require no conception but what was present in every one of the particular instances on which the induction is grounded. That all men are mortal is surely an inductive conclusion, yet no new conception is introduced by it. Whoever knows that any man has died has all the conceptions involved in the inductive generalization, but Dr. Whewell considers the process of invention, which consists in framing a new conception consistent with the facts, to be not merely a necessary part of all induction, but the whole of it. The mental operation which extracts from a number of detached observations certain general characters in which the observed phenomena resemble one another, or resemble other known facts, is what Bacon, Locke, and most subsequent metaphysicians have understood by the word abstraction. A general expression obtained by abstraction, connecting known facts by means of common characters, but without concluding from them to unknown, may, I think, with strict logical correctness, be termed a description. Nor do I know in what other way things can ever be described. My position, however, does not depend on the employment of that particular word. I am quite content to use Dr. Whewell's term colligation, or the more general phrases, quote, mode of representing or of expressing phenomena, end quote, provided it be clearly seen that the process is not induction, but something radically different. What more may usefully be said on the subject of colligation, or of the correlative expression invented by Dr. Whewell, the explication of conceptions, and generally on the subject of ideas and mental representations as connected with the study of facts, will find a more appropriate place in the 4th book, on the operations subsidiary to induction, to which I must refer the reader for the removal of any difficulty which the present discussion may have left. End of section 30. Section 31 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 3, Chapter 3 of The Ground of Induction. Part 1. Induction, properly so called, as distinguished from those mental operations, sometimes, though improperly, designated by the name, which I have attempted in the preceding chapter to characterize, may, then, be summarily defined as generalization from experience. It consists in inferring from some individual instances in which a phenomenon is observed to occur, that it occurs in all instances of a certain class, namely, in all which resemble the former in what are regarded as the material circumstances. In what way the material circumstances are to be distinguished from those which are immaterial, or why some of the circumstances are material and others not so, we are not yet ready to point out. We must first observe that there is a principle implied in the very statement of what induction is, an assumption with regard to the course of nature and the order of the universe, namely, that there are such things in nature as parallel cases, that what happens once will, under a sufficient degree of similarity of circumstances, happen again, and not only again, but as often as the same circumstances recur. This, I say, is an assumption involved in every case of induction, and if we consult the actual course of nature, we find that the assumption is warranted. The universe, so far as known to us, is so constituted that whatever is true in any one case is true in all cases of a certain description. The only difficulty is to find what description. This universal fact, which is our warrant for all inferences from experience, has been described by different philosophers in different forms of language, that the course of nature is uniform, that the universe is governed by general laws, and the like. One of the most usual of these modes of expression, but also one of the most inadequate, is that which has been brought into familiar use by the metaphysicians of the school of Reid and Stuart. The disposition of the human mind to generalize from experience, a propensity considered by these philosophers as an instinct of our nature, they usually describe under some such name as, quote, our intuitive conviction that the future will resemble the past. End quote. Now, it has been well pointed out by Mr. Bailey that, whether the tendency be or not an original and ultimate element of our nature, time, in its modifications of past, present, and future, has no concern either with the belief itself or with the grounds of it. Footnote: Essays on the Pursuit of Truth. End footnote. We believe that fire will burn tomorrow because it burned today and yesterday. But we believe, on precisely the same grounds, that it burned before we were born, and that it burns this very day in Cochin, China. It is not from the past to the future, as past and future, that we infer, but from the known to the unknown, from facts observed to facts unobserved, from what we have perceived or been directly conscious of to what has not come within our experience. In this last predicament is the whole region of the future, but also the vastly greater portion of the present and of the past. Whatever be the most popular mode of expressing it, the proposition that the course of nature is uniform is the fundamental principle or general axiom of induction. It would yet be a great error to offer this large generalization as any explanation of the inductive process. On the contrary, I hold it to be itself an instance of induction and induction by no means of the most obvious kind. Far from being the first induction we make, it is one of the last, or, at all events, one of those which are latest in attaining strict philosophical accuracy. As a general maxim, indeed, it has scarcely entered into the minds of any but philosophers, nor even by them, as we shall have many opportunities of remarking, have its extent and limits been always very justly conceived. The truth is that this great generalization is itself founded on prior generalizations. The obscurer laws of nature were discovered by means of it, but the more obvious ones must have been understood and assented to as a general truth before it was ever heard of. We should never have thought of affirming that all phenomena take place according to general laws if we had not first arrived, in the case of a great multitude of phenomena, at some knowledge of the laws themselves, which could be done no otherwise than by induction. In what sense, then, can a principle which is so far from being our earliest induction be regarded as our warrant for all the others? In the only sense in which, as we have already seen, the general propositions which we place at the head of our reasonings when we throw them into syllogisms ever really contribute to their validity. As Archbishop Whately remarks, every induction is a syllogism with the major premise suppressed, or, as I prefer expressing it, every induction may be thrown into the form of a syllogism by supplying a major premise. If this be actually done, the principle which we are now considering, that of the uniformity of the course of nature, will appear as the ultimate major premise of all inductions, and will, therefore, stand to all inductions in the relation in which, as has been shown at so much length, the major proposition of a syllogism always stands to the conclusion, not contributing at all to prove it, but being a necessary condition of its being proved, since no conclusion is proved for which there cannot be found a true major premise. Footnote. In the first edition a note was appended at this place, containing some criticism on Archbishop Whately's mode of conceiving the relation between syllogism and induction. In a subsequent issue of his Logic, the Archbishop made a reply to the criticism, which induced me to cancel part of the note, incorporating the remainder in the text. In a still later edition, the Archbishop observes in a tone of something like disapprobation that the objections, quote, doubtless from their being fully answered and found untenable, were silently suppressed, end quote, and that hence he might appear to some of his readers to be combating a shadow. On this latter point, the Archbishop need give himself no uneasiness. His readers, I make bold to say, will fully credit his mere affirmation that the objections have actually been made. But as he seems to think that what he terms the suppression of the objections ought not to have been made silently, I now break that silence, and state exactly what it is that I suppressed, and why I suppressed that alone which might be regarded as personal criticism on the Archbishop. I had imputed to him the having omitted to ask himself a particular question. I found that he had asked himself the question, and could give it an answer consistent with his own theory. I had also, within the compass of a parenthesis, hazarded some remarks on certain general characteristics of Archbishop Whately as a philosopher. These remarks, though their tone, I hope, was neither disrespectful nor arrogant, I felt, on reconsideration, that I was hardly entitled to make, least of all when the instance which I had regarded as an illustration of them failed, as I now saw, to bear them out. The real matter at the bottom of the whole dispute, the different view we take of the function of the major premise, remains exactly where it was, and so far was I from thinking that my opinion had been fully answered and was untenable, that in the same edition in which I cancelled the note, I not only enforced the opinion by further arguments, but answered, though without naming him, those of the Archbishop. For not having made this statement before, I do not think it needful to apologize. It would be attaching very great importance to one's smallest sayings to think a formal retraction requisite every time that one falls into an error. Nor is Archbishop Whately's well-earned fame of so tender a quality as to require that in withdrawing a slight criticism on him I should have been bound to offer a public amends for having made it. End footnote. The statement that the uniformity of the course of nature is the ultimate major premise in all cases of induction may be thought to require some explanation. The immediate major premise in every inductive argument it certainly is not. Of that, Archbishop Whately's must be held to be the correct account. The induction, John, Peter, and so on, are mortal, therefore all mankind are mortal, may, as he justly says, be thrown into a syllogism by prefixing as a major premise, what is at any rate a necessary condition of the validity of the argument, namely, that what is true of John, Peter, and so on, is true of all mankind. But how came we by this major premise? It is not self-evident. Nay, in all cases of unwarranted generalization, it is not true. How, then, is it arrived at? Necessarily either by induction or ratiocination, and if by induction, the process, like all other inductive arguments, may be thrown into the form of a syllogism. This previous syllogism it is, therefore, necessary to construct. There is, in the long run, only one possible construction. The real proof that what is true of John, Peter, and so on, is true of all mankind can only be that a different supposition would be inconsistent with the uniformity which we know to exist in the course of nature. Whether there would be this inconsistency or not may be a matter of long and delicate inquiry, but unless there would, we have no sufficient ground for the major of the inductive syllogism. It hence appears that if we throw the whole course of any inductive argument into a series of syllogisms, we shall arrive by more or fewer steps at an ultimate syllogism, which will have for its major premise the principle or axiom of the uniformity of the course of nature. Footnote. But though it is a condition of the validity of every induction that there be uniformity in the course of nature, it is not a necessary condition that the uniformity should pervade all nature. It is enough that it pervades the particular class of phenomena to which the induction relates, an induction concerning the motions of the planets or the properties of the magnet would not be vitiated, though we were to suppose that wind and weather are the sport of chance, provided it be assumed that astronomical and magnetic phenomena are under the dominion of general laws. Otherwise, the early experience of mankind would have rested on a very weak foundation, for in the infancy of science it could not be known that all phenomena are regular in their course. Neither would it be correct to say that every induction by which we infer any truth implies the general fact of uniformity as foreknown. Even in reference to the kind of phenomena concerned, it implies either that this general fact is already known, or that we may now know it, as the conclusion, "The Duke of Wellington is mortal," drawn from the instances A, B, and C, implies either that we have already concluded all men to be mortal, or that we are now entitled to do so from the same evidence. A vast amount of confusion and paralogism respecting the grounds of induction would be dispelled by keeping in view these simple considerations. End footnote. It was not to be expected that in the case of this axiom, any more than of other axioms, there should be unanimity among thinkers with respect to the grounds on which it is to be received as true. I have already stated that I regard it as itself a generalization from experience. Others hold it to be a principle which, antecedently to any verification by experience, we are compelled by the constitution of our thinking faculty to assume as true. Having so recently, and at so much length, combated a similar doctrine as applied to the axioms of mathematics, by arguments which are in a great measure applicable to the present case, I shall defer the more particular discussion of this controverted point in regard to the fundamental axiom of induction until a more advanced period of our inquiry. Footnote. See sections 55 and 56 of this work, Book 3, Chapter 21. End footnote. At present it is of more importance to understand thoroughly the import of the axiom itself, for the proposition that the course of nature is uniform possesses rather the brevity suitable to popular than the precision requisite in philosophical language. Its terms require to be explained, and a stricter than their ordinary signification given to them, before the truth of the assertion can be admitted. Part 2. Every person's consciousness assures him that he does not always expect uniformity in the course of events. He does not always believe that the unknown will be similar to the known, that the future will resemble the past. Nobody believes that the succession of rain and fine weather will be the same in every future year as in the present. Nobody expects to have the same dreams repeated every night. On the contrary, everybody mentions it as something extraordinary if the course of nature is constant and resembles itself in these particulars. To look for constancy where constancy is not to be expected, as for instance that a day which has once brought good fortune will always be a fortunate day, is justly accounted superstition. The course of nature, in truth, is not only uniform, it is also infinitely various. Some phenomena are always seen to recur in the very same combinations in which we met with them at first. Others seem altogether capricious, while some, which we had been accustomed to regard as bound down exclusively to a particular set of combinations, we unexpectedly find detached from some of the elements with which we had hitherto found them conjoined, and united to others of quite a contrary description. To an inhabitant of Central Africa 50 years ago, no fact probably appeared to rest on more uniform experience than this, that all human beings are black. To Europeans, not many years ago, the proposition, all swans are white, appeared an equally unequivocal instance of uniformity in the course of nature. Further experience has proved to both that they were mistaken, but they had to wait 50 centuries for this experience. During that long time, mankind believed in a uniformity of the course of nature where no such uniformity really existed. According to the notion which the ancients entertained of induction, the foregoing were cases of as legitimate inference as any inductions whatever. In these two instances, in which the conclusion being false, the ground of inference must have been insufficient, there was, nevertheless, as much ground for it as this conception of induction admitted of. The induction of the ancients has been well described by Bacon under the name of Inductio per enumerationem simplicem ubi non reperitur instantia contradictoria. It consists in ascribing the character of general truths to all propositions which are true in every instance that we happen to know of. This is the kind of induction which is natural to the mind when unaccustomed to scientific methods. The tendency, which some call an instinct, and which others account for by association, to infer the future from the past, the known from the unknown, is simply a habit of expecting that what has been found true once or several times, and never yet found false, will be found true again. Whether the instances are few or many, conclusive or inconclusive, does not much affect the matter. These are considerations which occur only on reflection. The unprompted tendency of the mind is to generalize its experience, provided this points all in one direction, provided no other experience of a conflicting character comes unsought. The notion of seeking it, of experimenting for it, of interrogating nature, to use Bacon's expression, is of much later growth. The observation of nature by uncultivated intellects is purely passive. They accept the facts which present themselves without taking the trouble of searching for more. It is a superior mind only which asks itself what facts are needed to enable it to come to a safe conclusion, and then looks out for these. But though we have always a propensity to generalize from unvarying experience, we are not always warranted in doing so. Before we can be at liberty to conclude that something is universally true because we have never known an instance to the contrary, we must have reason to believe that if there were in nature any instances to the contrary, we should have known of them. This assurance, in the great majority of cases, we cannot have, or can have only in a very moderate degree. The possibility of having it is the foundation on which we shall see hereafter that induction by simple enumeration may, in some remarkable cases, amount practically to proof. Footnote. See sections 55, 56, and 57 of this work, Book 3, chapters 21 and 22. End footnote. No such assurance, however, can be had on any of the ordinary subjects of scientific inquiry. Popular notions are usually founded on induction by simple enumeration. In science it carries us but a little way. We are forced to begin with it. We must often rely on it provisionally, in the absence of means of more searching investigation, but for the accurate study of nature we require a surer and a more potent instrument. It was above all by pointing out the insufficiency of this rude and loose conception of induction that Bacon merited the title so generally awarded to him of founder of the inductive philosophy. The value of his own contributions to a more philosophical theory of the subject has certainly been exaggerated, although, along with some fundamental errors, his writings contain, more or less fully developed, several of the most important principles of the inductive method. Physical investigation has now far outgrown the Baconian conception of induction. Moral and political inquiry, indeed, are as yet far behind that conception. The current and approved modes of reasoning on these subjects are still of the same vicious description against which Bacon protested. The method almost exclusively employed by those professing to treat such matters inductively is the very inductio per enumerationem simplicem which he condemns, and the experience which we hear so confidently appealed to by all sects, parties, and interests is still, in his own emphatic words, mere palpatio. Part 3. In order to a better understanding of the problem which the logician must solve if he would establish a scientific theory of induction, let us compare a few cases of incorrect inductions with others which are acknowledged to be legitimate. Some, we know, which were believed for centuries to be correct, were nevertheless incorrect. That all swans are white cannot have been a good induction, since the conclusion has turned out erroneous. The experience, however, on which the conclusion rested was genuine. From the earliest records, the testimony of the inhabitants of the known world was unanimous on the point. The uniform experience, therefore, of the inhabitants of the known world, agreeing in a common result without one known instance of deviation from that result, is not always sufficient to establish a general conclusion. But let us now turn to an instance apparently not very dissimilar to this. Mankind were wrong, it seems, in concluding that all swans were white. Are we also wrong when we conclude that all men's heads grow above their shoulders and never below, in spite of the conflicting testimony of the naturalist Pliny? As there were black swans, though civilized people had existed for 3,000 years on the earth without meeting with them, may there not also be, men whose heads do grow beneath their shoulders, notwithstanding a rather less perfect unanimity of negative testimony from observers? Most persons would answer, no. It was more credible that a bird should vary its colour than that men should vary in the relative position of their principal organs, and there is no doubt that in so saying they would be right. But to say why they are right would be impossible, without entering more deeply than is usually done into the true theory of induction. Again, there are cases in which we reckon with the most unfailing confidence upon uniformity, and other cases in which we do not count upon it at all. In some, we feel complete assurance that the future will resemble the past, the unknown be precisely similar to the known. In others, however invariable may be the result obtained from the instances which have been observed, we draw from them no more than a very feeble presumption that the like result will hold in all other cases. That a straight line is the shortest distance between 2 points, we do not doubt to be true, even in the region of the fixed stars. Footnote. In strictness, wherever the present constitution of space exists, which we have ample reason to believe that it does in the region of the fixed stars. End footnote. When a chemist announces the existence and properties of a newly discovered substance, if we confide in his accuracy, we feel assured that the conclusions he has arrived at will hold universally, though the induction be founded but on a single instance. We do not withhold our assent, waiting for a repetition of the experiment, or, if we do, it is from a doubt whether the one experiment was properly made, not whether, if properly made, it would be conclusive. Here, then, is a general law of nature, inferred without hesitation from a single instance, a universal proposition from a singular one. Now mark another case, and contrast it with this. Not all the instances which have been observed since the beginning of the world in support of the general proposition that all crows are black would be deemed a sufficient presumption of the truth of the proposition to outweigh the testimony of one unexceptionable witness who should affirm that in some region of the earth not fully explored he had caught and examined a crow and had found it to be grey. Why is a single instance, in some cases, sufficient for a complete induction, while in others, myriads of concurring instances without a single exception known or presumed go such a very little way toward establishing a universal proposition? Whoever can answer this question knows more of the philosophy of logic than the wisest of the ancients, and has solved the problem of induction. End of section 31. Section 32 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 3, Chapter 4 of Laws of Nature. Part 1. In the contemplation of that uniformity in the course of nature which is assumed in every inference from experience, one of the first observations that present themselves is that the uniformity in question is not properly uniformity, but uniformities. The general regularity results from the coexistence of partial regularities. The course of nature in general is constant, because the course of each of the various phenomena that compose it is so. A certain fact invariably occurs whenever certain circumstances are present, and does not occur when they are absent. The like is true of another fact, and so on. From these separate threads of connection between parts of the great whole which we term nature, a general tissue of connection unavoidably weaves itself, by which the whole is held together. If A is always accompanied by D, B by E, and C by F, it follows that AB is accompanied by DE, AC by DF, BC by EF, and finally ABC by DEF, and thus the general character of regularity is produced, which, along with and in the midst of infinite diversity, pervades all nature. The first point, therefore, to be noted in regard to what is called the uniformity of the course of nature is that it is itself a complex fact, compounded of all the separate uniformities which exist in respect to single phenomena. These various uniformities, when ascertained by what is regarded as a sufficient induction, we call, in common parlance, laws of nature. Scientifically speaking, that title is employed in a more restricted sense to designate the uniformities when reduced to their most simple expression. Thus, in the illustration already employed, there were 7 uniformities, all of which, if considered sufficiently certain, would, in the more lax application of the term, be called laws of nature. But of the 7, 3 alone are properly distinct and independent, these being presupposed. The others follow, of course. The first 3, therefore, according to the stricter acceptation, are called laws of nature, the remainder not, because they are in truth mere cases of the first 3, virtually included in them, said, therefore, to result from them. Whoever affirms those 3 has already affirmed all the rest. To substitute real examples for symbolic ones, the following are 3 uniformities, or call them laws of nature. The law that air has weight, the law that pressure on a fluid is propagated equally in all directions, and the law that pressure in one direction, not opposed by equal pressure in the contrary direction, produces motion which does not cease until equilibrium is restored. From these 3 uniformities we should be able to predict another uniformity, namely, the rise of the mercury in the Torricellian tube. This, in the stricter use of the phrase, is not a law of nature. It is the result of laws of nature. It is a case of each and every one of the 3 laws, and is the only occurrence by which they could all be fulfilled. If the mercury were not sustained in the barometer, and sustained at such a height that the column of mercury were equal in weight to a column of the atmosphere of the same diameter, here would be a case either of the air not pressing upon the surface of the mercury with the force which is called its weight, or of the downward pressure on the mercury not being propagated equally in an upward direction, or of a body pressed in one direction and not in the direction opposite, either not moving in the direction in which it is pressed, or stopping before it had attained equilibrium. If we knew, therefore, the 3 simple laws, but had never tried the Torricellian experiment, we might deduce its result from those laws. The known weight of the air, combined with the position of the apparatus, would bring the mercury within the first of the 3 inductions. The first induction would bring it within the second, and the second within the third, in the manner which we characterized in treating of ratiocination. We should thus come to know the more complex uniformity independently of specific experience, through our knowledge of the simpler ones from which it results, though, for reasons which will appear hereafter, verification by specific experience would still be desirable, and might possibly be indispensable. Complex uniformities which, like this, are mere cases of simpler ones and have therefore been virtually affirmed in affirming those, may, with propriety, be called laws, but can scarcely in the strictness of scientific speech be termed laws of nature. It is the custom in science, wherever regularity of any kind can be traced, to call the general proposition which expresses the nature of that regularity a law, as when, in mathematics, we speak of the law of decrease of the successive terms of a converging series. But the expression law of nature has generally been employed with a sort of tacit reference to the original sense of the word law, namely, the expression of the will of a superior. When, therefore, it appeared that any of the uniformities which were observed in nature would result spontaneously from certain other uniformities, no separate act of creative will being supposed necessary for the production of the derivative uniformities, these have not usually been spoken of as laws of nature. According to one mode of expression, the question, "What are the laws of nature?" may be stated thus: what are the fewest and simplest assumptions which, being granted, the whole existing order of nature would result? Another mode of stating it would be thus: what are the fewest general propositions from which all the uniformities which exist in the universe might be deductively inferred? Every great advance which marks an epoch in the process of science has consisted in a step made toward the solution of this problem. Even a simple colligation of inductions already made, without any fresh extension of the inductive inference, is already an advance in that direction. When Kepler expressed the regularity which exists in the observed motions of the heavenly bodies by the three general propositions called his laws, he, in so doing, pointed out three simple suppositions which, instead of a much greater number, would suffice to construct the whole scheme of the heavenly motions so far as it was known up to that time. A similar and still greater step was made when these laws, which at first did not seem to be included in any more general truths, were discovered to be cases of the three laws of motion, as obtaining among bodies which mutually tend toward one another with a certain force, and have had a certain instantaneous impulse originally impressed upon them. After this great discovery, Kepler's three propositions, though still called laws, would hardly by any person accustomed to use language with precision be termed laws of nature. That phrase would be reserved for the simpler and more general laws into which Newton is said to have resolved them. According to this language, every well-grounded inductive generalization is either a law of nature or a result of laws of nature, capable, if those laws are known, of being predicted from them. And the problem of inductive logic may be summed up in two questions: how to discern the laws of nature, and how, after having ascertained them, to follow them into their results. On the other hand, we must not suffer ourselves to imagine that this mode of statement amounts to a real analysis, or to anything but a mere verbal transformation of the problem. For the expression laws of nature means nothing but the uniformities which exist among natural phenomena, or, in other words, the results of induction, when reduced to their simplest expression. It is, however, something to have advanced so far as to see that the study of nature is the study of laws, not a law, of uniformities, in the plural number, that the different natural phenomena have their separate rules or modes of taking place, which, though much intermixed and entangled with one another, may, to a certain extent, be studied apart, that, to resume our former metaphor, the regularity which exists in nature is a web composed of distinct threads, and only to be understood by tracing each of the threads separately. for which purpose it is often necessary to unravel some portion of the web and exhibit the fibers apart. The rules of experimental inquiry are the contrivances for unraveling the web. Part 2. In thus attempting to ascertain the general order of nature by ascertaining the particular order of the occurrence of each one of the phenomena of nature, the most scientific proceeding can be no more than an improved form of that which was primitively pursued by the human understanding, while undirected by science. When mankind first formed the idea of studying phenomena according to a stricter and surer method than that which they had in the first instance spontaneously adopted, they did not, conformably to the well-meant but impracticable precept of Descartes, set out from the supposition that nothing had been already ascertained. Many of the uniformities existing among phenomena are so constant and so open to observation as to force themselves upon involuntary recognition. Some facts are so perpetually and familiarly accompanied by certain others that mankind learned, as children learn, to expect the one where they found the other, long before they knew how to put their expectation into words by asserting, in a proposition, the existence of a connection between those phenomena. No science was needed to teach that food nourishes, that water drowns or quenches thirst, that the sun gives light and heat, that bodies fall to the ground. The first scientific inquirers assumed these and the like as known truths, and set out from them to discover others which were unknown. Nor were they wrong in so doing, subject, however, as they afterward began to see, to an ulterior revision of these spontaneous generalizations themselves, when the progress of knowledge pointed out limits to them, or showed their truth to be contingent on some circumstance not originally attended to. It will appear, I think, from the subsequent part of our inquiry, that there is no logical fallacy in this mode of proceeding, but we may see already that any other mode is rigorously impracticable, since it is impossible to frame any scientific method of induction or test of the correctness of inductions unless on the hypothesis that some inductions deserving of reliance have already been made. Let us revert, for instance, to one of our former illustrations and consider why it is that, with exactly the same amount of evidence, both negative and positive, we did not reject the assertion that there are black swans, while we should refuse credence to any testimony which asserted that there were men wearing their heads underneath their shoulders. The first assertion was more credible than the latter. But why more credible? So long as neither phenomenon had been actually witnessed, what reason was there for finding the one harder to be believed than the other? Apparently because there is less constancy in the colours of animals than in the general structure of their anatomy. But how do we know this? Doubtless from experience. It appears then that we need experience to inform us in what degree and in what cases, or sorts of cases, experience is to be relied on. Experience must be consulted in order to learn from it under what circumstances arguments from it will be valid. We have no ulterior test to which we subject experience in general, but we make experience its own test. Experience testifies that among the uniformities which it exhibits or seems to exhibit, some are more to be relied on than others, and uniformity, therefore, may be presumed from any given number of instances with a greater degree of assurance, in proportion as the case belongs to a class in which the uniformities have hitherto been found more uniform. This mode of correcting one generalization by means of another, and narrower generalization by a wider, which common sense suggests and adopts in practice, is the real type of scientific induction. All that art can do is but to give accuracy and precision to this process, and adapt it to all varieties of cases, without any essential alteration in its principle. There are, of course, no means of applying such a test as that above described, unless we already possess a general knowledge of the prevalent character of the uniformities existing throughout nature. The indispensable foundation, therefore, of a scientific formula of induction must be a survey of the inductions to which mankind have been conducted in unscientific practice, with the special purpose of ascertaining what kinds of uniformities have been found perfectly invariable, pervading all nature, and what are those which have been found to vary with difference of time, place, or other changeable circumstances. Part 3. The necessity of such a survey is confirmed by the consideration that the stronger inductions are the touchstone to which we always endeavour to bring the weaker. If we find any means of deducing one of the less strong inductions from stronger ones, it acquires at once all the strength of those from which it is deduced, and even adds to that strength, since the independent experience on which the weaker induction previously rested becomes additional evidence of the truth of the better established law in which it is now found to be included. We may have inferred from historical evidence that the uncontrolled power of a monarch, of an aristocracy, or of the majority will often be abused, but we are entitled to rely on this generalization with much greater assurance when it is shown to be a corollary from still better established facts. The very low degree of elevation of character ever yet attained by the average of mankind, and the little efficacy, for the most part, of the modes of education hitherto practiced, in maintaining the predominance of reason and conscience over the selfish propensities. It is at the same time obvious that even these more general facts derive an accession of evidence from the testimony which history bears to the effects of despotism. The strong induction becomes still stronger when a weaker one has been bound up with it. On the other hand, if an induction conflicts with stronger inductions, or with conclusions capable of being correctly deduced from them, then, unless on reconsideration it should appear that some of the stronger inductions have been expressed with greater universality than their evidence warrants, the weaker one must give way. The opinion so long prevalent that a comet or any other unusual appearance in the heavenly regions was the precursor of calamities to mankind, or to those at least who witnessed it, the belief in the veracity of the oracles of Delphi or Dodona, the reliance on astrology, or on the weather prophecies in almanacs, were doubtless inductions supposed to be grounded on experience, and faith in such delusions seems quite capable of holding out against a great multitude of failures, provided it be nourished by a reasonable number of casual coincidences between the prediction and the event. Footnote. Dr. Whewell, Philosophy of Discovery, page 246, will not allow these and similar erroneous judgments to be called inductions, inasmuch as such superstitious fancies, quote, were not collected from the facts by seeking a law of their occurrence, but were suggested by an imagination of the anger of superior powers shown by such deviations from the ordinary course of nature. End quote. I conceive the question to be, not in what manner these notions were at first suggested, but by what evidence they have, from time to time, been supposed to be substantiated. If the believers in these erroneous opinions had been put on their defence, they would have referred to experience, to the comet which preceded the assassination of Julius Caesar, or to the oracles and other prophecies known to have been fulfilled. It is by such appeals to facts that all analogous superstitions, even in our day, attempt to justify themselves, the supposed evidence of experience is necessary to their hold on the mind. I quite admit that the influence of such coincidences would not be what it is if strength were not lent to it by an antecedent presumption. But this is not peculiar to such cases. Preconceived notions of probability form part of the explanation of many other cases of belief on insufficient evidence. The a priori prejudice does not prevent the erroneous opinion from being sincerely regarded as a legitimate conclusion from experience, though it improperly predisposes the mind to that interpretation of experience. Thus, much in defense of the sort of examples objected to. But it would be easy to produce instances equally adapted to the purpose and in which no antecedent prejudice is at all concerned. Quote, "For many ages," says Archbishop Whately, "all farmers and gardeners were firmly convinced, and convinced of their knowing it by experience, that the crops would never turn out good unless the seed were sown during the increase of the moon." End quote. This was induction, but bad induction, just as a vicious syllogism is reasoning, but bad reasoning. End footnote. What has really put an end to these insufficient inductions is their inconsistency with the stronger inductions subsequently obtained by scientific inquiry respecting the causes on which terrestrial events really depend, and where those scientific truths have not yet penetrated, the same or similar delusions still prevail. It may be affirmed as a general principle that all inductions, whether strong or weak, which can be connected by ratiocination, are confirmatory of one another, while any which lead deductively to consequences that are incompatible become mutually each other's test, showing that one or other must be given up, or at least more guardedly expressed. In the case of inductions which confirm each other, the one which becomes a conclusion from ratiocination rises to at least the level of certainty of the weakest of those from which it is deduced, while in general all are more or less increased in certainty. Thus, the Torricellian experiment, though a mere case of three more general laws, not only strengthened greatly the evidence on which those laws rested, but converted one of them, the weight of the atmosphere, from a still doubtful generalization into a completely established doctrine. If, then, a survey of the uniformities which have been ascertained to exist in nature should point out some which, as far as any human purpose requires certainty, may be considered quite certain and quite universal, then by means of these uniformities we may be able to raise multitudes of other inductions to the same point in the scale. For if we can show, with respect to any inductive inference, that either it must be true, or one of these certain and universal inductions must admit of an exception, the former generalization will attain the same certainty and indefeasibleness within the bounds assigned to it, which are the attributes of the latter. It will be proved to be a law, and, if not a result of other and simpler laws, it will be a law of nature. There are such certain and universal inductions, and it is because there are such that a logic of induction is possible. End of section 32. Section 33 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 3, Chapter 5 of the Law of Universal Causation, Parts 1 through 5. Part 1. The phenomena of nature exist in two distinct relations to one another, that of simultaneity and that of succession. Every phenomenon is related in a uniform manner to some phenomena that coexist with it, and to some that have preceded and will follow it. Of the uniformities which exist among synchronous phenomena, the most important on every account are the laws of number, and next to them those of space, or in other words, of extension and figure. The laws of number are common to synchronous and successive phenomena. That 2 and 2 make 4 is equally true whether the second 2 follow the first 2 or accompany them. It is as true of days and years as of feet and inches. The laws of extension and figure, in other words, the theorems of geometry from its lowest to its highest branches, are, on the contrary, laws of simultaneous phenomena only. The various parts of space and of the objects which are said to fill space coexist, and the unvarying laws which are the subject of the science of geometry are an expression of the mode of their coexistence. This is a class of laws, or in other words, of uniformities, for the comprehension and proof of which it is not necessary to suppose any lapse of time, any variety of facts or events succeeding one another. The propositions of geometry are independent of the succession of events. All things which possess extension, or, in other words, which fill space, are subject to geometrical laws. Possessing extension, they possess figure. Possessing figure, they must possess some figure in particular, and have all the properties which geometry assigns to that figure. If one body be a sphere, and another a cylinder of equal height and diameter, the one will be exactly 2/3 of the other, let the nature and quality of the material be what it will. Again, each body and each point of a body must occupy some place or position among other bodies, and the position of two bodies, relatively to each other, of whatever nature the bodies be, may be unerringly inferred from the position of each of them relatively to any third body. In the laws of number, then, and in those of space, we recognize in the most unqualified manner the rigorous universality of which we are in quest. Those laws have been in all ages the type of certainty, the standard of comparison for all inferior degrees of evidence. Their invariability is so perfect that it renders us unable even to conceive any exception to them, and philosophers have been led, though, as I have endeavoured to show, erroneously, to consider their evidences lying not in experience, but in the original constitution of the intellect. If, therefore, from the laws of space and number we were able to deduce uniformities of any other description, this would be conclusive evidence to us that those other uniformities possessed the same rigorous certainty. But this we cannot do. From laws of space and number alone, nothing can be deduced but laws of space and number. Of all truths relating to phenomena, the most valuable to us are those which relate to the order of their succession. On a knowledge of these is founded every reasonable anticipation of future facts, and whatever power we possess of influencing those facts to our advantage. Even the laws of geometry are chiefly of practical importance to us as being a portion of the premises from which the order of the succession of phenomena may be inferred. Inasmuch as the motion of bodies, the action of forces, and the propagation of influences of all sorts take place in certain lines and over definite spaces, the properties of those lines and spaces are an important part of the laws to which those phenomena are themselves subject. Again, motions, forces, or other influences and times are numerable quantities, and the properties of number are applicable to them as to all other things. But though the laws of number and space are important elements in the ascertainment of uniformities of succession, they can do nothing toward it when taken by themselves. they can only be made instrumental to that purpose when we combine them with additional premises expressive of uniformities of succession already known. By taking, for instance, as premises these propositions, that bodies acted upon by an instantaneous force move with uniform velocity in straight lines, that bodies acted upon by a continuous force move with accelerated velocity in straight lines, and that bodies acted upon by two forces in different directions move in the diagonal of a parallelogram, whose sides represent the direction and quantity of those forces, we may, by combining these truths with propositions relating to the properties of straight lines and of parallelograms, as that a triangle is half a parallelogram of the same base and altitude, deduce another important uniformity of succession, that is, that a body moving round a center of force describes areas proportional to the times. But unless there had been laws of succession in our premises, there could have been no truths of succession in our conclusions. A similar remark might be extended to every other class of phenomena really peculiar, and had it been attended to, would have prevented many chimerical attempts at demonstrations of the indemonstrable, and explanations which do not explain. It is not, therefore, enough for us that the laws of space, which are only laws of simultaneous phenomenon, and the laws of number, which, though true of successive phenomena, do not relate to their succession, possess the rigorous certainty and universality of which we are in search. We must endeavour to find some law of succession which has those same attributes, and is therefore fit to be made the foundation of processes for discovering, and of a test for verifying, all other uniformities of succession. This fundamental law must resemble the truths of geometry in their most remarkable peculiarity, that of never being, in any instance whatever, defeated or suspended by any change of circumstances. Now, among all those uniformities in the succession of phenomena which common observation is sufficient to bring to light, there are very few which have any even apparent pretension to this rigorous indefeasibility, and of those few one only has been found capable of completely sustaining it. In that one, however, we recognize a law which is universal also in another sense. It is coextensive with the entire field of successive phenomena, all instances whatever of succession being examples of it. This law is the law of causation, the truth that every fact which has a beginning, has a cause, is coextensive with human experience. This generalization may appear to some minds not to amount to much, since after all it asserts only this. Quote, "It is a law that every event depends on some law." End quote. Quote, "It is a law that there is a law for everything." End quote. We must not, however, conclude that the generality of the principle is merely verbal. It will be found on inspection to be no vague or unmeaning assertion, but a most important and really fundamental truth. Part 2. The notion of cause being the root of the whole theory of induction, it is indispensable that this idea should, at the very outset of our inquiry, be, with the utmost practicable degree of precision, fixed and determined. If, indeed, it were necessary for the purpose of inductive logic that the strife should be quelled, which has so long raged among the different schools of metaphysicians, respecting the origin and analysis of our idea of causation, the promulgation, or at least the general reception, of a true theory of induction, might be considered desperate for a long time to come. But the science of the investigation of truth by means of evidence is happily independent of many of the controversies which perplex the science of the ultimate constitution of the human mind, and is under no necessity of pushing the analysis of mental phenomenon to that extreme limit which alone ought to satisfy a metaphysician. I premise, then, that when in the course of this inquiry I speak of the cause of any phenomenon, I do not mean a cause which is not itself a phenomenon. I make no research into the ultimate or ontological cause of anything. To adopt a distinction familiar in the writings of the Scotch metaphysicians, and especially of Reid, the causes with which I concern myself are not efficient but physical causes. They are causes in that sense alone, in which one physical fact is said to be the cause of another. Of the efficient causes of phenomena, or whether any such causes exist at all, I am not called upon to give an opinion. The notion of causation is deemed by the schools of metaphysics most in vogue at the present moment to imply a mysterious and most powerful tie, such as cannot, or at least does not, exist between any physical fact and that other physical fact on which it is invariably consequent, and which is popularly termed its cause, and thence is deduced the supposed necessity of ascending higher into the essences and inherent constitution of things to find the true cause, the cause which is not only followed by but actually produces the effect. No such necessity exists for the purposes of the present enquiry, nor will any such doctrine be found in the following pages. The only notion of a cause which the theory of induction requires is such a notion as can be gained from experience. The law of causation, the recognition of which is the main pillar of inductive science, is but the familiar truth that invariability of succession is found by observation to obtain between every fact in nature and some other fact which has preceded it, independently of all considerations respecting the ultimate mode of production of phenomena and of every other question regarding the nature of things in themselves. Between the phenomena, then, which exist at any instant, and the phenomena which exist at the succeeding instant, there is an invariable order of succession, and, as we said in speaking of the general uniformity of the course of nature, this web is composed of separate fibres. This collective order is made up of particular sequences, obtaining invariably among the separate parts. To certain facts always do and, as we believe, will continue to succeed. The invariable antecedent is termed the cause, the invariable consequent the effect, and the universality of the law of causation consists in this, that every consequent is connected in this manner with some particular antecedent or set of antecedents. Let the fact be what it may. If it has begun to exist, it was preceded by some fact or facts with which it is invariably connected. For every event there exists some combination of objects or events, some given concurrence of circumstances, positive and negative, the occurrence of which is always followed by that phenomenon. We may not have found out what this occurrence of circumstances may be, but we never doubt that there is such a one, and that it never occurs without having the phenomenon in question as its effect or consequence. On the universality of this truth depends the possibility of reducing the inductive process to rules. The undoubted assurance we have that there is a law to be found, if we only knew how to find it, will be seen presently to be the source from which the canons of the inductive logic derive their validity. Part 3. It is seldom, if ever, between a consequent and a single antecedent that this invariable sequence subsists. It is usually between a consequent and the sum of several antecedents, the concurrence of all of them being requisite to produce, that is, to be certain of being followed by, the consequent. In such cases it is very common to single out one only of the antecedents under the denomination of cause, calling the others merely conditions. Thus, if a person eats of a particular dish and dies in consequence, that is, would not have died if he had not eaten of it, people would be apt to say that eating of that dish was the cause of his death. There needs not, however, be any invariable connection between eating of the dish and death, but there certainly is, among the circumstances which took place, some combination or other on which death is invariably consequent, as, for instance, the act of eating the dish combined with a particular bodily constitution, a particular state of present health, and, perhaps, even a certain state of the atmosphere, the whole of which circumstances perhaps constituted in this particular case the conditions of the phenomenon, or, in other words, the set of antecedents which determined it, and but for which it would not have happened. The real cause is the whole of these antecedents, and we have, philosophically speaking, no right to give the name of cause to one of them exclusively of the others. What, in the case we have supposed, disguises the incorrectness of the expression is this, that the various conditions, except the single one of eating the food, were not events, that is, instantaneous changes or successions of instantaneous changes, but states possessing more or less of permanency, and might therefore have preceded the effect by an indefinite length of duration, for want of the event which was requisite to complete the required concurrence of conditions, while as soon as that event, eating the food, occurs, no other cause is waited for, but the effect begins immediately to take place, and hence the appearance is presented of a more immediate and close connection between the effect and that one antecedent than between the effect and the remaining conditions. But though we may think proper to give the name of cause to that one condition, the fulfilment of which completes the tale and brings about the effect without further delay, this condition has really no closer relation to the effect than any of the other conditions has. All the conditions were equally indispensable to the production of the consequent, and the statement of the cause is incomplete unless in some shape or other we introduce them all. A man takes mercury, goes out of doors, and catches cold. We say perhaps that the cause of his taking cold was exposure to the air. It is clear, however, that his having taken mercury may have been a necessary condition of his catching cold, and though it might consist with usage to say that the cause of his attack was exposure to the air, to be accurate we ought to say that the cause was exposure to the air while under the effect of mercury. If we do not, when aiming at accuracy, enumerate all the conditions, it is only because some of them will, in most cases, be understood without being expressed, or because, for the purpose in view, they may without detriment be overlooked. For example, when we say the cause of a man's death was that his foot slipped in climbing a ladder, we omit as a thing unnecessary to be stated the circumstance of his weight, though quite as indispensable a condition of the effect which took place. When we say that the assent of the crown to a bill makes it law, we mean that the assent, being never given until all the other conditions are fulfilled, makes up the sum of the conditions, though no one now regards it as the principal one. When the decision of a legislative assembly has been determined by the casting vote of the chairman, we sometimes say that this one person was the cause of all the effects which resulted from the enactment. Yet we do not really suppose that his single vote contributed more to the result than that of any other person who voted in the affirmative. But for the purpose we have in view, which is to insist on his individual responsibility, the part which any other person had in the transaction is not material. In all these instances, the fact which was dignified with the name of cause was the one condition which came last into existence, but it must not be supposed that in the employment of the term this or any other rule is always adhered to. Nothing can better show the absence of any scientific ground for the distinction between the cause of a phenomenon and its conditions than the capricious manner in which we select from among the conditions that which we choose to denominate the cause. However numerous the conditions may be, there is hardly any of them which may not, according to the purpose of our immediate discourse, obtain that nominal preeminence. This will be seen by analyzing the conditions of some one familiar phenomenon. For example, a stone thrown into water falls to the bottom. What are the conditions of this event? In the first place, there must be a stone and water, and the stone must be thrown into the water. But these suppositions forming part of the enunciation of the phenomenon itself, to include them also among the conditions would be a vicious tautology, and this class of conditions, therefore, have never received the name of cause from any but the Aristotelians, by whom they were called the material cause, causa materialis. The next condition is, therefore, there must be an earth, and accordingly it is often said that the fall of a stone is caused by the earth, or by a power or property of the earth, or a force exerted by the earth, all of which are merely roundabout ways of saying that it is caused by the earth, or, lastly, the earth's attraction, which also is only a technical mode of saying that the earth causes the motion, with the additional particularity that the motion is towards the earth, which is not a character of the cause, but of the effect. Let us now pass to another condition. It is not enough that the earth should exist. The body must be within that distance from it in which the earth's attraction preponderates over that of any other body. Accordingly, we may say, and the expression would be confessedly correct, that the cause of the stone's falling is its being within the sphere of the earth's attraction. We proceed to a further condition. The stone is immersed in water. It is therefore a condition of its reaching the ground that its specific gravity exceed that of the surrounding fluid, or in other words, that it surpass in weight an equal volume of water. Accordingly, any one would be acknowledged to speak correctly who said that the cause of the stone's going to the bottom is its exceeding in specific gravity the fluid in which it is immersed. Thus we see that each and every condition of the phenomenon may be taken in its turn, and, with equal propriety in common parlance, but with equal impropriety in scientific discourse, may be spoken of as if it were the entire cause, and in practice that particular condition is usually styled the cause, whose share in the matter is superficially the most conspicuous, or whose requisiteness to the production of the effect we happen to be insisting on at the moment. So great is the force of this last consideration that it sometimes induces us to give the name of cause even to one of the negative conditions. We say, for example, the army was surprised because the sentinel was off his post. But since the sentinel's absence was not what created the enemy, or put the soldiers asleep, how did it cause them to be surprised? All that is really meant is that the event would not have happened if he had been at his duty. His being off his post was no producing cause, but the mere absence of a preventing cause. It was simply equivalent to his non-existence. From nothing, from a mere negation, no consequences can proceed. All effects are connected by the law of causation with some set of positive conditions, negative ones, it is true, being almost always required in addition. In other words, Every fact or phenomenon which has a beginning invariably arises when some certain combination of positive facts exists, provided certain other positive facts do not exist. There is, no doubt, a tendency, which our first example, that of death from taking a particular food, sufficiently illustrates, to associate the idea of causation with the proximate antecedent event, rather than with any of the antecedent states or permanent facts, which may happen also to be conditions of the phenomenon. The reason being that the event not only exists, but begins to exist immediately previous, while the other conditions may have pre-existed for an indefinite time. And this tendency shows itself very visibly in the different logical fictions which are resorted to, even by men of science, to avoid the necessity of giving the name of cause to anything which had existed for an indeterminate length of time before the effect. Thus, rather than say that the earth causes the fall of bodies, they ascribe it to a force exerted by the earth, or an attraction by the earth, abstractions which they can represent to themselves as exhausted by each effort, and therefore constituting at each successive instant a fresh fact, simultaneous with, or only immediately preceding, the effect. Inasmuch as the coming of the circumstance which completes the assemblage of conditions is a change or event, it thence happens that an event is always the antecedent in closest apparent proximity to the consequent, and this may account for the illusion which disposes us to look upon the proximate event as standing more peculiarly in the position of a cause than any of the antecedent states. But even this peculiarity of being in closer proximity to the effect than any other of its conditions is, as we have already seen, far from being necessary to the common notion of a cause, with which notion, on the contrary, any one of the conditions, either positive or negative, is found, on occasion, completely to accord. Footnote: the assertion that any and every one of the conditions of a phenomenon may be and is on some occasions and for some purposes spoken of as the cause has been disputed by an intelligent reviewer of this work in the Prospective Review, the predecessor of the justly esteemed National Review, who maintains that, quote, we always apply the word cause rather to that element in the antecedents which exercises force, and which would tend at all times to produce the same or a similar effect to that which, under certain conditions, it would actually produce. End quote. And he says that everyone would feel the expression that the cause of a surprise was the sentinel's being off his post to be incorrect, but that the, quote, allurement or force which drew him off his post might be so called because, in doing so, it removed a resisting power which would have prevented the surprise. End quote. I cannot think that it would be wrong to say that the event took place because the sentinel was absent, and yet right to say that it took place because he was bribed to be absent. Since the only direct effect of the bribe was his absence, the bribe could be called the remote cause of the surprise, only on the supposition that the absence was the proximate cause, nor does it seem to me that anyone, who had not a theory to support, would use the one expression and reject the other. The reviewer observes that when a person dies of poison, his possession of bodily organs is a necessary condition, but that no one would ever speak of it as the cause. I admit the fact, but I believe the reason to be that the occasion could never arise for so speaking of it. For when, in the inaccuracy of common discourse, we are led to speak of some one condition of a phenomenon as its cause, the condition so spoken of is always one which it is at least possible that the hearer may require to be informed of. The possession of bodily organs is a known condition, and to give that as the answer when asked the cause of a person's death would not supply the information sought. Once conceive that a doubt could exist as to his having bodily organs, or that he were to be compared with some being who had them not, and cases may be imagined in which it might be said that his possession of them was the cause of his death. If Faust and Mephistopheles together took poison, it might be said that Faust died because he was a human being and had a body, while Mephistopheles survived because he was a spirit. It is for the same reason that no one, as the reviewer remarks, quote, calls the cause of a leap the muscles or sinews of the body, though they are necessary conditions, nor the cause of a self-sacrifice the knowledge which was necessary for it, nor the cause of writing a book that a man has time for it, which is a necessary condition. End quote. These conditions, besides that they are antecedent states and not proximate antecedent events, and are therefore never the conditions in closest apparent proximity to the effect, are all of them so obviously implied that it is hardly possible there should exist that necessity for insisting on them, which alone gives occasion for speaking of a single condition as if it were the cause. Wherever this necessity exists in regard to some one condition and does not exist in regard to any other, I conceive that it is consistent with usage, when scientific accuracy is not aimed at, to apply the name cause to that one condition. If the only condition which can be supposed to be unknown is a negative condition, the negative condition may be spoken of as the cause. It might be said that a person died for want of medical advice, though this would not be likely to be said unless the person was already understood to be ill. And in order to indicate that this negative circumstance was what made the illness fatal, and not the weakness of his constitution or the original virulence of the disease, it might be said that a person was drowned because he could not swim. The positive condition, namely that he fell into the water, being already implied in the word drowned. And here let me remark that his falling into the water is, in this case, the only positive condition. All the conditions not expressly or virtually included in this, as that he could not swim, that nobody helped him, and so forth, are negative. Yet, if it were simply said that the cause of a man's death was falling into the water, there would be quite as great a sense of impropriety in the expression as there would be if it were said that the cause was his inability to swim, because though the one condition is positive and the other negative, it would be felt that neither of them was sufficient without the other to produce death. With regard to the assertion that nothing is termed the cause except the element which exerts active force, I waive the question as to the meaning of active force and accept the phrase in its popular sense. I revert to a former example, and I ask, would it be more agreeable to custom to say that a man fell because his foot slipped in climbing a ladder, or that he fell because of his weight? For his weight, and not the motion of his foot, was the active force which determined his fall. If a person walking out in a frosty day stumbled and fell, it might be said that he stumbled because the ground was slippery, or because he was not sufficiently careful. But few people, I suppose, would say that he stumbled because he walked. Yet the only active force concerned was that which he exerted in walking. The others were mere negative conditions, but they happened to be the only ones which there could be any necessity to state, for he walked, most likely, in exactly his usual manner, and the negative conditions made all the difference. Again, if a person were asked why the army of Xerxes defeated that of Leonidas, he would probably say, because they were 1,000 times the number. But I do not think he would say, it was because they fought, though that was the element of active force. To borrow another example used by Mr. Grove and by Mr. Baden-Powell, the opening of the floodgates is said to be the cause of the flow of water, yet the active force is exerted by the water itself, and opening the floodgates merely supplies a negative condition. The reviewer adds, quote, "There are some conditions absolutely passive and yet absolutely necessary to physical phenomena, that is, the relations of space and time, and to these no one ever applies the word cause without being immediately arrested by those who hear him." End quote. Even from this statement I am compelled to dissent. Few persons would feel it incongruous to say, for example, that a secret became known because it was spoken of when A, B was within hearing, which is a condition of space, or that the cause why one of two particular trees is taller than the other is that it has been longer planted, which is a condition of time. End footnote. The cause, then, philosophically speaking, is the sum total of the conditions, positive and negative, taken together, the whole of the contingencies of every description, which, being realized, the consequent invariably follows. The negative conditions, however, of any phenomenon, a special enumeration of which would generally be very prolix, may be all summed up under one head, namely, the absence of preventing or counteracting causes. The convenience of this mode of expression is mainly grounded on the fact that the effects of any cause in counteracting another cause may, in most cases, be, with strict scientific exactness, regarded as a mere extension of its own proper and separate effects. If gravity retards the upward motion of a projectile and deflects it into a parabolic trajectory, it produces, in so doing, the very same kind of effect, and even, as mathematicians know, the same quantity of effect as it does in its ordinary operation of causing the fall of bodies when simply deprived of their support. If an alkaline solution mixed with an acid destroys its sourness and prevents it from reddening vegetable blues, it is because the specific effect of the alkali is to combine with the acid and form a compound with totally different qualities. This property, which causes of all descriptions possess, of preventing the effects of other causes by virtue, for the most part, of the same laws according to which they produce their own, enables us, by establishing the general axiom that all causes are liable to be counteracted in their effects by one another, to dispense with the consideration of negative conditions entirely, and limit the notion of cause to the assemblage of the positive conditions of the phenomenon. One negative condition invariably understood, and the same in all instances, namely, the absence of counteracting causes, being sufficient, along with the sum of the positive conditions, to make up the whole set of circumstances on which the phenomenon is dependent. Footnote. There are few exceptions, for there are some properties of objects which seem to be purely preventative, as the property of opaque bodies by which they intercept the passage of light. This, as far as we are able to understand it, appears an instance not of one cause counteracting another by the same law, whereby it produces its own effects, but of an agency which manifests itself in no other way than in defeating the effects of another agency. If we knew on what other relations to light or on what peculiarities of structure opacity depends, we might find that this is only an apparent, not a real exception to the general proposition in the text. In any case, it needs not affect the practical application. The formula which includes all the negative conditions of an effect in the single one of the absence of counteracting causes is not violated by such cases as this, though, if all counteracting agencies were of this description, there would be no purpose served by employing the formula. End footnote. Part 4. Among the positive conditions, as we have seen that there are some to which, in common parlance, the term cause is more readily and frequently awarded, so there are others to which it is, in ordinary circumstances, refused. In most cases of causation, a distinction is commonly drawn between something which acts and some other thing which is acted upon, between an agent and a patient. Both of these, it would be universally allowed, are conditions of the phenomenon, but it would be thought absurd to call the latter the cause, that title being reserved for the former. The distinction, however, vanishes on examination, or rather is found to be only verbal, arising from an incident of mere expression, namely, that the object said to be acted upon, and which is considered as the scene in which the effect takes place, is commonly included in the phrase by which the effect is spoken of, so that if it were also reckoned as part of the cause, the seeming incongruity would arise of its being supposed to cause itself. In the instance which we have already had of falling bodies, the question was thus put: what is the cause which makes a stone fall? And if the answer had been the stone itself, the expression would have been in apparent contradiction to the meaning of the word cause. The stone, therefore, is conceived as the patient, and the earth, or according to the common and most unphilosophical practice, an occult quality of the earth, is represented as the agent or cause. But that there is nothing fundamental in the distinction may be seen from this, that it is quite possible to conceive the stone as causing its own fall, provided the language employed be such as to save the mere verbal incongruity. We might say that the stone moves towards the earth by the properties of the matter composing it, and according to this mode of presenting the phenomenon, the stone itself might, without impropriety, be called the agent, though, to save the established doctrine of the inactivity of matter, men usually prefer here also to ascribe the effect to an occult quality, and say that the cause is not the stone itself, but the weight or gravitation of the stone. Those who have contended for a radical distinction between agent and patient have generally conceived the agent as that which causes some state of, or some change in the state of, another object, which is called the patient. But a little reflection will show that the license we assume of speaking of phenomena as states of the various objects which take part in them, an artifice of which so much use has been made by some philosophers, Brown in particular, for the apparent explanation of phenomena, is simply a sort of logical fiction, useful sometimes as one among several modes of expression, but which should never be supposed to be the enunciation of a scientific truth. Even those attributes of an object which might seem with greatest propriety to be called states of the object itself, its sensible qualities, its colour, hardness, shape, and the like, are in reality, as no one has pointed out more clearly than Brown himself, phenomena of causation, in which the substance is distinctly the agent or producing cause, the patient being our own organs and those of other sentient beings. What we call states of objects are always sequences into which the objects enter, generally as antecedents or causes, and things are never more active than in the production of those phenomena in which they are said to be acted upon. Thus, in the example of a stone falling to the earth, according to the theory of gravitation, the stone is as much an agent as the earth, which not only attracts, but is itself attracted by, the stone. In the case of a sensation produced in our organs, the laws of our organization, and even those of our minds, are as directly operative in determining the effect produced as the laws of the outward object. Though we call prussic acid the agent of a person's death, the whole of the vital and organic properties of the patient are as actively instrumental as the poison in the chain of effects which so rapidly terminates his sentient existence. In the process of education, we may call the teacher the agent, and the scholar only the material acted upon. Yet in truth, all the facts which pre-existed in the scholar's mind exert either cooperating or counteracting agencies in relation to the teacher's efforts. It is not light alone which is the agent in vision, but light coupled with the active properties of the eye and brain, and with those of the visible object. The distinction between agent and patient is merely verbal. Patients are always agents, in a great proportion, indeed, of all natural phenomena. They are so to such a degree as to react forcibly on the causes which acted upon them, and even when this is not the case, they contribute in the same manner as any of the other conditions to the production of the effect of which they are vulgarly treated as the mere theatre. All the positive conditions of a phenomenon are alike agents, alike active, and in any expression of the cause which professes to be complete, none of them can with reason be excluded, except such as have already been implied in the words used for describing the effect. Nor by including even these would there be incurred any but a merely verbal impropriety. Part 5. There is a case of causation which calls for separate notice, as it possesses a peculiar feature, and presents a greater degree of complexity than the common case. It often happens that the effect, or one of the effects, of a cause is not to produce of itself a certain phenomenon, but to fit something else for producing it. In other words, there is a case of causation in which the effect is to invest an object with a certain property. When sulphur, charcoal, and nitre are put together in certain proportions and in a certain manner, the effect is not an explosion, but that the mixture acquires a property by which, in given circumstances, it will explode. The various causes, natural and artificial, which educate the human body or the human mind, have for their principal effect not to make the body or mind immediately do anything, but to endow it with certain properties. In other words, to give assurance that in given circumstances certain results will take place in it, or as consequences of it. Physiological agencies often have for the chief part of their operation to predispose the constitution to some mode of action. To take a simpler instance than all of these, putting a coat of white paint upon a wall does not merely produce in those who see it done the sensation of white, it confers on the wall the permanent property of giving that kind of sensation. Regarded in reference to the sensation, the putting on of the paint is a condition of a condition. It is a condition of the wall's causing that particular fact. The wall may have been painted years ago, but it has acquired a property which has lasted till now and will last longer. The antecedent condition necessary to enable the wall to become in its turn a condition has been fulfilled once for all. In a case like this, where the immediate consequent in the sequence is a property produced in an object, no one now supposes the property to be a substantive entity inherent in the object. What has been produced is what, in other language, may be called a state of preparation in an object for producing an effect. The ingredients of the gunpowder have been brought into a state of preparation for exploding as soon as the other conditions of an explosion shall have occurred. In the case of the gunpowder, this state of preparation consists in a certain collocation of its particles relatively to one another. In the example of the wall, it consists in a new collocation of two things relatively to each other, the wall and the paint. In the example of the moulding influences on the human mind, its being a collocation at all is only conjectural, for even on the materialistic hypothesis it would remain to be proved that the increased facility with which the brain sums up a column of figures when it has been long trained to calculation is the result of a permanent new arrangement of some of its material particles. We must, therefore, content ourselves with what we know, and must include among the effects of causes the capacities given to objects of being causes of other effects. This capacity is not a real thing existing in the objects, it is but a name for our conviction that they will act in a particular manner when certain new circumstances arise. We may invest this assurance of future events with a fictitious objective existence by calling it a state of the object, but unless the state consists, as in the case of the gunpowder, it does in a collocation of particles, it expresses no present fact, it is but the contingent future fact brought back under another name. It may be thought that this form of causation requires us to admit an exception to the doctrine, that the conditions of a phenomenon, the antecedents required for calling it into existence, must all be found among the facts immediately, not remotely, preceding its commencement. But what we have arrived at is not a correction, it is only an explanation of that doctrine. In the enumeration of the conditions required for the occurrence of any phenomenon, it always has to be included that objects must be present, possessed of given properties. It is a condition of the phenomenon explosion that an object should be present of one or other of certain kinds which, for that reason, are called explosive. The presence of one of these objects is a condition immediately precedent to the explosion. The condition which is not immediately precedent is the cause which produced not the explosion, but the explosive property. The conditions of the explosion itself were all present immediately before it took place, and the general law, therefore, remains intact. End of section 33. Section 34 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 3, Chapter 5 of the Law of Universal Causation, Parts 6 through 10. Part 6. It now remains to advert to a distinction which is of first-rate importance, both for clearing up the notion of cause and for obviating a very specious objection often made against the view which we have taken of the subject. When we define the cause of any thing, in the only sense in which the present inquiry has any concern with causes, to be the antecedent which it invariably follows, we do not use this phrase as exactly synonymous with the antecedent which it invariably has followed in our past experience. Such a mode of conceiving causation would be liable to the objection, very plausibly urged by Dr. Reid, namely, that according to this doctrine, night must be the cause of day, and day the cause of night, since these phenomena have invariably succeeded one another from the beginning of the world. But it is necessary to our using the word cause that we should believe not only that the antecedent always has been followed by the consequent, but that, as long as the present constitution of things endures, it always will be so. Footnote. I mean by this expression the ultimate laws of nature, whatever they may be, as distinguished from the derivative laws and from the collocations. The diurnal revolution of the earth, for example, is not a part of the constitution of things, because nothing can be so called which might possibly be terminated or altered by natural causes. End footnote. And this would not be true of day and night. We do not believe that night will be followed by day under all imaginable circumstances, but only that it will be so provided the sun rises above the horizon. If the sun ceased to rise, which, for aught we know, may be perfectly compatible with the general laws of matter, night would be, or might be, eternal. On the other hand, if the sun is above the horizon, his light not extinct, and no opaque body between us and him, we believe firmly that unless a change takes place in the properties of matter, this combination of antecedents will be followed by the consequent day. That if the combination of antecedents could be indefinitely prolonged, it would be always day. And that if the same combination had always existed, it would always have been day, quite independently of night as a previous condition. Therefore is it that we do not call night the cause nor even a condition of day. The existence of the sun or some such luminous body, and there being no opaque medium in a straight line between that body and the part of the earth where we are situated, are the sole conditions, and the union of these, without the addition of any superfluous circumstance, constitutes the cause. Footnote. I use the words straight line for brevity and simplicity. In reality, the line in question is not exactly straight, for, from the effect of refraction, we actually see the sun for a short interval during which the opaque mass of the earth is interposed in a direct line between the sun and our eyes, thus realizing, though but to a limited extent, the coveted desideratum of seeing round a corner. End footnote. This is what writers mean when they say that the notion of cause involves the idea of necessity. If there be any meaning which confessedly belongs to the term necessity, it is unconditionalness. That which is necessary, that which must be, means that which will be, whatever supposition we may make in regard to all other things. The succession of day and night evidently is not necessary in this sense. It is conditional on the occurrence of other antecedents. That which will be followed by a given consequent when, and only when, some third circumstance also exists, is not the cause, even though no case should ever have occurred in which the phenomenon took place without it. Invariable sequence, therefore, is not synonymous with causation, unless the sequence, besides being invariable, is unconditional. There are sequences as uniform in past experience as any others whatever, which yet we do not regard as cases of causation, but as conjunctions in some sort accidental. Such, to an accurate thinker, is that of day and night. The one might have existed for any length of time, and the other not have followed the sooner for its existence. It follows only if certain other antecedents exist, and where those antecedents existed, it would follow in any case. No one, probably, ever called night the cause of day. Mankind must so soon have arrived at the very obvious generalization that the state of general illumination which we call day would follow from the presence of a sufficiently luminous body, whether darkness had preceded or not. We may define, therefore, the cause of a phenomenon to be the antecedent or the concurrence of antecedents on which it is invariably and unconditionally consequent. Or, if we adopt the convenient modification of the meaning of the word cause, which confines it to the assemblage of positive conditions without the negative, then, instead of unconditionally, we must say subject to no other than negative conditions. To some it may appear that the sequence between night and day being invariable in our experience, we have as much ground in this case as experience can give in any case, for recognizing the two phenomena as cause and effect, and that to say that more is necessary to require a belief that the succession is unconditional, or, in other words, that it would be invariable under all changes of circumstances, is to acknowledge in causation an element of belief not derived from experience. The answer to this is that it is experience itself which teaches us that one uniformity of sequence is conditional and another unconditional. When we judge that the succession of night and day is a derivative sequence depending on something else, we proceed on grounds of experience. It is the evidence of experience which convinces us that day could equally exist without being followed by night, and that night could equally exist without being followed by day. To say that these beliefs are not generated by our mere observation of sequence is to forget that twice in every 24 hours, when the sky is clear, we have an experimentum crucis that the cause of day is the sun. Footnote: Second Burnett Prize essay by Principal Tulloch, page 25. End footnote. We have an experimental knowledge of the sun, which justifies us on experimental grounds in concluding that if the sun were always above the horizon, there would be day, though there had been no night, and that if the sun were always below the horizon, there would be night, though there had been no day. We thus know from experience that the succession of night and day is not unconditional. Let me add that the antecedent which is only conditionally invariable is not the invariable antecedent. Though a fact may in experience have always been followed by another fact, yet if the remainder of our experience teaches us that it might not always be so followed, or if the experience itself is such as leaves room for a possibility that the known cases may not correctly represent all possible cases, the hitherto invariable antecedent is not accounted the cause. But why? Because we are not sure that it is the invariable antecedent. Such cases of sequence as that of day and night not only do not contradict the doctrine which resolves causation into invariable sequence, but are necessarily implied in that doctrine. It is evident that from a limited number of unconditional sequences there will result a much greater number of conditional ones. Certain causes being given, that is, certain antecedents which are unconditionally followed by certain consequents, the mere coexistence of these causes will give rise to an unlimited number of additional uniformities. If two causes exist together, the effects of both will exist together, and if many causes coexist, these causes, by what we shall term hereafter the intermixture of their laws, will give rise to new effects, accompanying or succeeding one another in some particular order, which order will be invariable while the causes continue to coexist, but no longer. The motion of the earth in a given orbit round the sun is a series of changes which follow one another as antecedents and consequents, and will continue to do so while the sun's attraction and the force with which the earth tends to advance in a direct line through space continue to coexist in the same quantities as at present, but vary either of these causes, and this particular succession of motions would cease to take place. The series of the earth's motions, therefore, though a case of sequence invariable within the limits of human experience, is not a case of causation. It is not unconditional. This distinction between the relations of succession which, so far as we know, are unconditional, and those relations, whether of succession or of coexistence, which, like the earth's motions or the succession of day and night, depend on the existence or on the coexistence of other antecedent facts, corresponds to the great division which Dr. Whewell and other writers have made of the field of science into the investigation of what they term the laws of phenomena and the investigation of causes, a phraseology, as I conceive, not philosophically sustainable, inasmuch as the ascertainment of causes, such causes as the human faculties can ascertain, namely, causes which are themselves phenomena, is therefore merely the ascertainment of other and more universal laws of phenomena. And let me here observe that Dr. Whewell and, in some degree, even Sir John Herschel, seem to have misunderstood the meaning of those writers who, like M. Comte, limit the sphere of scientific investigation to laws of phenomena, and speak of the inquiry into causes as vain and futile. The causes which M. Comte designates as inaccessible are efficient causes. The investigation of physical as opposed to efficient causes, including the study of all the active forces in nature, considered as facts of observation, is as important a part of M. Comte's conception of science as of Dr. Whewell's. His objection to the word cause is a mere matter of nomenclature, in which, as a matter of nomenclature, I consider him to be entirely wrong. Quote, "Those," it is justly remarked by Mr. Bailey, "who, like M. Comte, object to designate events as causes, are objecting without any real ground to a mere but extremely convenient generalization to a very useful common name, the employment of which involves or needs involve no particular theory." End quote. Footnote: Letters on the Philosophy of the Human Mind, First Series, page 219. End footnote. To which it may be added that by rejecting this form of expression, M. Comte leaves himself without any term for marking a distinction which, however incorrectly expressed, is not only real, but is one of the fundamental distinctions in science. Indeed, it is on this alone, as we shall hereafter find, that the possibility rests of framing a rigorous canon of induction, and, as things left without a name are apt to be forgotten, a canon of that description is not one of the many benefits which the philosophy induction has received from M. Comte's great powers. Part 7. Does a cause always stand with its effects in the relation of antecedent and consequent? Do we not often say of two simultaneous facts that they are cause and effect, as when we say that fire is the cause of warmth, the sun and moisture the cause of vegetation, and the like? Since a cause does not necessarily perish because its effect has been produced, the two things do very generally coexist, and there are some appearances and some common expressions seeming to imply not only that causes may, but that they must be contemporaneous with their effects. Cessante causa cessatet effectus has been a dogma of the schools. The necessity for the continued existence of the cause in order to the continuance of the effect seems to have been once a generally received doctrine. Kepler's numerous attempts to account for the motions of the heavenly bodies on mechanical principles were rendered abortive by his always supposing that the agency which set those bodies in motion must continue to operate in order to keep up the motion which it at first produced. Yet there were at all times many familiar instances of the continuance of effects long after their causes had ceased. A coup de soleil gives a person brain fever. Will the fever go off as soon as he is moved out of the sunshine? A sword is run through the body. Must the sword remain in his body in order that he may continue dead? A ploughshare, once made, remains a ploughshare, without any continuance of heating and hammering, and even after the man who heated and hammered it has been gathered to his fathers. On the other hand, the pressure which forces up the mercury in an exhausted tube must be continued in order to sustain it in the tube. This, it may be replied, is because another force is acting without intermission, the force of gravity, which would restore it to its level, unless counterposed by a force equally constant. But again, a tight bandage causes pain, which pain will sometimes go off as soon as the bandage is removed. The illumination which the sun diffuses over the earth ceases when the sun goes down. There is, therefore, a distinction to be drawn. The conditions which are necessary for the first production of a phenomenon are occasionally also necessary for its continuance, though more commonly its continuance requires no condition except negative ones. Most things once produced continue as they are until something changes or destroys them, but some require the permanent presence of the agencies which produced them at first. These may, if we please, be considered as instantaneous phenomena, requiring to be renewed at each instant by the cause by which they were at first generated. Accordingly, the illumination of any given point of space has always been looked upon as an instantaneous fact, which perishes and is perpetually renewed as long as the necessary conditions subsist. If we adopt this language, we avoid the necessity of admitting that the continuance of the cause is ever required to maintain the effect. We may say it is not required to maintain, but to reproduce the effect, or else to counteract some force tending to destroy it. And this may be a convenient phraseology, but it is only a phraseology. The fact remains that, in some cases, though these are a minority, the continuance of the conditions which produced an effect is necessary to the continuance of the effect. As to the ulterior question, whether it is strictly necessary that the cause or assemblage of conditions should precede by ever so short an instant the production of the effect, a question raised and argued with much ingenuity by Sir John Herschel in an essay already quoted, the inquiry is of no consequence for our present purpose. Footnote: Essays, pages 206 to 208. End footnote. There certainly are cases in which the effect follows without any interval perceptible by our faculties, and when there is an interval, we cannot tell by how many intermediate links imperceptible to us that interval may really be filled up. But even granting that an effect may commence simultaneously with its cause, the view I have taken of causation is in no way practically affected. Whether the cause and its effect be necessarily successive or not, the beginning of a phenomenon is what implies a cause, and causation is the law of the succession of phenomena. If these axioms be granted, we can afford, though I see no necessity for doing so, to drop the words antecedent and consequent as applied to cause and effect. I have no objection to define a cause, the assemblage of phenomena which, occurring, some other phenomenon invariably commences or has its origin. Whether the effect coincides in point of time with, or immediately follows, the hindmost of its conditions is immaterial. At all events, it does not precede it. And when we are in doubt between two coexistent phenomena, which is cause and which effect, we rightly deem the question solved if we can ascertain which of them preceded the other. Part 8. It continually happens that several different phenomena, which are not in the slightest degree dependent or conditional on one another, are found all to depend, as the phrase is, on one and the same agent. In other words, one and the same phenomenon is seen to be followed by several sorts of effects, quite heterogeneous, but which go on simultaneously one with another, provided, of course, that all other conditions requisite for each of them also exist. Thus, the sun produces the celestial motions, it produces daylight, and it produces heat. The earth causes the fall of heavy bodies, and it also, in its capacity of a great magnet, causes the phenomena of the magnetic needle. A crystal of galena causes the sensations of hardness, of weight, of cubical form, of grey colour, and many others between which we can trace no interdependence. The purpose to which the phraseology of properties and powers is specially adapted is the expression of this sort of cases, when the same phenomena is followed, either subject or not to the presence of other conditions, by effects of different and dissimilar orders. It is usual to say that each different sort of effect is produced by a different property of the cause. Thus, we distinguish the attractive or gravitative property of the earth and its magnetic property, the gravitative, luminiferous, and calorific properties of the sun, the colour, shape, weight, and hardness of a crystal. These are mere phrases which explain nothing and add nothing to our knowledge of the subject, but, considered as abstract names denoting the connection between the different effects produced and the object which produces them, they are a very powerful instrument of abridgment, and of that acceleration of the process of thought which abridgment accomplishes. This class of considerations leads to a conception which we shall find to be of great importance, that of a permanent cause or original natural agent. There exist in nature a number of permanent causes which have subsisted ever since the human race has been in existence, and for an indefinite and probably an enormous length of time previous. The sun, the earth, and planets, with their various constituents, air, water, and other distinguishable substances, whether simple or compound, of which nature is made up, are such permanent causes. These have existed, and the effects or consequences which they were fitted to produce have taken place, as often as the other conditions of the production met, from the very beginning of our experience. But we can give no account of the origin of the permanent causes themselves. Why these particular natural agents existed originally and no others, or why they are commingled in such and such proportions and distributed in such and such a manner throughout space, is a question we cannot answer. More than this, we can discover nothing regular in the distribution itself. We can reduce it to no uniformity, to no law. There are no means by which, from the distribution of these causes or agents in one part of space, we could conjecture whether a similar distribution prevails in another. The coexistence, therefore, of primeval causes ranks to us among merely casual concurrences, and all those sequences or coexistences among the effects of several such causes, which, though invariable while those causes coexist, would, if the coexistence terminated, terminate along with it, we do not class as cases of causation or laws of nature. We can only calculate on finding these sequences or coexistences where we know by direct evidence that the natural agents on the properties of which they ultimately depend are distributed in the requisite manner. These permanent causes are not always objects, they are sometimes events, that is to say, periodical cycles of events, that being the only mode in which events can possess the property of permanence. Not only, for instance, is the earth itself a permanent cause or primitive natural agent, but the earth's rotation is so too. It is a cause which has produced from the earliest period, by the aid of other necessary conditions, the succession of day and night, the ebb and flow of the sea, and many other effects, while, as we can assign no cause, except conjecturally, for the rotation itself, it is entitled to be ranked as a primeval cause. It is, however, only the origin of the rotation which is mysterious to us. Once begun, its continuance is accounted for by the first law of motion, that of the permanence of rectilinear motion once impressed, combined with the gravitation of the parts of the earth toward one another. All phenomena without exception which begin to exist, that is, all except the primeval causes, are effects either immediate or remote of those primitive facts, or of some combination of them. There is no thing produced, no event happening in the known universe, which is not connected by a uniformity or invariable sequence with some one or more of the phenomena which preceded it, insomuch that it will happen again as often as those phenomena occur again, and as no other phenomenon having the character of a counteracting cause shall coexist. These antecedent phenomena, again, were connected in a similar manner with some that preceded them, and so on until we reach, as the ultimate step attainable by us, either the properties of some one primeval cause, or the conjunction of several. The whole of the phenomena of nature were therefore the necessary, or, in other words, the unconditional, consequences of some former collocation of the permanent causes. The state of the whole universe at any instant we believe to be the consequence of its state at the previous instant, insomuch that one who knew all the agents which exist at the present moment, their collocation in space, and all their properties, in other words, the laws of their agency, could predict the whole subsequent history of the universe, at least unless some new volition of a power capable of controlling the universe should supervene. Footnote: to the universality which mankind are agreed in ascribing to the law of causation, there is one claim of exception, one disputed case, that of the human will, the determinations of which a large class of metaphysicians are not willing to regard as following the causes called motives, according to the strict laws, as those which they suppose to exist in the world of mere matter. This controverted point will undergo a special examination when we come to treat particularly of the logic of the moral sciences. See section 83 of this work, Book 6, Chapter 2. In the meantime, I may remark that these metaphysicians who, it must be observed, ground the main part of their objection on the supposed repugnance of the doctrine in question to our consciousness, seem to me to mistake the fact which consciousness testifies against. What is really in contradiction to consciousness, they would, I think, on strict self-examination, find to be the application to human actions and volitions of the ideas involved in the common use of the term necessity, which I agree with them in objecting to. But if they would consider that by saying that a person's actions necessarily follow from his character, all that is really meant, for no more is meant in any case whatever of causation, is that he invariably does act in conformity to his character, and that any one who thoroughly knew his character could certainly predict how he would act in any supposable case, they probably would not find this doctrine either contrary to their experience or revolting to their feelings, and no more than this is contended for by any one but an Asiatic fatalist. End footnote. And if any particular state of the entire universe could ever recur a second time, all subsequent states would return too, and history would, like a circulating decimal of many figures, periodically repeat itself. Jam reddit et Virgo reduent Saturnia regna, alter erit tum Tiphys et altera cae vahet Argo, delectos heroas erunt coque altera bella, atque iterum ad Trojam magnus mittitur Achilles. And though things do not really revolve in this eternal round, the whole series of events in the history of the universe, past and future, is not the less capable in its own nature of being constructed a priori by any one whom we can suppose acquainted with the original distribution of all natural agents and with the whole of their properties, that is, the laws of succession existing between them and their effects, saving the far more than human powers of combination and calculation which would be required, even in one possessing the data, for the actual performance of the task. Part 9. Since everything which occurs is determined by laws of causation and collocations of the original causes, it follows that the coexistences which are observable among effects cannot be themselves the subject of any similar set of laws distinct from laws of causation. Uniformities there are, as well of coexistence as of succession, among effects, but these must in all cases be a mere result either of the identity or of the coexistence of their causes. If the causes did not coexist, neither could the effects. And these causes being also effects of prior causes, and these of others, until we reach the primeval causes, it follows that, except in the case of effects which can be traced immediately or remotely to one and the same cause, the coexistences of phenomena can in no case be universal, unless the coexistences of the primeval causes, to which the effects are ultimately traceable, can be reduced to a universal law. But we have seen that they cannot. There are, accordingly, no original and independent, in other words, no unconditional, uniformities of coexistence between effects of different causes. If they coexist, it is only because the causes have casually coexisted. The only independent and unconditional coexistences which are sufficiently invariable to have any claim to the character of laws are between different and mutually independent effects of the same cause, in other words, between different properties of the same natural agent. This portion of the laws of nature will be treated of in the latter part of the present book under the name of the specific properties of kinds. Part 10. Since the first publication of the present treatise, the sciences of physical nature have made a great advance in generalization through the doctrine known as the conservation or persistence of force. This imposing edifice of theory, the building and laying out of which has for some time been the principal occupation of the most systematic minds among physical inquirers, consists of two stages: one of ascertained fact, the other containing a large element of hypothesis. To begin with the first, it is proved by numerous facts, both natural and of artificial production, that agencies which had been regarded as distinct and independent sources of force, heat, electricity, chemical action, nervous and muscular action, momentum of moving bodies, are interchangeable in definite and fixed quantities with one another. It had long been known that these dissimilar phenomena had the power, under certain conditions, of producing one another. What is new in the theory is a more accurate estimation of what this production consists in. What happens is that the whole or part of the one kind of phenomena disappears and is replaced by phenomena of one of the other descriptions, and that there is an equivalence in quantity between the phenomena that have disappeared and those which have been produced, insomuch that if the process be reversed, the very same quantity which had disappeared will reappear without increase or diminution. Thus, the amount of heat which will raise the temperature of a pound of water 1 degree of the thermometer will, if expended, say in the expansion of steam, lift a weight of 772 pounds 1 foot, or a weight of 1 pound 772 feet. And the same exact quantity of heat can, by certain means, be recovered through the expenditure of exactly that amount of mechanical motion. The establishment of this comprehensive law has led to a change in the language in which the scientific world had been accustomed to speak of what are called the forces of nature. Before this correlation between phenomena most unlike one another had been ascertained, their unlikeness had caused them to be referred to so many distinct forces. Now that they are known to be convertible into one another without loss, they are spoken of as all of them results of one and the same force, manifesting itself in different modes. This force, it is said, can only produce a limited and definite quantity of effect, but always does produce that definite quantity, and produces it, according to circumstances, in one or another of the forms, or divides it among several, but so as, according to a scale of numerical equivalence established by experiment, always to make up the same sum, and no one of the manifestations can be produced save by the disappearance of the equivalent quantity of another, which in its turn, in appropriate circumstances, will reappear undiminished. This mutual interchangeability of the forces of nature, according to fixed numerical equivalence, is the part of the new doctrine which rests on irrefragable fact. To make the statement true, however, it is necessary to add that an indefinite and perhaps immense interval of time may elapse between the disappearance of the force in one form and its reappearance in another. A stone thrown up into the air with a given force and falling back immediately will, by the time it reaches the earth, recover the exact amount of mechanical momentum which was expended in throwing it up, deduction being made of a small portion of motion which has been communicated to the air. But if the stone has lodged on a height, it may not fall back for years, or perhaps ages, and until it does, the force expended in raising it is temporarily lost, being represented only by what, in the language of the new theory, is called potential energy. The coal embedded in the earth is considered by theory as a vast reservoir of force which has remained dormant for many geological periods, and will so remain until, by being burned, it gives out the stored up force in the form of heat. Yet it is not supposed that this force is a material thing which can be confined by bounds, as used to be thought of latent heat, when that important phenomenon was first discovered. What is meant is that when the coal does at last, by combustion, generate a quantity of heat, transformable like all other heat into mechanical momentum and the other forms of force, this extrication of heat is the reappearance of a force derived from the sun's rays expended myriads of ages ago in the vegetation of the organic substances which were the material of the coal. Let us now pass to the higher stage of the theory of conservation of force, the part which is no longer a generalization of proved fact, but a combination of fact and hypothesis. Stated in few words, it is as follows: that the conservation of force is really the conservation of motion, that in the various interchanges between the forms of force, it is always motion that is transformed into motion. To establish this, it is necessary to assume motions which are hypothetical. The supposition is that there are motions which manifest themselves to our senses only as heat, electricity, and so on, being molecular motions, oscillations, invisible to us among the minute particles of bodies, and that these molecular motions are transmutable into molar motions, motions of masses, and molar motions into molecular. Now, there is a real basis of fact for this supposition. We have positive evidence of the existence of molecular motion in these manifestations of force. In the case of chemical action, for instance, the particles separate and form new combinations, often with a great visible disturbance of the mass. In the case of heat, the evidence is equally conclusive, since heat expands bodies, that is, causes their particles to move from one another, and, if of sufficient amount, changes their mode of aggregation from solid to liquid, or from liquid to gaseous. Again, the mechanical actions which produce heat, friction and the collision of bodies, must, from the nature of the case, produce a shock, that is, an internal motion of particles, which, indeed, we find is often so violent as to break them permanently asunder. Such facts are thought to warrant the inference that it is not, as was supposed, heat that causes the motion of particles, but the motion of particles that causes heat. The original cause of both being the previous motion, whether molar or molecular, collisions of bodies or combustion of fuel, which formed the heating agency. This inference already contains hypothesis, but at least the supposed cause, the intestine motion of molecules, is a vera causa. But in order to reduce the conservation of force to conservation of motion, it was necessary to attribute to motion the heat propagated, through apparently empty space, from the sun. This required the supposition, already made for the explanation of the laws of light, of a subtle ether pervading space, which, though impalpable to us, must have the property which constitutes matter, that of resistance, since waves are propagated through it by an impulse from a given point. The ether must be supposed, a supposition not required by the theory of light, to penetrate into the minute interstices of all bodies. The vibratory motion supposed to be taking place in the heated mass of the sun is considered as imparted from that mass to the particles of the surrounding ether, and through them to the particles of the same ether in the interstices of terrestrial bodies, and this too with a sufficient mechanical force to throw the particles of those bodies into a state of similar vibration, producing the expansion of their mass and the sensation of heat in sentient creatures. All this is hypothesis, though of its legitimacy as hypothesis I do not mean to express any doubt. It would seem to follow as a consequence from this theory that force may and should be defined matter in motion. This definition, however, will not stand, for, as has already been seen, the matter needs not be in actual motion. It is not necessary to suppose that the motion afterward manifested is actually taking place among the molecules of the coal during its sojourn in the earth. Certainly not in the stone which is at rest on the eminence to which it has been raised. Footnote. I believe, however, the accredited authorities do suppose that molecular motion, equivalent in amount to that which will be manifested in the combustion of the coal, is actually taking place during the whole of the long interval, if not in the coal, yet in the oxygen which will then combine with it. But how purely hypothetical this supposition is need hardly be remarked. I venture to say, unnecessarily and extravagantly hypothetical. End footnote. The true definition of force must be not motion, but potentiality of motion. And what the doctrine, if established, amounts to is not that there is at all times the same quantity of actual motion in the universe, but that the possibilities of motion are limited to a definite quantity, which cannot be added to, but which cannot be exhausted, and that all actual motion which takes place in nature is a draft upon this limited stock. It needs not all of it have ever existed as actual motion. There is a vast amount of potential motion in the universe in the form of gravitation, which it would be a great abuse of hypothesis to suppose to have been stored up by the expenditure of an equal amount of actual motion in some former state of the universe. Nor does the motion produced by gravity take place, so far as we know, at the expense of any other motion, either molar or molecular. It is proper to consider whether the adoption of this theory as a scientific truth, involving as it does a change in the conception hitherto entertained of the most general physical agencies, requires any modification in the view I have taken of causation as a law of nature. As it appears to me, none whatever. The manifestations which the theory regards as modes of motion are as much distinct and separate phenomena when referred to a single force as when attributed to several. Whether the phenomenon is called a transformation of force or the generation of one, it has its own set or sets of antecedents, with which it is connected by invariable and unconditional sequence, and that set or those sets of antecedents are its cause. The relation of the conservation theory to the principle of causation is discussed in much detail and very instructively by Professor Bain in the second volume of his Logic. The chief practical conclusion drawn by him, bearing on causation, is that we must distinguish in the assemblage of conditions which constitutes the cause of a phenomenon two elements: one, the presence of a force; the other, the collocation or position of objects which is required in order that the force may undergo the particular transmutation which constitutes the phenomena. Now, it might always have been said with acknowledged correctness that a force and a collocation were both of them necessary to produce any phenomenon. The law of causation is that change can only be produced by change, along with any number of stationary antecedents which are collocations. There must be at least one changing antecedent, which is a force. To produce a bonfire, there must not only be fuel and air and a spark, which are collocations, but chemical action between the air and the materials, which is a force. To grind corn, there must be a certain collocation of the parts composing a mill relatively to one another and to the corn, but there must also be the gravitation of water or the motion of wind to supply a force. But as the force in these cases was regarded as a property of the objects in which it is embodied, it seemed tautology to say that there must be the collocation and the force, as the collocation must be a collocation of objects possessing the force-giving property. The collocation, so understood, included the force. How then shall we have to express these facts if the theory be finally substantiated that all force is reducible to a previous motion? We shall have to say that one of the conditions of every phenomenon is an antecedent motion, but it will have to be explained that this needs not be actual motion. The coal which supplies the force exerted in combustion is not shown to have been exerting that force in the form of molecular motion in the pit. It was not even exerting pressure. The stone on the eminence is exerting a pressure, but only equivalent to its weight, not to the additional momentum it would acquire by falling. The antecedent, therefore, is not a force in action, and we can still only call it a property of the objects by which they would exert a force on the occurrence of a fresh collocation. The collocation, therefore, still includes the force. The force said to be stored up is simply a particular property which the object has acquired. The cause we are in search of is a collocation of objects possessing that particular property. When indeed we inquire further into the cause from which they derive that property, the new conception introduced by the conservation theory comes in. The property is itself an effect, and its cause, according to the theory, is a former motion of exactly equivalent amount, which has been impressed on the particles of the body, perhaps at some very distant period. But the case is simply one of those we have already considered, in which the efficacy of a cause consists in its investing an object with a property. The force said to be laid up and merely potential is no more a really existing thing than any other properties of objects are really existing things. The expression is a mere artifice of language, convenient for describing the phenomena. It is unnecessary to suppose that any thing has been in continuous existence except an abstract potentiality. A force suspended in its operation, neither manifesting itself by motion nor by pressure, is not an existing fact, but a name for our conviction that, in appropriate circumstances, a fact would take place. We know that a pound weight, were it to fall from the earth into the sun, would acquire in falling a momentum equal to millions of pounds, but we do not credit the pound weight with more of actually existing force than is equal to the pressure it is now exerting on the earth, and that is exactly a pound. We might as well say that a force of millions of pounds exists in a pound, as that the force which will manifest itself when the coal is burned is a real thing existing in the coal. What is fixed in the coal is only a certain property. It has become fit to be the antecedent of an effect called combustion, which partly consists in giving out under certain conditions a given definite quantity of heat. We thus see that no new general conception of causation is introduced by the conservation theory. The indestructibility of force no more interferes with the theory of causation than the indestructibility of matter, meaning by matter the element of resistance in the sensible world. It only enables us to understand better than before the nature and laws of some of the sequences. This better understanding, however, enables us, with Mr. Bain, to admit as one of the tests for distinguishing causation from mere concomitance, the expenditure or transfer of energy. If the effect, or any part of the effect to be accounted for, consists in putting matter in motion, then any of the objects present which has lost motion has contributed to the effect. And this is the true meaning of the proposition that the cause is that one of the antecedents which exerts active force. End of section 34. Section 35 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 3, Chapter 5 of the Law of Universal Causation, Part 11. It is proper in this place to advert to a rather ancient doctrine respecting causation, which has been revived during the last few years in many quarters, and at present gives more signs of life than any other theory of causation at variance with that set forth in the preceding pages. According to the theory in question, mind, or to speak more precisely, will, is the only cause of phenomena. The type of causation, as well as the exclusive source from which we derive the idea, is our own voluntary agency. Here, and here only, it is said, we have direct evidence of causation. We know that we can move our bodies. Respecting the phenomena of inanimate nature, we have no other direct knowledge than that of antecedents and sequence. But in the case of our voluntary actions, it is affirmed that we are conscious of power before we have experience of results. An act of volition, whether followed by an effect or not, is accompanied by a consciousness of effort, of force exerted, of power in action, which is necessarily causal or causative. This feeling of energy or force inherent in an act of will is knowledge a priori, assurance prior to experience, that we have the power of causing effects. Volition, therefore, it is asserted, is something more than an unconditional antecedent. It is a cause, in a different sense from that in which physical phenomena are said to cause one another. It is an efficient cause. From this, the transition is easy to the further doctrine that volition is the sole efficient cause of all phenomena. It is inconceivable that dead force could continue unsupported for a moment beyond its creation. We cannot even conceive of change or phenomena without the energy of a mind. The word action itself, says another writer of the same school, has no real significance except when applied to the doings of an intelligent agent. Let any one conceive, if he can, of any power, energy, or force inherent in a lump of matter. Phenomena may have the semblance of being produced by physical causes, but they are in reality produced, say these writers, by the immediate agency of mind. All things which do not proceed from a human, or, I suppose, an animal, will proceed, they say, directly from divine will. The earth is not moved by the combination of a centripetal and a projectile force. This is but a mode of speaking which serves to facilitate our conceptions. It is moved by the direct volition of an omnipotent being, in a path coinciding with that which we deduce from the hypothesis of these two forces. As I have so often observed, the general question of the existence of efficient causes does not fall within the limits of our subject, but a theory which represents them as capable of being subjects of human knowledge, and which passes off as efficient causes what are only physical or phenomenal causes, belongs as much to logic as to metaphysics, and is a fit subject for discussion here. To my apprehension, a volition is not an efficient, but simply a physical cause. Our will causes our bodily actions in the same sense and in no other in which cold causes ice, or a spark causes an explosion of gunpowder. The volition, a state of our mind, is the antecedent. The motion of our limbs in conformity to the volition is the consequent. This sequence I conceive to be not a subject of direct consciousness in the sense intended by the theory. The antecedent, indeed, and the consequent are subjects of consciousness, but the connection between them is a subject of experience. I cannot admit that our consciousness of the volition contains in itself any a priori knowledge that the muscular motion will follow. If our nerves of motion were paralyzed, or our muscles stiff and inflexible, and had been so all our lives, I do not see the slightest ground for supposing that we should ever, unless by information from other people, have known any things of volition as a physical power, or been conscious of any tendency in feelings of our mind to produce motions of our body, or of other bodies. I will not undertake to say whether we should in that case have had the physical feeling which I suppose is meant when these writers speak of consciousness of effort. I see no reason why we should not, since that physical feeling is probably a state of nervous sensation beginning and ending in the brain, without involving the motory apparatus. but we certainly should not have designated it by any term equivalent to effort, since effort implies consciously aiming at an end, which we should not only in that case have had no reason to do, but could not even have had the idea of doing. If conscious at all of this particular sensation, we should have been conscious of it, I conceive, only as a kind of uneasiness accompanying our feelings of desire. It is well argued by Sir William Hamilton against the theory in question that it, quote, is refuted by the consideration that between the overt fact of corporeal movement of which we are cognizant and the internal act of mental determination of which we are also cognizant, there intervenes a numerous series of intermediate agencies of which we have no knowledge, and consequently that we can have no consciousness of any causal connection between the extreme links of this chain, the volition to move and the limb moving, as this hypothesis asserts. No one is immediately conscious, for example, of moving his arm through his volition. Previously to this ultimate movement, muscles, nerves, a multiple of solid and fluid parts must be set in motion by the will, but of this motion we know, from consciousness, absolutely nothing. A person struck with paralysis is conscious of no inability in his limb to fulfill the determinations of his will, and it is only after having willed and finding that his limbs do not obey his volition that he learns by this experience that the external movement does not follow the internal act. But as the paralytic learns after the volition that his limbs do not obey his mind, so it is only after volition that the man in health learns that his limbs do obey the mandates of his will. End quote. Footnote. Lectures on Metaphysics, Volume 2, Lecture 39, pages 391 to 392. I regret that I cannot invoke the authority of Sir William Hamilton in favour of my own opinions on causation, as I can against the particular theory which I am now combating. But that acute thinker has a theory of causation peculiar to himself, which has never yet, as far as I know, been analytically examined, but which, I venture to think, admits of as complete refutation as any one of the false or insufficient psychological theories which strew the ground in such numbers under his potent metaphysical scythe. Since examined and controverted in the 16th chapter of An Examination of Sir William Hamilton's Philosophy. End footnote. Those against whom I am contending have never produced, and do not pretend to produce, any positive evidence that the power of our will to move our bodies would be known to us independently of experience. Footnote. Unless we are to consider as such the following statement by one of the writers quoted in the text, quote, in the case of mental exertion, the result to be accomplished is preconsidered or meditated, and is therefore known a priori, or before experience. End quote. Bowen's Lower Lectures on the Application of Metaphysical and Ethical Science to the Evidence of Religion, Boston, 1849. This is merely saying that when we will a thing, we have an idea of it. But to have an idea of what we wish to happen does not imply a prophetic knowledge that it will happen. Perhaps it will be said that the first time we exerted our will, when we had of course no experience of any of the powers residing in us, we nevertheless must already have known that we possessed them, since we cannot will that which we do not believe to be in our power. But the impossibility is perhaps in the words only, and not in the facts, for we may desire what we do not know to be in our power, and finding by experience that our bodies move according to our desire, we may then, and only then, pass into the more complicated mental state, which is termed will. After all, even if we had an instinctive knowledge that our actions would follow our will, this, as Brown remarks, would prove nothing as to the nature of causation, Our knowing previous to experience that an antecedent will be followed by a certain consequent would not prove the relation between them to be anything more than antecedence and consequence. End footnote. What they have to say on the subject is that the production of physical events by a will seems to carry its own explanation with it, while the action of matter upon matter seems to require something else to explain it, and is even, according to them, inconceivable on any other supposition than that some will intervenes between the apparent cause and its apparent effect. They thus rest their case on an appeal to the inherent laws of our conceptive faculty, mistaking, as I apprehend, for the laws of that faculty its acquired habits, grounded on the spontaneous tendencies of its uncultured state. The succession between the will to move a limb and the actual motion is one of the most direct and instantaneous of all sequences which come under our observation, and is familiar to every moment's experience from our earliest infancy, more familiar than any succession of events exterior to our bodies, and especially more so than any other case of the apparent origination, as distinguished from the mere communication, of motion. Now, it is the natural tendency of the mind to be always attempting to facilitate its conception of unfamiliar facts by assimilating them to others which are familiar. Accordingly, our voluntary acts, being the most familiar to us of all cases of causation, are, in the infancy and early youth of the human race, spontaneously taken as the type of causation in general, and all phenomena are supposed to be directly produced by the will of some sentient being. This original fetishism I shall not characterize in the words of Hume or of any follower of Hume, but in those of a religious metaphysician, Dr. Reid, in order more effectually to show the unanimity which exists on the subject among all competent thinkers. Quote, "When we turn our attention to external objects and begin to exercise our rational faculties about them, we find that there are some motions and changes in them which we have power to produce, and that there are many which must have some other cause. Either the objects must have life and active power, as we have, or they must be moved or changed by something that has life and active power, as external objects are moved by us. Our first thoughts seem to be that the objects in which we perceive such motion have understanding and active power as we have. Savages, says the Abbé Raynal, wherever they see motion which they cannot account for, there they suppose a soul. All men may be considered as savages in this respect until they are capable of instruction, and of using their faculties in a more perfect manner than savages do. The Abbé Raynal's observation is sufficiently confirmed both from fact and from the structure of all languages. Rude nations do really believe sun, moon, and stars, earth, sea, and air, fountains and lakes, to have understanding and active power. To pay homage to them and implore their favour is a kind of idolatry natural to savages. All languages carry in their structure the marks of their being formed when this belief prevailed. The distinction of verbs and participles into active and passive, which is found in all languages, must have been originally intended to distinguish what is really active from what is merely passive, and in all languages we find active verbs applied to those objects, in which, according to the Abbé Raynal's observation, savages suppose a soul. Thus we say, the sun rises and sets and comes to the meridian. The moon changes. The sea ebbs and flows. The winds blow. Languages were formed by men who believed these objects to have life and active power in themselves. It was therefore proper and natural to express their motions and changes by active verbs. There is no surer way of tracing the sentiments of nations before they have records than by the structure of their language, which, notwithstanding the changes produced in it by time, will always retain some signatures of the thoughts of those by whom it was invented. When we find the same sentiments indicated in the structure of all languages, those sentiments must have been common to the human species when languages were invented. When a few of superior intellectual abilities find leisure for speculation, they begin to philosophize, and soon discover that many of those objects which at first they believed to be intelligent and active are really lifeless and passive. This is a very important discovery. It elevates the mind, emancipates from many vulgar superstitions, and invites to further discoveries of the same kind. As philosophy advances, life and activity in natural objects retires and leaves them dead and inactive. Instead of moving voluntarily, we find them to be moved necessarily. Instead of acting, we find them to be acted upon. And nature appears as one great machine, where one wheel is turned by another, that by a third. And how far this necessary succession may reach, the philosopher does not know. End quote. Footnote. Reads Essays on the Active Powers, Essay 4, Chapter 3. End footnote. There is, then, a spontaneous tendency of the intellect to account to itself for all cases of causation by assimilating them to the intentional acts of voluntary agents like itself. This is the instinctive philosophy of the human mind in its earliest stage, before it has become familiar with any other invariable sequences than those between its own volitions or those of other human beings and their voluntary acts. As the notion of fixed laws of succession among external phenomena gradually establishes itself, the propensity to refer all phenomena to voluntary agency slowly gives way before it. The suggestions, however, of daily life continuing to be more powerful than those of scientific thought, the original instinctive philosophy maintains its ground in the mind underneath the growths obtained by cultivation, and keeps up a constant resistance to their throwing their roots deep into the soil. The theory against which I am contending derives its nourishment from that substratum. Its strength does not lie in argument, but in its affinity to an obstinate tendency of the infancy of the human mind. That this tendency, however, is not the result of an inherent mental law is proved by superabundant evidence. The history of science, from its earliest dawn, shows that mankind have not been unanimous in thinking either that the action of matter upon matter was not conceivable, or that the action of mind upon matter was. To some thinkers and some schools of thinkers, both in ancient and in modern times, this last has appeared much more inconceivable than the former. Sequences entirely physical and material, as soon as they had become sufficiently familiar to the human mind, came to be thought perfectly natural, and were regarded not only as needing no explanation themselves, but as being capable of affording it to others, and even of serving as the ultimate explanation of things in general. One of the ablest recent supporters of the volitional theory has furnished an explanation, at once historically true and philosophically acute, of the failure of the Greek philosophers in physical inquiry, in which, as I conceive, he unconsciously depicts his own state of mind. Quote, "Their stumbling block was one as to the nature of the evidence they had to expect for their conviction. They had not seized the idea that they must not expect to understand the processes of outward causes, but only their results, and consequently the whole physical philosophy of the Greeks was an attempt to identify mentally the effect with its cause, to feel after some not only necessary but natural connection, where they meant by natural that which would per se carry some presumption to their own mind. They wanted to see some reason why the physical antecedent should produce this particular consequent, and their only attempts were in directions where they could find such reasons. End quote. Footnote. Prospective Review for February 1850. End footnote. In other words, they were not content merely to know that one phenomenon was always followed by another. They thought that they had not attained the true aim of science unless they could perceive something in the nature of the one phenomenon from which it might have been known or presumed previous to trial that it would be followed by the other. Just what the writer who has so clearly pointed out their error thinks that he perceives in the nature of the phenomenon volition. And to complete the statement of the case, he should have added that these early speculators not only made this their aim, but were quite satisfied with their success in it, not only sought for causes which should carry in their mere statement evidence of their efficiency, but fully believed that they had found such causes. The reviewer can see plainly that this was an error, because he does not believe that there exist any relations between material phenomena which can account for their producing one another, but the very fact of the persistency of the Greeks in this error shows that their minds were in a very different state. They were able to derive from the assimilation of physical facts to other physical facts the kind of mental satisfaction which we connect with the word explanation, and which the reviewer would have us think can only be found in referring phenomena to a will. When Thales and Hippo held that moisture was the universal cause and external element of which all other things were but the infinitely various sensible manifestations, when Anaximenes predicted the same thing of air, Pythagoras of numbers, and the like, they all thought that they had found a real explanation, and were content to rest in this explanation as ultimate. The ordinary sequences of the external universe appeared to them, no less than to their critic, to be inconceivable without the supposition of some universal agency to connect the antecedents with the consequents. But they did not think that volition exerted by minds was the only agency which fulfilled this requirement. Moisture or air or numbers carried to their minds a precisely similar impression of making intelligible what was otherwise inconceivable, and gave the same full satisfaction to the demands of their conceptive faculty. It was not the Greeks alone who, quote, wanted to see some reason why the physical antecedent should produce this particular consequent, some connection, which would per se carry some presumption to their own mind. End quote. Among modern philosophers, Leibniz laid it down as a self-evident principle that all physical causes without exception must contain in their own nature something which makes it intelligible that they should be able to produce the effects which they do produce. Far from admitting volition as the only kind of cause which carried internal evidence of its own power, and as the real bond of connection between physical antecedents and their consequents, he demanded some naturally and per se efficient physical antecedent as the bond of connection between volition itself and its effects. He distinctly refused to admit the will of God as a sufficient explanation of anything except miracles, and insisted upon finding something that would account better for the phenomena of nature than a mere reference to divine volition. Footnote. See section 24 of this work, Book 2, Chapter 5, Part 6. End footnote. Again, and conversely, the action of mind upon matter, which we are now told not only needs no explanation itself, but is the explanation of all other effects, has appeared to some thinkers to be itself the grand inconceivability. It was to get over this very difficulty that the Cartesians invented the system of occasional causes. They could not conceive that thoughts in a mind could produce movements in a body, or that bodily movements could produce thoughts. They could see no necessary connection, no relation a priori between a motion and a thought. And as the Cartesians, more than any other school of philosophical speculation before or since, made their own minds the measure of all things, and refused on principle to believe that nature had done what they were unable to see any reason why she must do, they affirmed it to be impossible that a material and a mental fact could be causes one of another. They regarded them as mere occasions on which the real agent, God, thought fit to exert his power as a cause. When a man wills to move his foot, it is not his will that moves it, but God, they said, moves it on the occasion of his will. God, according to this system, is the only efficient cause, not qua mind or qua endowed with volition, but qua omnipotent. This hypothesis was, as I said, originally suggested by the supposed inconceivability of any real mutual action between mind and matter. But it was afterward extended to the action of matter upon matter, for on a nicer examination they found this inconceivable too, and therefore, according to their logic, impossible. The Deus ex machina was ultimately called in to produce a spark on the occasion of a flint and steel coming together, or to break an egg on the occasion of its falling to the ground. All this undoubtedly shows that it is the disposition of mankind in general not to be satisfied with knowing that one fact is invariably antecedent and another consequent, but to look out for something which may seem to explain their being so. But we also see that this demand may be completely satisfied by an agency purely physical, provided it be much more familiar than that which it is invoked to explain. To Thales and Anaximenes it appeared inconceivable that the antecedents which we see in nature should produce the consequence, but perfectly natural that water or air should produce them. The writers whom I oppose declare this inconceivable, but can conceive that mind or volition is per se an efficient cause, while the Cartesians could not conceive even that, but peremptorily declared that no mode of production of any fact whatever was conceivable, except the direct agency of an omnipotent being, thus giving additional proof of what finds new confirmation in every stage of the history of science, that both what persons can and what they cannot conceive is very much an affair of accident, and depends altogether on their experience and their habits of thought, that by cultivating the requisite associations of ideas, people may make themselves unable to conceive any given thing, and may make themselves able to conceive most things, however inconceivable these may at first appear, and the same facts in each person's mental history which determine what is or is not conceivable to him, determine also which, among the various sequences in nature, will appear to him so natural and plausible as to need no other proof of their existence, to be evident by their own light, independent equally of experience and of explanation. By what rule is any one to decide between one theory of this description and another? The theorists do not direct us to any external evidence. They appeal each to his own subjective feelings. One says, the succession CB appears to me more natural, conceivable, and credible per se than the succession AB. You are therefore mistaken in thinking that B depends upon A. I am certain, though I can give no other evidence of it, that C comes in between A and B, and is the real and only cause of B. The other answers, the successions CB and AB appear to me equally natural and conceivable, or the latter more so than the former. A is quite capable of producing B without any other intervention. A third agrees with the first in being unable to conceive that A can produce B, but finds the sequence DB still more natural than CB, or of nearer kin to the subject matter, and prefers his D theory to the C theory. It is plain that there is no universal law operating here, except the law that each person's conceptions are governed and limited by his individual experiences and habits of thought. We are warranted in saying of all three what each of them already believes of the other two, namely, that they exalt into an original law of the human intellect and of outward nature one particular sequence of phenomena, which appears to them more natural and more conceivable than other sequences, only because it is more familiar, and from this judgment I am unable to accept the theory that volition is an efficient cause. I am unwilling to leave the subject without adverting to the additional fallacy contained in the corollary from this theory, in the inference that because volition is an efficient cause, therefore it is the only cause, and the direct agent in producing even what is apparently produced by something else. Volitions are not known to produce anything directly except nervous action, for the will influences even the muscles only through the nerves. Though it were granted then that every phenomenon has an efficient and not merely a phenomenal cause, and that volition, in the case of the peculiar phenomena which are known to be produced by it, is that efficient cause, are we therefore to say, with these writers, that since we know of no other efficient cause, and ought not to assume one without evidence, there is no other, and volition is the direct cause of all phenomena? A more outrageous stretch of inference could hardly be made, because among the infinite variety of the phenomena of nature there is one, namely, a particular mode of action of certain nerves which has for its cause, and, as we are now supposing, for its efficient cause, a state of our mind, and because this is the only efficient cause of which we are conscious, being the only one of which in the nature of the case we can be conscious, since it is the only one which exists within ourselves, does this justify us in concluding that all other phenomena must have the same kind of efficient cause with that one eminently special, narrow, and peculiarly human or animal phenomenon? The nearest parallel to this specimen of generalization is suggested by the recently revived controversy on the old subject of plurality of worlds, in which the contending parties have been so conspicuously successful in overthrowing one another. Here also we have experience only of a single case, that of the world in which we live. But that this is inhabited we know absolutely, and without possibility of doubt. Now, if on this evidence any one were to infer that every heavenly body without exception, sun, planet, satellite, comet, fixed star, or nebula, is inhabited, and must be so from the inherent constitution of things, his inference would exactly resemble that of the writers who conclude that because volition is the efficient cause of our own bodily motions, it must be the efficient cause of everything else in the universe. It is true, there are cases in which, with acknowledged propriety, we generalize from a single instance to a multitude of instances. But they must be instances which resemble the one known instance, and not such as have no circumstance in common with it except that of being instances. I have, for example, no direct evidence that any creature is alive except myself, yet I attribute with full assurance life and sensation to other human beings and animals. But I do not conclude that all other things are alive merely because I am. I ascribe to certain other creatures a life like my own, because they manifest it by the same sort of indications by which mine is manifested. I find that their phenomena and mine conform to the same laws, and it is for this reason that I believe both to arise from a similar cause. Accordingly, I do not extend the conclusion beyond the grounds for it. Earth, fire, mountains, trees are remarkable agencies, but their phenomena do not conform to the same laws as my actions do, and I therefore do not believe earth or fire, mountains or trees to possess animal life. But the supporters of the volition theory ask us to infer that volition causes everything, for no reason except that it causes one particular thing, although that one phenomenon, far from being a type of all natural phenomena, is eminently peculiar, its laws bearing scarcely any resemblance to those of any other phenomenon, whether of inorganic or organic nature. Note supplementary to the preceding chapter. The author of the second Burnett Prize essay, Dr. Tulloch, who has employed a considerable number of pages in controverting the doctrines of the preceding chapter, has somewhat surprised me by denying a fact which I imagined too well known to require proof, that there have been philosophers who found in physical explanations of phenomena the same complete mental satisfaction which, we are told, is only given by volitional explanation, and others who denied the volitional theory on the same ground of inconceivability on which it is defended. The assertion of the essayist is countersigned still more positively by an able reviewer of the essay. Footnote. Westminster Review for October 1855. End footnote. Quote, "Two illustrations," says the reviewer, "are advanced by Mr. Mill. The case of Thales and Anaximenes, stated by him to have maintained the one moisture and the other air to be the origin of all things, and that of Descartes and Leibniz, whom he asserts to have found the action of mind upon matter the grand inconceivability. In counter-statement as to the first of these cases, the author shows, what we believe now hardly admits of doubt, that the Greek philosophers distinctly recognized as beyond and above their primal material source, the nous, or divine intelligence, as the efficient and originating source of all, and as to the second, by proof that it was the mode, not the fact, of that action on matter, which was represented as inconceivable." End quote. A greater quantity of historical error has seldom been comprised in a single sentence. With regard to Thales, the assertion that he considered water as a mere material in the hands of nous rests on a passage of Cicero, De Natura Deorum, and whoever will refer to any of the accurate historians of philosophy will find that they treat this as a mere fancy of Cicero, resting on no authority, opposed to all the evidence, and make surmises as to the manner in which Cicero may have been led into the error. See Rutter, Volume 1, page 211, second edition. See Brandis, Volume 1, pages 118 through 119, first edition. See Preller, Historia Philosophiae Graeco-Romae, page 10. Schiefer an sich durchaus zu verwerfen, augenscheinlich folgend statt zu berichten. Quibus vera sententia thaletis planedetocetur are the expressions of these writers. As for Anaximenes, he even, according to Cicero, maintained not that air was the material out of which God made the world, but that the air was a god. Quote, Anaximenes aera deum statuit, or according to St. Augustine, that it was the material out of which the gods were made. Quote, non tamen ab ipsis dis eram factum sed ipsos ex ere ortos creditet. End quote. Those who are not familiar with the metaphysical terminology of antiquity must not be misled by finding it stated that Anaximenes attributed psychin, translated soul or life, to his universal element, the air. The Greek philosophers acknowledged several kinds of psyche: the nutritive, the sensitive, and the intellective. Footnote. See the whole doctrine in Aristotle De Anima, where the threptiki psyche is treated as exactly equivalent to threptiki finamis. End footnote. Even the moderns, with admitted correctness, attribute life to plants. As far as we can make out the meaning of Anaximenes, he made choice of air as the universal agent, on the ground that it is perpetually in motion without any apparent cause external to itself, so that he conceived it as exercising spontaneous force, and as the principle of life and activity in all things, men and gods inclusive. If this be not representing it as the efficient cause, the dispute altogether has no meaning. If either Anaximenes or Thales or any of their contemporaries had held the doctrine that nous was the efficient cause, that doctrine could not have been reputed, as it was throughout antiquity, to have originated with Anaxagoras. The testimony of Aristotle in the first book of his Metaphysics is perfectly decisive with respect to these early speculations. After enumerating 4 kinds of causes, or rather 4 different meanings of the word cause, that is, the essence of a thing, the matter of it, the origin of motion, efficient cause, and the end or final cause, he proceeds to say that most of the early philosophers recognized only the second kind of cause, the matter of a thing. Tas en illis ivi monas oitesan anhas inipandum. As his first example, he specifies Thales, whom he describes as taking the lead in this view of the subject, otisti aftis archigos philosophias, and goes on to Hippon, Anaximenes, Diogenes of Apollonia, Hippasus of Metapontum, Heraclitus, and Empedocles. Anaxagoras, however, he proceeds to say, taught a different doctrine, as we know, and it is alleged that Hermotimus of Clazomenae taught it before him. Anaxagoras represented that even if these various theories of the universal material were true, there would be need of some other cause to account for the transformations of the materials, since the material cannot originate its own changes. Uchar vi to ye hypokimenon, afto pi metavalli me afto. Lecho fion ute to xylon ute o chalkos, etios tu metavallin e kataron. Afton ude pi tomen xylon clinin, ude chalkos anavrianda. Al eteronti tis metavolis etion. That is, the other kind of cause, othen I archi tis kenisios, an efficient cause. Aristotle expresses great approbation of this doctrine, which, he says, made its author appear the only sober man among persons raving. Ion miphon ephanni par iki legundas, tus proteron. But while describing the influence which it exercised over subsequent speculation, he remarks that the philosophers against whom this, as he thinks, insuperable difficulty was urged had not felt it to be any difficulty. Uden evisceranan en eaftis. It is surely unnecessary to say more in proof of the matter of fact which Dr. Tulloch and his reviewer disbelieve. Having pointed out what he thinks the error of these early speculators in not recognizing the need of an efficient cause, Aristotle goes on to mention two other efficient causes to which they might have had recourse instead of intelligence: tixi, chance, and to automāton, spontaneity. He indeed puts these aside as not sufficiently worthy causes for the order in the universe. Oti αυτό αυτομάτων και τι τύχη τόσον τον επιτρέψε πράγμα Carlos Ichen. But he does not reject them as incapable of producing any effect, but only as incapable of producing that effect. He himself recognizes tixi and to αυτομάτων as coordinate agents with mind in producing the phenomena of the universe, the department allotted to them being composed of all the classes of phenomena which are not supposed to follow any uniform law. By thus including chance among efficient causes, Aristotle fell into an error which philosophy has now outgrown, but which is by no means so alien to the spirit, even of modern speculation, as it may at first sight appear. Up to quite a recent period, philosophers went on ascribing, and many of them have not yet ceased to ascribe, a real existence to the results of abstraction. Chance could make out as good a title to that dignity as many other of the mind's abstract creations. It had had a name given to it, and why should it not be a reality? As for to αυτομάτων, it is recognized even yet as one of the modes of origination of phenomena by all those thinkers who maintain what is called the freedom of the will. The same self-determining power which that doctrine attributes to volitions was supposed by the ancients to be possessed also by some other natural phenomena, a circumstance which throws considerable light on more than one of the supposed invincible necessities of belief. I have introduced it here because this belief of Aristotle, or rather of the Greek philosophers generally, is as fatal as the doctrines of Thales and the Ionic school to the theory that the human mind is compelled by its constitution to conceive volition as the origin of all force and the efficient cause of all phenomena. Footnote. It deserves notice that the parts of nature which Aristotle regards as representing evidence of design are the uniformities. The phenomena, in so far as reducible to law, τύχη and to αυτομάτων, satisfy him as explanations of the variable element in phenomena, but their occurring according to a fixed rule can only, to his conceptions, be accounted for by an intelligent will. The common, or what may be called the instinctive religious interpretation of nature, is the reverse of this. The events in which men spontaneously see the hand of a supernatural being are those which cannot, as they think, be reduced to a physical law. What they can distinctly connect with physical causes, and especially what they can predict, though of course ascribe to an author of nature, if they already recognize such an author, might be conceived, they think, to arise from a blind fatality, and in any case do not appear to them to bear so obviously the mark of a divine will. And this distinction has been countenanced by eminent writers on natural theology, in particular by Dr. Chalmers, who thinks that though design is present everywhere, the irresistible evidence of it is to be found not in the laws of nature, but in the collocations, that is, in the part of nature in which it is impossible to trace any law. A few properties of dead matter might, he thinks, conceivably account for the regular and invariable succession of effects and causes, but that the different kinds of matter have been so placed as to promote beneficent ends is what he regards as the proof of a divine providence. Mr. Baden-Powell, in his essay entitled Philosophy of Creation, has returned to the point of view of Aristotle and the ancients, and vigorously reasserts the doctrine that the indication of design in the universe is not special adaptations, but uniformity, and law, these being the evidences of mind, and not what appears to us to be a provision for our uses. While I decline to express any opinion here on this vexato quaestio, I ought not to mention Mr. Powell's volume without the acknowledgment due to the philosophic spirit which pervades generally the 3 essays composing it, forming in the case of one of them, The Unity of Worlds, an honourable contrast with the other dissertations, so far as they have come under my notice, which have appeared on either side of that controversy. End footnote. With regard to the modern philosophers, Leibniz and the Cartesians, whom I had cited as having maintained that the action of mind upon matter, so far from being the only conceivable origin of material phenomena, is itself inconceivable, the attempt to rebut this argument by asserting that the mode, not the fact, of the action of mind on matter was represented as inconceivable, is an abuse of the privilege of writing confidentially about authors without reading them. For any knowledge whatever of Leibniz would have taught those who thus speak of him that the inconceivability of the mode and the impossibility of the thing were in his mind convertible expressions. What was his famous principle of the sufficient reason, the very cornerstone of his philosophy, from which the pre-established harmony, the doctrine of monads, and all the opinions most characteristic of Leibniz were corollaries? It was that nothing exists, the existence of which is not capable of being proved and explained a priori. The proof and explanation in the case of contingent facts being derived from the nature of their causes, which could not be the causes unless there was something in their nature showing them to be capable of producing those particular effects. And this something which accounts for the production of physical effects he was able to find in many physical causes, but could not find it in any finite minds, which therefore he unhesitatingly asserted to be incapable of producing any physical effects whatever. Quote, "On ne saurait concevoir," he says, "une action réciproque de la matière et de l'intelligence l'un sur l'autre." End quote. And there is, therefore, he contends, no choice but between the occasional causes of the Cartesians and his own pre-established harmony, according to which there is no more connection between our volitions and our muscular actions than there is between 2 clocks which are wound up to strike at the same instant. But he felt no similar difficulty as to physical causes, and throughout his speculations, as in the passage I have already cited respecting gravitation, he distinctly refuses to consider as part of the order of nature any fact which is not explicable from the nature of its physical cause. With regard to the Cartesians, not Descartes, I did not make that mistake, though the reviewer of Dr. Tulloch's essay attributes it to me, I take a passage almost at random from Malebranche, who is the best known of the Cartesians, and though not the inventor of the system of occasional causes, is its principal expositor. In Part 2, Chapter 3 of his 6th book, having first said that matter cannot have the power of moving itself, he proceeds to argue that neither can mind have the power of moving it. Quote, "Quand on examine l'idée que l'on a de tous les esprits finis, on ne voit point de liaison nécessaire entre leur volonté et le mouvement de quelque corps que ce soit. On voit au contraire qu'il n'y en a point et qu'il n'y en peut avoir. There is nothing in the idea of finite mind which can account for its causing the motion of a body. On doit aussi conclure, si on veut raisonner selon les lumières, qu'il n'y a qu'un esprit créé qui puisse remuer quelque corps que ce soit comme cause véritable en principal, de même que l'on a dit qu'aucun corps ne se pouvait remuer soi-même." End quote. Thus, the idea of mind is according to him as incompatible as the idea of matter, with the exercise of active force. But when he continues, we consider not a created but a divine mind, the case is altered, for the idea of a divine mind includes omnipotence, and the idea of omnipotence does contain the idea of being able to move bodies. Thus, it is the nature of omnipotence which renders the motion of bodies, even by the divine mind, credible or conceivable, while, so far as depended on the mere nature of mind, it would have been inconceivable and incredible if Malebranche had not believed in an omnipotent being. He would have held all action of mind on body to be a demonstrated impossibility. Footnote. In the words of Fontenelle, another celebrated Cartesian, quote, Les philosophes aussi bien que le peuple avaient cru que l'âme et le corps agissant réellement et physiquement l'un sur l'autre. Descartes vint qui prouva que leur nature ne permettait point cette sorte de communication véritable et qu'ils n'en pouvaient avoir qu'une apparente, dont Dieu était le médiateur. End quote. Works of Fontenelle, 1767 edition, Book 5, page 534. End footnote. A doctrine more precisely the reverse of the volitional theory of causation cannot well be imagined. The volitional theory is that we know by intuition or by direct experience the action of our own mental volitions on matter, that we may hence infer all other action upon matter to be that of volition, and might thus know, without any other evidence, that matter is under the government of a divine mind. Leibniz and the Cartesians, on the contrary, maintain that our volitions do not and cannot act upon matter, and that it is only the existence of an all-governing being, and that being omnipotent, which can account for the sequence between our volitions and our bodily actions. When we consider that each of these two theories, which, as the theories of causation, stand at the opposite extremes of possible divergence from one another, invokes not only as its evidence, but as its sole evidence, the absolute inconceivability of any theory but itself, we are enabled to measure the worth of this kind of evidence. And when we find the volitional theory entirely built upon the assertion that by our mental constitution we are compelled to recognize our volitions as efficient causes, and then find other thinkers maintaining that we know that they are not and cannot be such causes, and cannot conceive them to be so, I think we have a right to say that this supposed law of our mental constitution does not exist. Dr. Tulloch, pages 45 through 47, thinks it a sufficient answer to this that Leibniz and the Cartesians were theists and believed the will of God to be an efficient cause. Doubtless they did, and the Cartesians even believed, though Leibniz did not, that it is the only such cause. Dr. Tulloch mistakes the nature of the question. I was not writing on theism, as Dr. Tulloch is, but against a particular theory of causation, which, if it be unfounded, can give no effective support to theism or to anything else. I found it asserted that volition is the only efficient cause, on the ground that no other efficient cause is conceivable. To this assertion I oppose the instances of Leibniz and of the Cartesians, who affirmed with equal positiveness that volition as an efficient cause is itself not conceivable, and that omnipotence, which renders all things conceivable, can alone take away the impossibility. This I thought, and think, a conclusive answer to the argument on which this theory of causation avowedly depends. But I certainly did not imagine that theism was bound up with that theory, nor expected to be charged with denying Leibniz and the Cartesians to be theists, because I denied that they held the theory. End of section 35. Section 36. of a System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 3, Chapter 6, On the Composition of Causes. Part 1. To complete the general notion of causation on which the rules of experimental inquiry into the laws of nature must be founded, one distinction still remains to be pointed out, a distinction so radical and of so much importance as to require a chapter to itself. The preceding discussions have rendered us familiar with the case in which several agents or causes concur as conditions to the production of an effect, a case, in truth, almost universal, there being very few effects to the production of which no more than one agent contributes. Suppose, then, that two different agents operating jointly are followed under a certain set of collateral conditions by a given effect. If either of these agents, instead of being joined with the other, had operated alone under the same set of conditions in all other respects, some effect would probably have followed which would have been different from the joint effect of the two, and more or less dissimilar to it. Now, if we happen to know what would be the effect of each cause when acting separately from the other, we are often able to arrive deductively or a priori at a correct prediction of what will arise from their conjunct agency. To render this possible, it is only necessary that the same law which expresses the effect of each cause acting by itself shall also correctly express the part due to that cause of the effect which follows from the two together. This condition is realized in the extensive and important class of phenomena commonly called mechanical, namely, the phenomena of the communication of motion, or of pressure, which is tendency to motion, from one body to another. In this important class of cases of causation, one cause never, properly speaking, defeats or frustrates another. Both have their full effect. If a body is propelled in two directions by two forces, one tending to drive it to the north and the other to the east, it is caused to move in a given time exactly as far in both directions as the two forces would separately have carried it, and it is left precisely where it would have arrived if it had been acted upon first by one of the two forces and afterward by the other. This law of nature is called, in dynamics, the principle of the composition of forces, and in imitation of that well-chosen expression, I shall give the name of the composition of causes to the principle which is exemplified in all cases in which the joint effect of several causes is identical with the sum of their separate effects. This principle, however, by no means prevails in all departments of the field of nature. The chemical combination of two substances produces, as is well known, a third substance with properties different from those of either of the two substances separately or of both of them taken together. Not a trace of the properties of hydrogen or of oxygen is observable in those of their compound, water. The taste of sugar of lead is not the sum of the tastes of its component elements, acetic acid and lead, or its oxide. Nor is the colour of blue vitriol a mixture of the colours of sulphuric acid and copper. This explains why mechanics is a deductive or demonstrative science, and chemistry not. In the one, we can compute the effects of combinations of causes, whether real or hypothetical, from the laws which we know to govern those causes when acting separately, because they continue to observe the same laws when in combination, which they observe when separate. Whatever would have happened in consequence of each cause taken by itself, happens when they are together, and we have only to cast up the results. Not so in the phenomena which are the peculiar subject of the science of chemistry. There, most of the uniformities to which the causes conform when separate cease altogether when they are conjoined, and we are not, at least in the present state of our knowledge, able to foresee what result will follow from any new combination until we have tried the specific experiment. If this be true of chemical combinations, it is still more true of those far more complex combinations of elements which constitute organized bodies, and in which those extraordinary new uniformities arise which are called the laws of life. All organized bodies are composed of parts similar to those composing inorganic nature, and which have even themselves existed in an inorganic state. But the phenomena of life, which result from the juxtaposition of those parts in a certain manner, bear no analogy to any of the effects which would be produced by the action of the component substances considered as mere physical agents. To whatever degree we might imagine our knowledge of the properties of the several ingredients of a living body to be extended and perfected, it is certain that no mere summing up of the separate actions of those elements will ever amount to the action of the living body itself. The tongue, for instance, is, like all other parts of the animal frame, composed of gelatine, fibrin, and other products of the chemistry of digestion. But from no knowledge of the properties of those substances could we ever predict that it could taste, unless gelatine or fibrin themselves taste. For no elementary fact can be in the conclusion which was not in the premises. There are thus two different modes of the conjunct action of causes, from which arise two modes of conflict or mutual interference between laws of nature. Suppose, at a given point of time and space, two or more causes which, if they acted separately, would produce effects contrary or at least conflicting with each other, one of them tending to undo, wholly or partially, what the other tends to do. Thus, the expansive force of the gases generated by the ignition of gunpowder tends to project a bullet towards the sky, while its gravity tends to make it fall to the ground. A stream running into a reservoir at one end tends to fill it higher and higher, while a drain at the other extremity tends to empty it. Now, in such cases as these, even if the two causes which are in joint action exactly annul one another, still the laws of both are fulfilled. The effect is the same as if the drain had been open for half an hour first, and the stream had flowed in for as long afterward. Footnote. I omit for simplicity to take into account the effect, in this latter case, of the diminution of pressure in diminishing the flow of water through the drain, which evidently in no way affects the truth or applicability of the principle, since, when the two causes act simultaneously, the conditions of that diminution of pressure do not arise. End footnote. Each agent produces the same amount of effect as if it had acted separately, though the contrary effect which was taking place during the same time obliterated it as fast as it was produced. Here, then, are two causes producing by their joint operations an effect which at first seems quite dissimilar to those which they produce separately, but which, on examination, proves to be really the sum of those separate effects. It will be noticed that we here enlarge the idea of the sum of two effects so as to include what is commonly called their difference, but which is in reality the result of the addition of opposites, a conception to which mankind are indebted for that admirable extension of the algebraical calculus which has so vastly increased its powers as an instrument of discovery, by introducing into its reasonings, with the sign of subtraction prefixed and under the name of negative quantities, every description whatever of positive phenomena, provided they are of such a quality in reference to those previously introduced, that to add the one is equivalent to subtracting an equal quantity of the other. There is then one mode of the mutual interference of laws of nature in which, even when the concurrent causes annihilate each other's effects, each exerts its full efficacy according to its own law as a separate agent. But in the other description of cases, the agencies which are brought together cease entirely, and a totally different set of phenomena arise, as in the experiment of two liquids which, when mixed in certain proportions, instantly become not a larger amount of liquid, but a solid mass. Part 2. This difference between the case in which the joint effect of causes is the sum of their separate effects, and the case in which it is heterogeneous to them, between laws which work together without alteration, and laws which, when called upon to work together, cease and give place to others, is one of the fundamental distinctions in nature. The former case, that of the composition of causes, is the general one. The other is always special and exceptional. There are no objects which do not, as to some of their phenomena, obey the principle on the composition of causes, none that have not some laws which are rigidly fulfilled in every combination into which the objects enter. The weight of a body, for instance, is a property which it retains in all the combinations in which it is placed. The weight of a chemical compound, or of an organized body, is equal to the sum of the weights of the elements which compose it. The weight either of the elements or of the compound will vary if they be carried farther from their center of attraction or brought nearer to it. But whatever effects the one effects the other. They always remain precisely equal. So again, the component parts of a vegetable or animal substance do not lose their mechanical and chemical properties as separate agents, when, by a peculiar mode of juxtaposition, they, as an aggregate whole, acquire physiological or vital properties in addition. Those bodies continue, as before, to obey mechanical and chemical laws, insofar as the operation of those laws is not counteracted by the new laws which govern them as organized beings. When, in short, a concurrence of causes takes place which calls into action new laws bearing no analogy to any that we can trace in the separate operation of the causes, the new laws, while they supersede one portion of the previous laws, may coexist with another portion, and may even compound the effect of those previous laws with their own. Again, laws which were themselves generated in the second mode may generate others in the first. Though there are laws which, like those of chemistry and physiology, owe their existence to a breach of the principle of composition of causes, it does not follow that these peculiar, or, as they might be termed, heteropathic laws, are not capable of composition with one another. The causes which by one combination have had their laws altered may carry their new laws with them unaltered into their ulterior combinations, and hence there is no reason to despair of ultimately raising chemistry and physiology to the condition of deductive sciences, for though it is impossible to deduce all chemical and physiological truths from the laws or properties of simple substances or elementary agents, they may possibly be deducible from laws which commence when these elementary agents are brought together into some moderate number of not very complex combinations. The laws of life will never be deducible from the mere laws of the ingredients, but the prodigiously complex facts of life may all be deducible from comparatively simple laws of life, which laws, depending indeed on combinations, but on comparatively simple combinations of antecedents, may, in more complex circumstances, be strictly compounded with one another, and with the physical and chemical laws of the ingredients. The details of the vital phenomena even now afford innumerable exemplifications of the composition of causes, and in proportion as these phenomena are more accurately studied, there appears more reason to believe that the same laws which operate in the simpler combinations of circumstances do, in fact, continue to be observed in the more complex. This will be found equally true in the phenomena of mind, and even in social and political phenomena, the results of the laws of mind. It is in the case of chemical phenomena that the least progress has yet been made in bringing the special laws under general ones, from which they may be deduced. But there are even in chemistry many circumstances to encourage the hope that such general laws will hereafter be discovered. The different actions of a chemical compound will never undoubtedly be found to be the sums of the actions of its separate elements, but there may exist between the properties of the compound and those of its elements some constant relation which, if discoverable by a sufficient induction, would enable us to foresee the sort of compound which will result from a new combination before we have actually tried it, and to judge of what sort of elements some new substance is compounded before we have analyzed it. The law of definite proportions, first discovered in its full generality by Dalton, is a complete solution of this problem in one, though but a secondary aspect, that of quantity. And in respect to quality, we have already some partial generalizations sufficient to indicate the possibility of ultimately proceeding further. We can predicate some common properties of the kind of compounds which result from the combination in each of the small number of possible proportions of any acid whatever with any base. We have also the curious law discovered by Berthollet that two soluble salts mutually decompose one another whenever the new combinations which result produce an insoluble compound or one less soluble than the two former. Another uniformity is that called the law of isomorphism, the identity of the crystalline forms of substances which possess in common certain peculiarities of chemical composition. Footnote. Professor Bain adds several other well-established chemical generalizations. Quote, the laws that simple substances exhibit the strongest affinities, that compounds are more fusible than their elements, that combination tends to a lower state of matter from gas down to solid, end quote, and some general propositions concerning the circumstances which facilitate or resist chemical combination. Logic 2, page 254. End footnote. Thus it appears that even heteropathic laws, such laws of combined agency as are not compounded of the laws of the separate agencies, are yet, at least in some cases, derived from them according to a fixed principle. There may therefore be laws of the generation of laws from others dissimilar to them, and in chemistry these undiscovered laws of the dependence of the properties of the compound on the properties of its elements may, together with the laws of the elements themselves, furnish the premises by which the science is perhaps destined one day to be rendered deductive. It would seem, therefore, that there is no class of phenomena in which the composition of causes does not obtain, that as a general rule, causes in combination produce exactly the same effects as when acting singly, but that this rule, though general, is not universal, that in some instances, at some particular points in the transition from separate to united actions, the laws change and an entirely new set of effects are either added to or take the places of those which arise from the separate agency of the same causes, the laws of these new effects being again susceptible of composition to an indefinite extent, like the laws which they superseded. Part 3. That effects are proportional to their causes is laid down by some writers as an axiom in the theory of causation, and great use is sometimes made of this principle in reasonings respecting the laws of nature, though it is encumbered with many difficulties and apparent exceptions, which much ingenuity has been expended in showing not to be real ones. This proposition, in so far as it is true, enters as a particular case into the general principle of the composition of causes, the causes compounded being, in this instance, homogeneous, in which case, if in any, their joint effect might be expected to be identical with the sum of their separate effects. If a force equal to 1 hundredweight will raise a certain body along an inclined plane, a force equal to 2 hundredweight will raise two bodies exactly similar, and thus the effect is proportional to the cause. But does not a force equal to 2 hundredweight actually contain in itself two forces each equal to 1 hundredweight, which, if employed apart, would separately raise the two bodies in question? The fact, therefore, that when exerted jointly they raise both bodies at once, results from the composition of causes, and is a mere instance of the general fact that mechanical forces are subject to the law of composition, and so in every other case which can be supposed. For the doctrine of the proportionality of effects to their causes cannot, of course, be applicable to cases in which the augmentation of the cause alters the kind of effect, that is, in which the surplus quantity superadded to the cause does not become compounded with it, but the two together generate an altogether new phenomenon. Suppose that the application of a certain quantity of heat to a body merely increases its bulk, that a double quantity melts it, and a triple quantity decomposes it. These three effects being heterogeneous, no ratio, whether corresponding or not to that of the quantities of heat applied, can be established between them. Thus, the supposed axiom of the proportionality of effects to their causes fails at the precise point where the principle of the composition of causes also fails, that is, where the concurrence of causes is such as to determine a change in the properties of the body generally, and render it subject to new laws, more or less dissimilar to those to which it conformed in its previous state. The recognition, therefore, of any such law of proportionality is superseded by the more comprehensive principle in which as much of it as is true is implicitly asserted. Footnote: Professor Bain, Logic 2:39, points out a class of cases other than that spoken of in the text, which he thinks must be regarded as an exception to the composition of causes. Quote, causes that merely make good the collocation for bringing a prime mover into action, or that release a potential force, do not follow any such rule. One man may direct a gun upon a fort as well as three. Two sparks are not more effectual than one in exploding a barrel of gunpowder. In medicine there is a certain dose that answers the end, and adding to it does no more good. End quote. I am not sure that these cases are really exceptions. The law of composition of causes, I think, is really fulfilled, and the appearance to the contrary is produced by attending to the remote instead of the immediate effect of the causes. In the cases mentioned, the immediate effect of the causes in action is a collocation, and the duplication of the cause does double the quantity of collocation. Two men could raise the gun to the required angle twice as quickly as one, though one is enough. Two sparks put two sets of particles of the gunpowder into the state of intestine motion, which makes them explode, though one is sufficient. It is the collocation itself that does not, by being doubled, always double the effect, because in many cases a certain collocation, once obtained, is all that is required for the production of the whole amount of effect which can be produced at all at the given time and place. Doubling the collocation with a difference of time and place, as by pointing 2 guns or exploding a second barrel after the first, does double the effect. This remark applies still more to Mr. Bain's third example, that of a double dose of medicine. For a double dose of an aperient does purge more violently, and a double dose of laudanum does produce longer and sounder sleep. But a double purging or a double amount of narcotism may have remote effects different in kind from the effect of the smaller amount, reducing the case to that of heteropathic laws discussed in the text. End footnote. The general remarks on causation, which seemed necessary as an introduction to the theory of the inductive process, may here terminate. That process is essentially an inquiry into cases of causation. All the uniformities which exist in the succession of phenomena and most of the uniformities in their coexistence are either, as we have seen, themselves laws of causation or consequences resulting from and corollaries capable of being deduced from such laws. If we could determine what causes are correctly assigned to what effects, and what effects to what causes, we should be virtually acquainted with the whole course of nature. All those uniformities which are mere results of causation might then be explained and accounted for, and every individual fact or event might be predicted, provided we had the requisite data, that is, the requisite knowledge of the circumstances which, in the particular instance, preceded it. To ascertain, therefore, what are the laws of causation which exist in nature, to determine the effect of every cause, and the causes of all effects, is the main business of induction, and to point out how this is done is the chief object of inductive logic. End of section 36. Section 37 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 3, Chapter 7, on Observation and Experiment. Part 1. It results from the preceding exposition that the process of ascertaining what consequents in nature are invariably connected with what antecedents, or in other words, what phenomena are related to each other as causes and effects, is in some sort a process of analysis. That every fact which begins to exist has a cause, and that this cause must be found in some fact or concourse of facts which immediately preceded the occurrence, may be taken for certain. The whole of the present facts are the infallible result of all past facts, and more immediately of all the facts which existed at the moment previous. Here, then, is a great sequence which we know to be uniform. If the whole prior state of the entire universe could again recur, it would again be followed by the present state. The question is, how to resolve this complex uniformity into the simpler uniformities which compose it, and assign to each portion of the vast antecedent the portion of the consequent which is attendant on it. This operation, which we have called analytical, inasmuch as it is the resolution of a complex whole into the component elements, is more than a merely mental analysis. No mere contemplation of the phenomena and partition of them by the intellect alone will of itself accomplish the end we have now in view. Nevertheless, such a mental partition is an indispensable first step. The order of nature, as perceived at a first glance, presents at every instant a chaos followed by another chaos. We must decompose each chaos into single facts. We must learn to see in the chaotic antecedent a multitude of distinct antecedents, in the chaotic consequent a multitude of distinct consequents. This, supposing it done, will not of itself tell us on which of the antecedents each consequent is invariably attendant. To determine that point, we must endeavour to effect a separation of the facts from one another, not in our minds only, but in nature. The mental analysis, however, must take place first, and everyone knows that in the mode of performing it, one intellect differs immensely from another. It is the essence of the act of observing, for the observer is not he who merely sees the thing which is before his eyes, but he who sees what parts that thing is composed of. To do this well is a rare talent. One person, from inattention, or attending only in the wrong place, overlooks half of what he sees. Another sets down much more than he sees, confounding it with what he imagines or with what he infers. Another takes note of the kind of all the circumstances, but, being inexpert in estimating their degree, leaves the quantity of each vague and uncertain. Another sees indeed the whole, but makes such an awkward division of it into parts, throwing things into one mass which require to be separated, and separating others which might more conveniently be considered as one, that the result is much the same, sometimes even worse than if no analysis had been attempted at all. It would be possible to point out what qualities of mind and modes of mental cultures fit a person for being a good observer. That, however, is a question not of logic, but of the theory of education in the most enlarged sense of the term. There is not properly an art of observing. There may be rules for observing, but these, like rules for inventing, are properly instructions for the preparation of one's own mind, for putting it into the state in which it will be most fitted to observe or most likely to invent. They are, therefore, essentially rules of self-education, which is a different thing from logic. They do not teach how to do the thing, but how to make ourselves capable of doing it. They are an art of strengthening the limbs, not an art of using them. The extent and minuteness of observation which may be requisite, and the degree of decomposition to which it may be necessary to carry the mental analysis, depend on the particular purpose in view. To ascertain the state of the whole universe at any particular moment is impossible, but would also be useless. In making chemical experiments, we do not think it necessary to note the position of the planets, because experience has shown, as a very superficial experience is sufficient to show, that in such cases that circumstance is not material to the result, and accordingly, in the ages when men believed in the occult influences of heavenly bodies, it might have been unphilosophical to omit ascertaining the precise condition of those bodies at the moment of the experiment. As to the degree of minuteness of the mental subdivision, if we were obliged to break down what we observe into its very simplest elements, that is, literally, into single facts, it would be difficult to say where we should find them. We can hardly ever affirm that our divisions of any kind have reached the ultimate unit, but this too is fortunately unnecessary. The only object of the mental separation is to suggest the requisite physical separation, so that we may either accomplish it ourselves or seek for it in nature. And we have done enough when we have carried the subdivision as far as the point at which we are able to see what observations or experiments we require. It is only essential, at whatever point our mental decomposition of facts may for the present have stopped, that we should hold ourselves ready and able to carry it further as occasion requires, and should not allow the freedom of our discriminating faculty to be imprisoned by the swathes and bands of ordinary classification, as was the case with all early speculative inquirers, not excepting the Greeks, to whom it seldom occurred that what was called by one abstract name might, in reality, be several phenomena, or that there was a possibility of decomposing the facts of the universe into any elements but those which ordinary language already recognized. Part 2. The different antecedents and consequents being, then, supposed to be, so far as the case requires, ascertained and discriminated from one another, we are to inquire which is connected with which. In every instance which comes under our observation, there are many antecedents and many consequents. If those antecedents could not be severed from one another except in thought, or if those consequents never were found apart, it would be impossible for us to distinguish, a posteriori at least, the real laws, or to assign to any cause its effect, or to any effect its cause. To do so, we must be able to meet with some of the antecedents apart from the rest, and observe what follows from them, or some of the consequents, and observe by what they are preceded. We must, in short, follow the Baconian rule of varying the circumstances. This is indeed only the first rule of physical inquiry, and not, as some have thought, the sole rule. But it is the foundation of all the rest. For the purpose of varying the circumstances, we may have recourse, according to a distinction commonly made, either to observation or to experiment. We may either find an instance in nature suited to our purposes, or, by an artificial arrangement of circumstances, make one. The value of the instance depends on what it is in itself, not on the mode in which it is obtained. Its employment for the purposes of induction depends on the same principles in the one case and in the other, as the uses of money are the same whether it is inherited or acquired. There is, in short, no difference in kind, no real logical distinction between the two processes of investigation. There are, however, practical distinctions to which it is of considerable importance to advert. Part 3. The first and most obvious distinction between observation and experiment is that the latter is an immense extension of the former. It not only enables us to produce a much greater number of variations in the circumstances than nature spontaneously offers, but also, in thousands of cases, to produce the precise sort of variation which we are in want of for discovering the law of the phenomenon, a service which nature, being constructed on a quite different scheme from that of facilitating our studies, is seldom so friendly as to bestow upon us. For example, in order to ascertain what principle in the atmosphere enables it to sustain life, the variation we require is that a living animal should be immersed in each component element of the atmosphere separately. But nature does not supply either oxygen or azote in a separate state. We are indebted to artificial experiment for our knowledge that it is the former and not the latter which supports respiration, and for our knowledge of the very existence of the two ingredients. Thus far, the advantage of experimentation over simple observation is universally recognized. All are aware that it enables us to obtain innumerable combinations of circumstances which are not to be found in nature, and so add to nature's experiments a multitude of experiments of our own. But there is another superiority, or, as Bacon would have expressed it, another prerogative, of instances artificially obtained over spontaneous instances, of our own experiments over even the same experiments when made by nature, which is not of less importance, and which is far from being felt and acknowledged in the same degree. When we can produce a phenomenon artificially, we can take it, as it were, home with us, and observe it in the midst of circumstances with which in all other respects we are accurately acquainted. If we desire to know what are the effects of the cause A, and are able to produce A by means at our disposal, we can generally determine at our own discretion, so far as is compatible with the nature of the phenomenon A, the whole of the circumstances which shall be present along with it, and thus, knowing exactly the simultaneous state of everything else which is within the reach of A's influence, we have only to observe what alteration is made in that state by the presence of A. For example, by the electric machine we can produce, in the midst of known circumstances, the phenomena which nature exhibits on a grander scale in the form of lightning and thunder. Now, let any one consider what amount of knowledge of the effects and laws of electric agency mankind could have obtained from the mere observation of thunderstorms, and compare it with that which they have gained and may expect to gain from electrical and galvanic experiments. This example is the more striking now that we have reason to believe that electric action is, of all natural phenomena except heat, the most pervading and universal, which therefore it might antecedently have been supposed could stand least in need of artificial means of production to enable it to be studied, while the fact is so much the contrary that without the electric machine, the Leyden jar, and the voltaic battery, we probably should never have suspected the existence of electricity as one of the great agents in nature. The few electric phenomena we should have known of would have continued to be regarded either as supernatural or as a sort of anomalies and eccentricities in the order of the universe. When we have succeeded in insulating the phenomenon which is the subject of inquiry, by placing it among known circumstances, we may produce further variations of circumstances to any extent, and of such kinds as we think best calculated to bring the laws of the phenomenon into a clear light. By introducing one well-defined circumstance after another into the experiment, we obtain assurance of the manner in which the phenomenon behaves under an indefinite variety of possible circumstances. Thus, chemists, after having obtained some newly discovered substance in a pure state, that is, having made sure that there is nothing present which can interfere with and modify its agency, introduce various other substances, one by one, to ascertain whether it will combine with them or decompose them, and with what result, and also apply heat or electricity or pressure to discover what will happen to the substance under each of these circumstances. But if, on the other hand, it is out of our power to produce the phenomenon, and we have to seek for instances in which nature produces it, the task before us is very different. Instead of being able to choose what the concomitant circumstances shall be, we now have to discover what they are, which, when we go beyond the simplest and most accessible cases, it is next to impossible to do with any precision and completeness. Let us take, as an exemplification of a phenomenon which we have no means of fabricating artificially, a human mind. Nature produces many, but the consequence of our not being able to produce them by art is, that in every instance in which we see a human mind developing itself, or acting upon other things, we see it surrounded and obscured by an indefinite multitude of unascertainable circumstances, rendering the use of the common experimental methods almost delusive. We may conceive to what extent this is true if we consider, among other things, that whenever nature produces a human mind, she produces, in close connection with it, a body, that is, a vast complication of physical facts, in no two cases perhaps exactly similar, and most of which, except the mere structure which we can examine in a sort of coarse way after it has ceased to act, are radically out of the reach of our means of exploration. If, instead of a human mind, we suppose the subject of investigation to be a human society or state, all the same difficulties recur in a greatly augmented degree. We have thus already come within sight of a conclusion, which the progress of the inquiry will, I think, bring before us with the clearest evidence, namely, that in the sciences which deal with phenomena in which artificial experiments are impossible, as in the case of astronomy, or in which they have a very limited range, as in mental philosophy, social science, and even physiology, induction from direct experience is practiced at a disadvantage, in most cases equivalent to impracticability, from which it follows that the methods of those sciences, in order to accomplish anything worthy of attainment, must be to a great extent, if not principally, deductive. This is already known to be the case with the first of the sciences we have mentioned, astronomy. That it is not generally recognized as true of the others is probably one of the reasons why they are not in a more advanced state. Part 4. If what is called pure observation is at so great a disadvantage compared with artificial experimentation in one department of the direct exploration of phenomena, there is another branch in which the advantage is all on the side of the former. Inductive inquiry, having for its object to ascertain what causes are connected with what effects, we may begin this search at either end of the road which leads from the one point to the other. We may either inquire into the effects of a given cause or into the causes of a given effect. The fact that light blackens chloride of silver might have been discovered either by experiments on light, trying what effect it would produce on various substances, or by observing that portions of the chloride had repeatedly become black, and inquiring into the circumstances. The effect of the Urali poison might have become known either by administering it to animals or by examining how it happened that the wounds which the Indians of Guiana inflict with their arrows prove so uniformly mortal. Now, it is manifest from the mere statement of the examples, without any theoretical discussion, that artificial experimentation is applicable only to the former of these modes of investigation. We can take a cause and try what it will produce, but we cannot take an effect and try what it will be produced by. We can only watch till we see it produced, or are enabled to produce it by accident. This would be of little importance if it always depended on our choice from which of the two ends of the sequence we would undertake our inquiries. But we have seldom any option, as we can only travel from the known to the unknown. We are obliged to commence at whichever end we are best acquainted with. If the agent is more familiar to us than its effects, we watch for or contrive instances of the agent under such varieties of circumstances as are open to us, and observe the result. If, on the contrary, the conditions on which a phenomenon depends are obscure, but the phenomenon itself familiar, we must commence our inquiry from the effect. If we are struck with the fact that chloride of silver has been blackened, and have no suspicion of the cause, we have no resource but to compare instances in which the fact has chanced to occur, until by that comparison we discover that in all those instances the substances had been exposed to light. If we knew nothing of the Indian arrows but their fatal effect, accident alone could turn our attention to experiments on the Urali. In the regular course of investigation, we could only inquire or try to observe what had been done to the arrows in particular instances. Wherever, having nothing to guide us to the cause, we are obliged to set out from the effect, and to apply the rule of varying the circumstances to the consequents, not the antecedents, we are necessarily destitute of the resource of artificial experimentation. We cannot, at our choice, obtain consequents, as we can antecedents, under any set of circumstances compatible with their nature. There are no means of producing effects but through their causes, and by the supposition the causes of the effect in question are not known to us. We have therefore no expedient but to study it where it offers itself spontaneously. If nature happens to present us with instances sufficiently varied in their circumstances, and if we are able to discover either among the proximate antecedents or among some other order of antecedents something which is always found when the effect is found, however various the circumstances, and never found when it is not, we may discover by mere observation without experiment a real uniformity in nature. But though this is certainly the most favourable case for sciences of pure observation, as contrasted with those in which artificial experiments are possible, there is in reality no case which more strikingly illustrates the inherent imperfection of direct induction when not founded on experimentation. Suppose that, by a comparison of cases of the effect, we have found an antecedent which appears to be, and perhaps is, invariably connected with it. We have not yet proved that antecedent to be the cause until we have reversed the process and produced the effect by means of that antecedent. If we can produce the antecedent artificially, and if, when we do so, the effect follows, the induction is complete. That antecedent is the cause of that consequent. Footnote. Unless indeed the consequent was generated not by the antecedent, but by the means employed to produce the antecedent. As, however, these means are under our power, there is so far a probability that they are also sufficiently within our knowledge to enable us to judge whether that could be the case or not. End footnote. But we have then added the evidence of experiment to that of simple observation. Until we had done so, we had only proved invariable antecedents within the limits of experience, but not unconditional antecedents or causation. Until it had been shown by the actual production of the antecedent under known circumstances, and the occurrence thereupon of the consequent, that the antecedent was really the condition on which it depended, the uniformity of succession which was proved to exist between them might, for aught we knew, be, like the succession of day and night, not a case of causation at all. Both antecedent and consequent might be successive stages of the effect of an ulterior cause. Observation, in short, without experiment, supposing no aid from deduction, can ascertain sequences and coexistences, but cannot prove causation. In order to see these remarks verified by the actual state of the sciences, we have only to think of the condition of natural history. In zoology, for example, there is an immense number of uniformities ascertained, some of coexistence, others of succession, to many of which, notwithstanding considerable variations of the attendant circumstances, we know not any exception. But the antecedents for the most part are such as we cannot artificially produce, or, if we can, it is only by setting in motion the exact process by which nature produces them, and this being to us a mysterious process, of which the main circumstances are not only unknown but unobservable, we do not succeed in obtaining the antecedents under known circumstances. What is the result? That on this vast subject, which affords so much and such varied scope for observation, we have made most scanty progress in ascertaining any laws of causation. We know not with certainty, in the case of most of the phenomena that we find conjoined, which is the condition of the other, which is cause and which effect, or whether either of them is so, or they are not rather conjunct effects of causes yet to be discovered, complex results of laws hitherto unknown. Although some of the foregoing observations may be, in technical strictness of arrangement, premature in this place. It seemed that a few general remarks on the difference between sciences of mere observation and sciences of experimentation, and the extreme disadvantage under which directly inductive inquiry is necessarily carried on in the former, were the best preparation for discussing the methods of direct induction, a preparation rendering superfluous much that must otherwise have been introduced, with some inconvenience, into the heart of that discussion. To the consideration of these methods we now proceed. End of section 37.